Good morning, my dear NEET warriors. Hello, Pratyusha, Vishal. Welcome, Krishna. Hello, Kamesh. Hello, Navya. Hello, Sebastian. I hope I'm audible as well as visible to all of you. Yes, looks like it. Good morning, good morning. So, last lecture was the first part where we did the 11th standard PYQs from 2019 to 2023. There were lots of them. And if you remember, this was the last PYQ which we did from Waves Oscillation chapter, the last chapter of your 11th standard syllabus. Now, today we will do the 12th standard PYQs from 2019 to 2023. All the PYQs done over here. So, next time when you are solving a question and you are stuck in a particular chapter, you can always refer to this particular video. Yes, Shreyas sir has done this. Right? So that is the whole purpose of this particular live class out here. Good morning, Dikshant. Let's begin. All right. So here comes the first question on electrostatics, and what does it say? It says, according to Gauss's law of electrostatics, the electric flux through a closed surface depends on what? That's the question. And as you're answering, remember, you have to go down there and smash that like button. Right? Do that. And if you have not yet subscribed to the Vedantu NEET English channel, do it right away before you begin the class. Yes, if you have done it, very good. Proud of all of you. Become the subscriber so that you do not miss any lectures, you do not miss any updates which are going to come up for your upcoming NEET 2024 examination. Right? Cool. So all the warrior Pandus have assembled and everybody is saying option B. Yes, sir. The correct answer is B. Why is that answer B? Think about it. According to the Gauss's law of electrostatics, the flux through a closed surface depends on the charge which is inside the surface, not outside. So there could be some charges inside. These are the inside charges. The flux is because of them. Whatever charges are there outside, they do not contribute in the flux. So that was your Gauss law. The total flux in a closed surface is the total charge inside by epsilon naught. Hence option B for biology is correct. Moving to the next one. A charge is placed at the center of the cube, then the flux coming through any of its face will be how much? That is the question. So let's quickly imagine a cube. Let's quickly imagine a cube like this. Let's quickly imagine. Okay, so this is our cube. Perfecto. And you have placed a charge at the center somewhere over here. There is a charge. What will that charge do? That charge will give flux here, it 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 will give flux here, and it will also give flux here. It will give flux equally in all the directions. Is that right, my dear warriors? It will give flux in all the possible directions. Is that right? Very good. So the total flux will be Q by epsilon naught. So the flux through any one of the face, because there are 1, 2, 3, 4, 5, 6 faces. 4 here, 1 on the top, 1 below. 6 faces. So each face will get 1/6 of the total flux. So it will be 1/6 of the total flux, right? And what is the charge given? What is the charge given? It is given to be Q coulombs. So that's it. So the answer will have 1/6 in the option, right? So it is option number D, I believe. Yes, option number D, because it was Q microcoulomb. Micro means 10 to the power minus 6. So that's why that 10 to the power minus 6 has come. Remember, this Q is capital Q into 10 to the power minus 6. So substitute it over there. Everybody got it? Very good. D for doctor. Very good. D for Ames Delhi also. Yeah. Yes, it will be 10 to the power minus 6. Yes, Santomani. Definitely. The small q is the charge. That small q is capital Q microcoulomb. Micro is 10 to the power minus 6. So, in the end, you have to put it. Next, in a conducting sphere of radius r, if it is charged, then the electric field at a distance larger than the radius from the center of the sphere would be if V is the potential. The question is asked in terms of the potential minded. For a conducting sphere which is charged, the field is asked. So let us quickly draw a conducting sphere. And for a conducting sphere, remember the charges are always on the surface of the sphere, always on the surface of the sphere. Is that right? That's how it will be. And now you are basically at a distance r which is more than the radius. At this point, what is the electric field? The electric field at that point is simply given by k into the charge which is there divided by small r square. Because you are outside, all the charge feels like it is concentrated at the center. All the charge feels like it is concentrated at the center. So from a point charge at a distance small r, this is the electric field. But you have to answer in terms of potential. You have to answer in terms of potential. If it is given, V is the potential on the surface of the sphere. So if you talk about the potential on the surface of the sphere, it will be KQ divided by capital R. Therefore, K into Q is basically VR. K into Q is basically VR. Is that right? Everybody with me? So substitute it over here. Substitute it over here. You will get VR over here and you will get small r square below. Instead of KQ, I am just putting VR over here. So that is the electric field, which is VR by small r square, which is option number C for Captain Shreyas. I hope you wrote C for Captain Shreyas. Yes. Madhumita Ramesh, good. You have the exam on April 4th. Wow, that is like really early. That means you are the front runner. You are the front warrior. You are going to face all the brunt. I hope you prepare really well. All the best, Madhumita. Yes, Pratusha, C for Capto. Yes, Subita. Hello, Kitty. Also saying C. Krishna also saying C. Santimuni also saying C. Vishal. No, not D. It is C. Okay. I think you have to read the question carefully. If you miss any word, like it was potential on the surface, it was clearly mentioned potential on the surface. If you miss that word surface, you will get a wrong answer. You will put capital R as small r and you will get option D. So that is the catch. Many people get confused between capital R and small r. Moving to the next one. The electric dipole is placed at an angle of 30 degrees with an electric field of intensity so and so. It experiences torque. Calculate the magnitude of the charge on the dipole if the dipole length is given to be basically 2 centimeters. Now, in such kind of questions, when you have a dipole which is placed in electric field, this is your dipole moment, this is the angle, right? So, this was the positive charge, this was the negative charge. So, the torque acting on it is given by PE sine theta. That is the torque acting on a dipole. P cross E, cross product means sine theta. Now the dipole moment is the charge into the separation, Q into L. Q into L is basically the dipole moment. E is E only, and instead of theta I will have sine 30 and here I will have torque. The question is find the magnitude of the charge. That means you have to find Q. That means it will be torque as it is. Bring all these people down. So L into E into sine theta. So substitute everything. The torque is how much? 4 Newton meter. The length of the dipole is 2 centimeter. That means 2 into 10 to the power minus 2. Electric field is 2 into 10 to the power minus 5. And this was sine theta, which is sine of 30 degrees. Sine 30 is half. So put half over here. Just do the math and see what you get as the answer. Even you don't have to worry about the powers of 10. This 2 gets cancelled. 4 by 2 is 2. So the answer should be 2. So which is basically option C. Yes, I don't even have to bother about the powers. Remember that. Don't even bother about the powers. Automatically you will get the answer, right? So it will be 2 millicoulomb. So that is the answer. I think I put 10 to the power minus 5. It was 10 to the power plus 5. Sorry. This was 10 to the power plus 5. So the answer is going to be 2 millicoulomb. Is that clear? Now, many people, let me remind you, get confused. Sir, should I use dipole moment as charge into 2L or should I use the dipole moment as charge into length? Will you use first or will you use second? Tell me in the chat box, 1 or 2. 1 or 2. Quickly put it up in the chat box. Are you going to use the first one or the second formula? Quickly let me know. Q into L or Q into 2L? In NCERT it is given as Q into 2L, where L is half the length between the dipole. But I feel that is very confusing. Half the length of the dipole is L, the actual length is 2L. It leads to a lot of confusion. So always in NEET, in boards, okay, whatever you had to do, you have done. In NEET, use Q into L, and the length is the actual length between negative and the positive charge. Between negative and the positive charge. Don't use this, okay? So try to avoid this. Use this formula for your NEET examination, okay? In one, you will see that is there in NCERT. It is going to lead to unnecessary confusion. Why do you want to say 2L is equal to the separation? Just say L is separation. It will lead to confusion, right? Okay. Integral of electric field with area, cyclic integral means closed surface, is 0, happens to be 0. This was in NEET 2022. Then which of the following statements is correct? This is direct application of the Gauss law. So think about it. You have a Gaussian surface. You have a closed surface. You have a closed surface. And I tell you the total flux is 0. The total, this is nothing but the total flux is basically, the total flux is 0. What does it mean? What does it mean? It just means that whatever field lines are coming in are going out. Whatever is coming in is going out. Whatever is coming in is going out. If in is equal to out, remember, field lines coming in will negative flux and field lines going out will be positive flux. So the negative flux is equal to the positive flux. That is why the total flux is 0, and this means it should be option D for doctor. It should be option D for doctor. Yes, perfecto, Monisha. Excelente, Subita. Perfecto, perfecto. Amazingo, amazingo. Yeah, simple, easy peasy. This was asked in NEET 2022. You can see a lot of questions are being asked from Gauss's law and basic electrostatics. Unnecessarily don't waste your time in complicated geometries, complex problems of electrostatics. You can see the questions are very straightforward, direct, based on concept, application and formulas, right? So what does this say? There is a dipole, as shown the potential at a point P due to the dipole is how much? Now many people will think, sir, can I use the potential due to dipole formula, which is Kp cos theta divided by R square. What do you say? Can you use the direct formula of dipole in this problem? That is the trick which they had put for the NEET 2023 aspirants. Read the question carefully, look at the diagram, you will realize this dipole is not short. Short dipole means the charges are very close to each other and the point under observation is very far from these charges. This is 5 centimeters, not very far. This is 6 centimeters, not a short dipole. So you cannot use short dipole formulas. So can't use short dipole, formulas. That is very, very important for this particular question. Is that right? Now understand, to solve this question you need to find the potential due to this, find the potential due to this. If you notice this separation, if this is 5 and this is 3, obviously this is 2 centimeter. If this is 3, this is 5, this total separation is obviously 8 centimeter. Everybody gets it? This is 2 and this is 8, right? Very good. So now when you find the total potential, find the potential due to plus Q as well as due to minus Q separately. So this will be KQ divided by, is the charge given? Question is due to the dipole is how much? Okay, charge is not given, I just put it as Q. And then the separation is basically, yes, the separation is basically 2 centimeters. So this is nothing but 2 into 10 to the power minus 2 plus K into minus Q, the whole thing divided by 8 centimeters, which is 8 into 10 to the power minus 2. If you convert it into meters, you can see KQ and 10 to the power 2 is common, and I have 1 by 2 plus 1 by 8 over here. 1 by 2 from here, 1 by 8 from here, right? And I think I should put a minus sign. So half minus 1 by 8. So it will become KQ into 10 to the power 2, because 10 to the power minus 2 went on the top. That's why it is positive power. So LCM is 8 LCM is 8, 2 goes with 8 4 times minus 1. So this will become kq into 10 to the power 2. 4 minus 1 is 3. 4 minus 1 is 3 and you will have 8 over here. So it will become 3kq by 8 into 10 to the power 2, and in 10 to the power 2 volts is asked. So you can think of it like this: 3kq divided by 8 into 10 to the power 2. This is volts. So only this number is asked. Only this number is asked. So which is option number D. Option number D. You can clearly see in 10 to the power 2 volts. So this is that 10 to the power 2 volts. This is that number which they are basically asking you. Got it, my dear warriors? Very good. Awesomeness. Perfecto. Let's wake up all the students quickly, because Shreyas sir is making all the students practice all the PYQs. In this channel, I am telling you, whatever we do will ensure that even the student who is getting 200 marks, 300 marks will be so satisfied and happy once you come out of the exam hall on 5th of May. Because that is the challenge we have taken up for all of you. And you know, the reason why we take up small tasks is because it feels doable. I want every student in this country and even abroad who is preparing for NEET examination should get that confidence that yes, I can do it, yes, this is possible, and does not simply give up. And when we make up these challenges for all of you, okay, 2 days, okay, 2 days only I have to study, okay, 4 days only I have to study, okay, 1 week only I have to study, it feels like, okay, let's give it a try. And in that process of giving it a try, the student feels like, okay, maybe, you know what, it was not so bad, maybe I can actually do this. And that is exactly the feeling I want you to get. And if you are getting this feeling slowly, trust me, you are on the right path. And if you already had that confidence, then even better. These questions will serve like an ultimate practice for all of you, no doubt about it. Moving to the next one. 6 charges are given, corners of the hexagon. The work done in bringing the charge Q0 to the center of the hexagon from infinity is question mark. Think about it. What is the work done to bring all these charges from infinity? What do you do in this particular question? I'll tell you what, just visualize this slightly in 3 dimensions. Just imagine they are very far away. This Q0 is very far away. This Q0 is very far away. Just visualize this in 3 dimensions. I'm just drawing these lines so that you appreciate they are away from these charges. Now imagine this charge Q0 is coming from infinity. It is coming from infinity and coming to the center. Are you able to visualize this? There will be potential due to Q, due to minus Q, due to Q, due to minus Q, due to Q, due to minus Q, due to Q, minus Q. So what will be the total potential at any point? At any point it will be 0, because the amount of positiveness and the amount of negativeness is equal. So won't it be a big fat 0? No matter where you are, basically it is everywhere on the axis. Everywhere you go on the axis, imagine this hexagon, you go on the axis, everywhere the potential is 0. So basically, can I also say the potential difference is going to be 0? Therefore, can I say the work done will be 0? So where is the 0 option over here? B for Baswa sir, biology. Big fat 0. Yes, Krishna. It is going to be a big fat 0. That is the answer. NEET 2022 question. Imagine the students who thought this was a difficult question. They thought, sir, 6 is there, sir. Sir, root 2 is there, sir. Sir, minus q square. I thought it is going to be difficult. But that is the whole point, my dear students. It just seems difficult. Physics feels difficult, but actually 80 to 70% of the questions are very simple, easy peasy, lemon squeezy. Easy peasy, lemon squeezy kind of question. So you have to cross that hill. You have to cross that potential barrier. Only then you will see, oh my God, it's so beautiful. It is so simple. Moving ahead. Next question. The angle between the electric lines of force and the equipotential surface. This is straightforward. I want everybody to spam this answer. This was asked in your NEET 2022 examination. What is the answer for this, my dear students? When you talk about equipotential surface where the potential is basically constant, you will have equipotential lines like this. You will have electric field lines like this. You will have electric field lines like this. They are always going to be perpendicular. That means 90 degree. And did we see the spam in the chat box? C for Captain. Very good, Surya, Subita, Sumati, Krishna, Rubita, Hello Kitty. Yes, yes. Shri, the reason why you feel easy when you solve it with me is because you are going with the flow. Everybody is there. The mood is built up. When you are trying it solo, you feel it is difficult. It's the same thing which happens when you first learned bicycle. Maybe your dad or your mom or your elder brother or some friend used to always hold you, right? Always hold you when you were riding the bicycle. Initially, when you're learning how to balance and all of that. But the day when you first rode it solo, you were so scared. Oh, nobody's there behind. What to do? What if I fall? All these thoughts are coming in your mind and maybe you lose your balance. So that's what happens when you try out solo and sit for practice. So it's just a matter of habit and practice before you learn to excel solving these problems. Okay, just like riding the bicycle. Moving on to the next question coming up on your screen. Here it is. Two hollow conducting spheres of radius R1 and R2 have equal charges. The potential would be, come on my dear students, two hollow conducting spheres radius R1 and R2. R1 is large, but their charges are equal. The potential will be, think about it, potential formula is KQ divided by R. The one which has larger R has smaller potential. So guys, it's very straightforward. It is inversely proportional. So it will be more on the smaller sphere or less on the bigger sphere. Equal? No. Depends on the material? No. More on the big? No. Definitely not. Direct formula KQ by R. This was also a straightforward question. Correcto. Yes. Crash course antimony. Crash course started long time back. The day probably you were maybe as a student or something. So lot of crushes are there. Like sometimes you can see some students, you know, saying hello, love you, what is your mobile number, what is your style number, everything they ask. So crash course has started long time back, but crash course 5.0, that option is still there. It is there for 1999 rupees. Link is there in the description, or you can go to the channel trailer. You will see the entire video is there where I have explained beautifully what is the crash course. So you can choose both the options. Crash course is also there. Crash course is also there. Both options I have given you. Okay, cool. Next one. 2-point charges are placed at a distance of L as shown in the figure. The magnitude of the electric field at a distance much larger. Guys, this is a short dipole question. This is a short dipole question. I think we can use our formulas now. We are allowed. We are allowed. So what is the question? The magnitude of the field is proportional to magnitude of the field. Remember, the field is always like K, P. You will have 3 cos square theta plus 1 divided by R cube. R cube. Guys, it's option B for biology. Yes, perfecto. B for Baswa sir. Perfect. Excelente. Excelente. All right. Great. Perfect. Moving ahead to the next question on your screen. NEET 2021. Polar molecules. We have polar bears. Now these are polar molecules, but they do not stay in the North Pole or South Pole. They are there everywhere around you. Are the molecules having permanent, zero, acquire something or acquire moment when magnetic field is absent? What do you think is the right answer for this? Polar molecules, like your water molecule is polar. There is separation of charges. That is a polar molecule. When do they acquire polarity? Under some condition? No, they are always polar because of, you know, the electron cloud shifts to the more electronegative atom, right? It is going to absorb more of the negative charges, so the cloud will shift. So that is why the polarities develop in the first place. So it will always have the permanent electric dipole moment. NEET 2021 question. Very good. Excellent, my dear students. Proud of all of you. Keep it up, keep it up. Moving ahead to the next one on your screen. The dipole is placed in an electric field as shown, in which, oops, did I accidentally show the answer? Okay, no problem. Now that you have seen the answer, I will explain this to you. A dipole is placed in electric field as shown, in which direction will it move? You can see the electric field lines are diverging. It's not a uniform field. So it is a non-uniform field. It is a non-uniform field. So force will also not be the same. So understand, here the field lines are closer, so it will be strong field over here. Here it will be a weak field. So strong field will give a large force. Weak field will give a small force. So the forces on the negative and on the positive are not equal. So that's why the total force will be in this direction. This will be the net force. This will be the net force. Towards the right, as the potential energy will decrease, it is understood the potential decreases in the direction of the field. High potential, low potential, low potential, lower potential, even lower potential. So it will be towards the right side. That is very straightforward. Let's go to the next NEET 2021 question, guys. Electrostatics is a high weighted chapter for your NEET, like you can see. So many questions have been asked. Here comes the next one. Two spherical conductors of radius R1 and R2 are connected by a wire. The ratio of the surface charge densities of the spheres are. Whenever you connect two spheres of any size, shape, whatever, then you will see the potentials are going to be equal. V1 is equal to V2. That is the criteria. Only then the charges will stop moving from here to here. And when this happens, okay, you can say V1 is nothing but K Q1 divided by R1, and this is nothing but K Q2 divided by basically R2. Now charge, I can, by the way, KK will get cancelled. So Q1 by Q2 will be nothing but R1 by R2. Now this charge, can I say, think about it, charge density being charge by area, therefore can I say charge is charge density into area, So instead of Q, can I write charge density into area, which is 4 pi R1 square, and same thing, charge density into the area, which is 4 pi R2 square. That is what I have written down the charge as, because sigma is Q by area, Q is sigma into area. Just bring that area on the top. Area is the surface area of a sphere. This is basically R1 by R2. 4 pi cancels. Sigma 1 by sigma 2. R1 and R1 will also cancel. 1 R1 will remain, 1 R2 will remain, is 1 by 1. So sigma 1 by sigma 2 is R2 by R1. Yes. Option C. I hope you got the sigma is correct. Sigma 1 by sigma 2 is R2 by R1. R2 by R1. Is that clear? So remember, whenever you connect two conductors together, their potentials become equal, and potential formula is KQ by R. Just use that formula and replace the charge with a charge density. Replace the charge with charge density into area over here. That's what I have done. Everything else is simple mathematics. Moving to the next one. 27 drops are charged. They combine to form a bigger drop. Calculate the potential of the bigger drop. That is the question. That is the question, my dear warriors. So how do we do this part? First of all, let's visualize. 27 drops are there. So each drop will have a small radius. Let's say I call it R. And like that, 27 drops are there. And that will give me a big drop of a new radius like this. Each of them is at 220 volts. Let's say I put over here 220 volts. They form a bigger drop. Calculate the potential of the bigger drop. Now, in order to find the potential of the bigger drop, I will need two things. I will need the new radius, number one. Number two, I will also need the total charge on it. So imagine each of these drops had a small charge of Q. Then the total charge on the big drop will be 27 times of small q. 27 times of small q. Everybody with me, understanding? Also, because I have combined 27 drops to form a bigger drop, the total volume should add up. So the volume of this bigger drop is 4 by 3 pi capital R cube. The volume of these small drops is 4 by 3 pi small r cube, but 27 of them gives you the total volume. 4 by 3 pi cancels out. So r cube into 27, 27 is basically 3 cube, is equal to capital R cube. So therefore I will get capital R is 3 times of small r. That is what I just got. Now my job is simplified. We can just solve for the last part. I want to find the potential of the bigger sphere. So the potential of the big sphere will be K capital Q divided by capital R. Capital Q is nothing but 27 times small q. Capital R is nothing but 3 times small r. Correct? 27 goes with 3, 9 times. So 9 times K Q divided by R. But this KQ by R is only 220. KQ by R is the voltage of small drop. So it will be 9 into 220. Is that clear? 9 into 220. I hope this is very, very clear. So 22 9s are 198. So 1 more 0. So 1980. Yes, that is the correct answer. 1980 will be the correct answer. Everyone clear? Shall we move ahead? Moving on to the next question coming up on your screen. Here it is. A short dipole has a dipole moment of this much. The electric potential due to the dipole at a point 0.6 meters from the center of the dipole at a line making 60 degree with the axis of the dipole. So this is our dipole, let's say, on a line which is making an angle of 60 degree at this particular point. The question is, what is the electric field? Electric potential. So the formula for electric potential is Kp cos theta divided by r square. That's all. That's all the formula is. K value we all know is 9 into 10 to the power 9. Dipole moment, I think it is already given as 16 into 10 to the power minus 19 coulomb meter. Cos of 60 will be there. Cos 60 will be there. Whole thing divided by distance 0.6. So put 0.6 over here. That's all. Understood how to substitute and which formula to use? It is a question on potential. Potential formula is Kp cos theta by r square. Many people miss this r square. Write it as r. So remember, dipole formulas have a higher power of r as compared to your regular formulas. So solving this, you will get the answer. Is that right, everyone? Just see if you get the answer as 200 volts. You should get the answer after solving this as 200 volts. Okay, that calculation part you do it. Perfect. Moving on to the next one coming up on your screen. In a certain region of space with the volume this much, potential is found to be 5 volts throughout. The field in the region is. This is very straightforward. I want everybody to spam it. Target aims, I'll tell you where will you get the PDF. Simple thing, as you're watching this video on the channel, do you see on the Vedantu NEET English main page only? First of all, I hope you have subscribed. You will see probably some links are there. Just click this particular link. You will see a sheet will open up. You can see 10-year PYQs. The chapter wise PYQ list is there for separately for biology, physics and chemistry. Okay, so you can check this out. Okay, so you can use this particular link directly. Cool. I hope this is clear. Yeah. Is that okay, target aims? Okay, and these links will keep getting updated with time. Don't worry. Yeah, the correct answer is a big fat 0. Why? Read the question carefully. It is 5 volts throughout. It is 5 volt here. If it is 5 volt here, that means the potential difference is 0. If potential difference is 0, that means the electric field is 0, because electric field only goes from high voltage to low voltage. If it is the same, then obviously the field will be absent, just like inside a conductor. Yeah, cool. Moving on to the next question on your screen. A spherical conductor of radius 10 centimeter has a charge of this. Oops, I showed the answer. Okay, anyways, has a charge of this distributed uniformly. That is the magnitude of the electric field at a point 15 I think, what is the magnetic field of the electric field at a point 15 centimeters from the center of the sphere. The radius of the sphere is 10, 15 centimeters is more than the radius. So that means you are asking what is the field at this particular point. So the formula for the field at that particular point is nothing but KQ divided by R square. That's all. That is the thing. So K value is 9 into 10 to the power 9. Charge is 3.2 into 10 to the power minus 7. And distance is 15 centimeter. So 15 into 10 to the power minus 2 whole square. That is it. So that will give you the answer as 1.28 into 10 to the power 5. Is that okay? So what is the use of 10 centimeter? What is this use of 10 centimeter? It is waste data. No use. Actually, in the formula there is no use, but otherwise there is the use to understand that you are outside. If you are inside, the formula changes. Only for that this particular radius is given. So it is not used in formula, but to understand which formula to use, we need the radius. That is how it is. Okay. Yes. Yes. Yes, Sri, that is the whole idea. We will be giving you, I'll tell you, we are going to launch something crazy for all of you, like a notes thing, so that you will have a cheat sheet, you will have some revision, right? So we are going to do something very, very crucial for all of you of different types, short sessions, long sessions. Yes, they are going to follow just after tomorrow. Whatever is the surprise, I will let you know. Okay, cool. Let's move on to the next one. A hollow metallic sphere of radius r is uniformly charged. The electric field due to the sphere at a distance small r from the center. At a distance of small r from the center, guys. Think about it. What should the answer be? What should the answer be? If you are taking a hollow metallic sphere, then if you are finding the electric field at a distance of small r from the center, obviously if you are inside, the electric field is 0. Outside, the electric field is going to be KQ by small r. There is only one option like that. I think 0 for less than r, and increases as r increases, or decreases, it will decrease. So it should be option A, I believe. Yes, it is option A. Because if you notice the graph of this, it looks something like this. It is 0 as you're inside, and the moment you go outside, it goes down like this. So it is 0 inside, and when you are outside, it decreases as r increases. You can see as r increases, your field decreases. So that is why this option A should be correct. If you know the formula, the graphs, it becomes easy. Moving to the next one. 2-point charges A and B having charges plus Q and minus Q respectively are placed at a certain distance apart, and the force acting between them is F. If 25% of the charge of A is given to B, then the force between the charges now becomes what? Yeah. Distance has to be in centimeters, Mohammed. If it is, see, everything is in CGS, you will use CGS, but usually you will convert it into SI. So if it is given in centimeters, you will convert it into SI by multiplying centimeters into 10 to the power minus 2 to make it meters. Now over here, A and B, this is A, this is B. This has plus Q charge, this has minus Q charge, and the force between them is F. That means you can think like this, they will be attracting each other with the same force of F. Now what you do is you have transferred the charges. How much charge? 25% of A is transferred to B. So if you give 25%, that means Q by 4 over to B. So the charge on B will become minus Q plus Q by 4. And the charge on A will become less. So it will become Q minus Q by 4. Q minus Q by 4 is 3Q by 4. Minus Q plus Q by 4 is nothing but minus 3Q by 4. I hope this is fine. These are the new charges. These are the new charges on the spheres. Minus 3Q by 4 and 3Q by 4. I hope this is clear. 25% of charge is transferred. So what will be the new force? The new force will be K into this charge, which is 3q by 4 into magnitude we are trying to find out. So again 3q by 4, we are just trying to find the magnitude over here. So 3 3s are 9, 4 4s are 16, q divided by, and this is r square, and then there is r square over here. So 9 by 16, q by r square is just nothing but your force F. That's it, guys. So the correct answer for this particular question should be 9F by 16. 9F by 16. As simple as that. Cool? Simple? Shall we go ahead? Yes, C for capital. Charge is conserved, but force is going to change. Yes, the total charge has to remain the same. Correct. So based on charge conservation principle. Moving to the next one. Two parallel infinite lines with linear charge density are at a distance of 2r in free space. What is the electric field midway between those two particular charges? That is the question. What is the electric field midway? So very rarely they ask different geometries, and this was the only question in the last 5 years where they have asked the field due to a geometry like a line charge and stuff like that. So this is basically plus lambda. Let's say this is minus lambda. Due to plus lambda over here, the field will be this side. The field will be like this due to the plus lambda charge, right? It will be away from it. Due to the minus lambda, it will again attract it. It will again attract it. So both the fields are in the same direction. So can I say the total field, the total net field is nothing but going to be the field due to the positive line charge and the field due to the negative charge, line charge. Both are in the same direction. They are in the same direction. That's why they will add. But the best part is magnitude of lambda is same, distance is also same, means the field magnitudes are same, so they can be just taken as equal. So you find any one and you multiply by 2. So I can just write this as 2 times of E plus or 2 times of E minus or 2 times of E minus. Why? Because they are equal. Because they are equal. Is that right? Everybody got this till this point? Very good. So what is the field formula due to a line charge? It is nothing but your K, or basically you can put 1 by 4 pi epsilon naught, and then you will have lambda is there, and then 2 is there over here. So actually you can put 2 over here, then lambda over here, and then you have r over here. This is the formula. So 2 cancels with this particular 4, I believe. Yes, everybody. So what is left? Only lambda by pi epsilon naught r. Lambda by pi epsilon naught r. This 2 is also there. It is actually 2k lambda by r. That is the actual formula. So you will get the answer as option C, I believe. Yes, it is the answer. So remember the formula that you have to remember is for infinitely long wire, the electric field is 1 by 4 pi epsilon naught multiplied by 2 lambda divided by r. That is the formula. So it is K into 2 lambda divided by r. That is exactly what I have put. If you know that, this becomes easy. Moving to the next question. Wow, we have completed electrostatics. Moving on to current electricity. Gurusha Gupta, is that clear? Not clear? If it is not clear, I will explain this to you. I think little bit in a different way. See, this was a positive line charge. What will it do? It will give field like this. It will give field like this. Imagine another line charge which is negatively charged. It will attract everything towards it like this. It will attract everything towards it like this. Correct? So basically everything is going to be attracted towards the negative charge. Everything is going to be repelled by the positive charge. So over here, do you see the fields are adding? The fields are basically adding, they are supporting each other. So that is why the net field is going to be in this particular direction. That's all. I hope this is clear. Direction is clear. So if you find the field due to any one charge, You just multiply by 2, you will get the total field, because both these things will apply the same amount of field. That is all that I have done. Cool. So over here, the separation between them was 2r. So from one charge to the midpoint, the separation is r. From one charge to the midpoint, the separation is basically r. So I have just used that over here. The field due to any line charge at this point is given by this formula. So I have used that over here, right? 2 lambda divided by 4 pi epsilon naught r, but 2 times because both the fields are equal. That's it. I hope this is clear. Gorisha and others, everyone, clearo? Shall we move ahead? Let me know. Give me a thumbs up, because current electricity is what we are going to go next, right? Cool. Let's move on. Okay. Current electricity. Here it is. A certain wire has resistance of 81 ohms. The resistance of another wire of the same material of equal length, but diameter is thrice the diameter of the other wire. So diameter has changed. So we all know resistance is rho L by area, which I can write it as rho L by pi r square. If diameter becomes 3 times, even the radius will become 3 times. That is understood. Now, the material has not changed. Length has not changed. Pi is a constant. Only r has changed. So resistance is inversely proportional to the square of the radius, and radius is half the diameter. So if radius increases 5 times, diameter also increases 5 times. Diameter increases 3 times, radius also increases 3 times. So instead of radius, I can also use the word diameter. So resistance is inversely proportional to d square. So R2 by R1 will be diameter 1 by diameter 2 whole square. What is the diameter 1 and diameter 2? The new diameter is thrice the old diameter. So D2 is 3 times the old diameter. The old resistance was 81. So R2 will be, bring 81 on the top. 3 square is basically 9. So it will be basically 9 ohms. Just check this out. Yes, it is 9 ohms, my dear warriors. Isn't that amazing? Simple question. You should know what is the resistance formula in terms of rho L and A. And you should also realize resistance and diameter will increase proportionately to each other. So you can replace in the proportionality symbol, instead of radius, you can also put diameter. That's all. That is the answer. Perfect. Moving on to the next question on your screen. A copper wire, some free electrons, drift speed 10 ampere. What is it? Question is, what is the drift speed? Drift speed formula. NVIDIA, very famous company these days, making those chips for artificial intelligence. So current is NVIDIA. So basically VD will be I divided by NEA. Current is 10 ampere. Number of charge carriers is 10 to the power 22. Electron charge is 1.6 10 to the power minus 19. And area is not given. The radius is given. So instead of this A over here, I can write it as pi r square. So I can just put pi, and r is 1 millimeter. So 10 to the power minus 3 and then whole square. So just do the math. I think they have left the answer in terms of pi only. So you will get something by pi, okay, meters per second. Just check it out. If you are getting the answer as 6.25 into 10 to the power 3, you should get the answer as 6.25 into 10 to the power 3 divided by pi meters per second. As straightforward as that. Yes, NVIDIA formula has saved the day. Cool. Let's move to the next question on your screen. What does it say? The magnitude and the direction of the current in the following circuit. Both the batteries are opposing each other. So the first thing that I should do is take both these batteries as one single battery. 10 and 5. Who will win? 10 will win. So I can think of the positive terminal being here and negative terminal being here. So the net will be 10 minus 5, which is basically 5 volts. 5 volts. So forget the individual batteries. Think of one single battery with positive side here, negative side here. So the current will definitely flow like this, like this, like this, like this, and back like this. And what will be the current, my dear students? The current will be the total EMF by the total resistance. EMF is nothing but 5. Resistance is 1 plus 7 plus 2, which is 10. 5 by 10 is half ampere. So half an ampere of current, which is 0.5 amperes of current. I can see 0.5 amperes only over here, and it is going from A to B via E. Yes, that is also correct. It is going from A to B via E. So option A seems to be correct, which is asked in NEET 2023. NEET 2023. Yes. Yep. Okay. Okay. Shall we go ahead? Shall we go ahead? Next question. Yep. Ready for it? Coming up on your screen. If the galvanometer does not show any deflection in the circuit shown, the value of the resistance is. Very nice question. This was asked last year. So let's see if you guys are able to think what is the crux of the problem. The crux of the problem is because there is no current here, whatever is the voltage across these 2 points will be directly available over here. So the same voltage, of basically 2 volts is available directly across the resistance, or else there will be some current drawn, there might be some new voltage because of the internal resistance and all of that, but directly 2 volts will be applicable over here. So now I know the resistance R has 2 volts across it. So using Ohm's law, that is V is equal to IR, I can say voltage is 2, current I don't know, resistance I don't know again, right? I hope this is clear. If the galvanometer does not show any deflection, I right now do not know the current nor do I know the resistance. But because I know this is 2 volts, 100% I will be able to find out what will be the voltage across 400 volts. Even though I cannot find neither the current and resistance here. Here, if you notice, since this is 2 and the battery is giving 10, out of 10, 2 volts is being dropped here. Some volts will be dropped here. Use Kirchhoff's voltage law. You will realize plus 10 from going from here to here, and then some voltage drop. The voltage will be dropped over here, so I'll put minus sign. So delta V across that 400, and 2 volts is dropped here, and you come back to the same point. The answer should be 0. Kirchhoff's voltage law. Plus 10 minus something, I come back to the same point, answer should be 0. So think about it. What is that voltage drop across that 400 ohm resistance? It will be 10 minus 2, which is basically 8 volt. Now let's use Ohm's law and see what do you get. If I use Ohm's law, voltage is 8, current I don't know, resistance is basically 400. This goes 2 times. So the current will be 2 divided by 100 ampere. So use this current over here. So this is 2 divided by 100, and your resistance is as it is. 2 cancels. So resistance should be 100 ohm. That's it. That is the answer. Let's just check it out. Yes, option B is correct. Got it, my dear students, what we just did? I just quickly repeat. Whatever galvanometer is there, no current is allowed. Whatever voltage is there here, same voltage will be there here. So 2 volts means 2 volts. But the problem is, if I use Ohm's law here, I neither know the current nor I know the resistance. Okay. So I went to this resistance. And if I see this particular loop, if I use Kirchhoff's law, 10 minus some voltage will be 0. I know this voltage is 2, that helped me, and the original battery is supplying 10 volts. So I got the voltage across this resistance. So voltage is current into resistance. voltage is current into the resistance. So I got the current. Once I know the current, I use the same current over here to find this resistance. As simple as that. Got it, everyone? Nice question. Loved it. Yeah, mark it. You will get these kind of questions. All these models are very, very probable in your NEET 2024 examination. Resistance of the wire is 2 and 6.8 at 80. The temperature coefficient of resistance is. Simple question. The resistance at any given temperature is given by R naught into 1 plus alpha delta T. So what you can do is you can write this as RT by R naught is equal to 1 plus alpha delta T. Then alpha delta T will become nothing but RT by R naught minus 1. So therefore alpha will become your RT by R naught minus 1, and you will have 1 by delta T over here. So it's just a matter of substitution. Everything now is simple. So resistance at temperature T is how much? It is 6.8, and resistance at 0 degree Celsius is basically 2. So minus 1 upon the temperature difference, 80 and 0, the temperature difference is 80. That's all. So just solve this and you will get the answer as 3 into 10 to the power minus 2. Okay, so solving this, you will get the answer as 3 into 10 to the power minus 2. Simple, direct formula. The linear coefficient of thermal resistance alpha. When you increase the temperature, resistance changes. Resistance will change. So alpha decides how much will it change by. It is there in the current electricity chapter in resistance. Moving on, next question on your screen. 10 resistors, each of resistance R, are connected in series to a battery of EMF E and negligible internal resistance. Then those are connected in parallel to the same battery. The current is increased n times. The value of n is how much? Interesting. Let's figure this out. 10 resistors, each of resistance R, are connected in series to that battery. There is no or negligible internal resistance. Now they are connected in parallel to the same battery. The current increases n times. How many times will it increase? See, if you have one battery after the other, like that, 10 such cells are there, and you connect it. Oh, sorry, 10 resistors are connected to battery. My bad, I told 10 cells. Sorry, 10 resistors are connected to this particular battery, each of resistance R. Then the current will be E by R plus R plus R, like that, 10 times. So it will be E by basically 10R. That is the first scenario. Now in the second scenario, they are in parallel. They are in parallel like this, right? 10 such resistors are in parallel and they are connected to the same cell. So the new current will be EMF by the new resistance, which is 1 by R plus 1 by R, like that, 10 times, which will be E by 10 by R. So take sorry, this I can say it is not like this, my bad. This is 1 by reciprocal. So 1 by R equivalent will be 1 by R plus 1 by R, like that, 10 times, which is 10 by R. So RE equivalent will be basically R by 10. So put R by 10 over here. So this will become 10 E by R. This will become 10 E by R. Now what is E by R? E by R, if you see from here only, you will get it. From here only you will get it. E by R is basically 10 times of I. Is basically 10 times of I. Bring that 10 on the top. So E by R is nothing but 10 times of I. So therefore 10 into 10 is 100. So 100 times of the current. So this is your new current, which is 100 times the old current, which is option number A. Which is option number A. Yes. Imitya, for JEE students, I think, yes, you can watch it. But it will be on the easier side. So you can expect the easy questions of JEE, like those 30%, 40% of those questions will be of this level only, right? 40-50% maximum will be of this level. Cool? In physics, I'm telling. Moving on to the next one. So if you are looking for easy questions, definitely please go ahead. Reciprocal of resistances. Resistance. This is straightforward. I want everybody to spam the answer. I want everybody to spam the answer. What do you think the answer is? Come on, my dear students. Very, very simple. Yep, very good, very good. A for Andhra. A for Ames. Perfect. Conductance. Resistance, conductance. Resistivity, conductivity. So that's how the reciprocals go. Uns is there, so uns only will be there in the end. Vt is there, Vt will be there in the end. So resistance, conductance. Resistivity, conductivity. They are reciprocals of each other. Very good. Proud of all of you. Moving to the next one. A cell of 4 volts and internal resistance 0.5 ohms is connected to 7.5 ohms external resistance. Okay, 7.5 ohms external resistance. The terminal potential difference of the cell is, okay, let's draw the diagram. It will become very, very easy for all of us. This is 4 volt. Internal resistance is 0.5 ohms is connected to 7.5 ohms cell. Resistance. The terminal voltage difference is, the first thing anybody should do is find out what is the current in the circuit. The current in the circuit is EMF divided by the external plus internal resistance. EMF is 4, external is 7.5, internal is 0.5, which will make it 8 totally. 4 by 8 is basically half, which is 0.5 amperes. Once I get this, you can find out the terminal voltage, which is voltage difference between these 2 points, which is given by E minus IR. E is basically 4, current is basically 0.5, resistance is also 0.5. So 0.5 into 0.5 is 0.25. This is minus 0.25. So this will become 3.75. 3.75. Oh, the answer was already marked. My bad. Okay. Okay. So the answer is 3.75 just by using the terminal voltage formula E minus IR. E minus IR. Okay. Is that clear, everyone? Yes. B for biology. Already seen. Yes, Kamesh. I think the previous slide had the question. Okay. I think I went to the answer slide directly. Okay. No issues. The equivalent resistance of the infinite network, famous problem of infinite ladder. Everybody gets scared the moment they see saw infinite ladder, sir. Okay, shall we do it properly? Okay, shall we do it? All right. So 1 1 1 1 1 1 like that it is there. Okay, so here is what I will do. Observe it carefully. What I am going to do. So from here, this is 1, this is 1, this is 1 like this. Now the remaining part, just showing it in different color, you will see why. And this continues like this. Please don't sit and by heart these questions. They are very, very logical, let me tell you that. Okay, this continues till infinity. Now let's just assume that between these 2 points A and B, resistance between A and B, let's assume it to be X. Let's assume it to be X example. Now think and tell me, if I forget this first part which is repeating and I directly start from here, what do you think will be the equivalent resistance over here? This continues. What do you think will be the equivalent resistance over here? Think about it. This yellow part. This is an infinite ladder from infinity. Let's say you go and ask Ambani sir, please give me 10 rupees. Ambani sir gives you 10 rupees. Do you think Ambani sir will become poor? No, right? Ambani has so much of wealth. But maybe you ask some person who is begging on the road 10 rupees, he will slap you. Like, what? I am only asking money, you are asking 10 rupees from me. My earning only per day might be 100, 200 rupees. So there it makes a difference. So when it is infinitely large, taking away one part will not matter. Understanding? So won't this resistance be also equivalent to X only? Won't this part be also X only? Everybody got it? Yeah. Great. Cricketers, and I don't know the answer for this question, but you can do one thing. You can study very well. You can join the NTA and then make the physics paper very easy. Then the students who will write the J exam in 2037 or 2040, they will praise you a lot. Okay, so that is the only thing which I can do. Right now we know it is difficult, we will just prepare for it. Let's not question why is it difficult or why is it easy, no point. Okay, so over here, why not then draw this circuit like this, 1 ohm over here, 1 ohm over here, then there is 1 ohm over here, and this whole thing is equivalent to X, so might as well write it as X ohms over here. Might as well write it as X ohms over here. This is 1, this is 1, this is 1. This is A and this is B. Does this make sense to all of you now? Does this make sense to all of you, everyone? Okay. Now, do you see that these two are in parallel? These two basically are in parallel. Do you see that? These two resistance, basically they are in parallel. So in the parallel combination, the equivalent resistance is R1 R2 upon R1 plus R2. So it will be X upon 1 plus X. X upon 1 plus X. Now you have three resistors in series. 1 ohm, then this, and then this. This is also 1 ohm, and this resistance in between. This resistance in between. This is X upon 1 plus X. They are in series. So the equivalent resistance of them will be, the equivalent resistance of them between the points A and B, between the points A and B will be 1 plus X by 1 plus X plus 1. But RAB is X. The equivalent resistance is X. So X will be equal to 2 plus X by 1 plus X. Correct? Perfect. Now what you do is just multiply. Take the LCM. So X into 1 plus X is equal to 2 into 1 plus X plus X. I just multiplied both sides with 1 plus X. So 1 plus X just got cancelled. It just got multiplied here as well as here. So this will become nothing but X plus X square is equal to 2 plus 2X plus X over here. So let's see what and all will get cancelled. First of all, this X got cancelled with this X, nothing else. That's all. So X square minus 2X minus 2 is equal to 0. Do you see it is a quadratic equation? Yes. I hope this is clear. I hope this is clear. Very good. And what next? What next, my dear warriors? X will be equal to minus B. Use your quadratic equation formula. Minus B plus or minus B square minus 4AC. Minus B is basically 2 plus or minus B square. B square is nothing but 2 square, which is 4, minus 4 into A. A is basically 1 into C. C is basically minus 2 over here. That's it. This whole thing divided by 2A, which is 2 over here. I think 4 will come outside. It will cancel with 2. 1 plus 2 root 3 will be there in the answer. 1 plus root 3, I think. Something like that. 1 plus root 3. Yes, that is the answer. 1 plus root 3. Perfect. Perfect. 1 plus root 3 ohm. We can cancel out 2. From everywhere, you do the simplification. 1 plus root 3. Some of you will be answering, sir, what happened to the minus sign? Will I take the minus sign? No. If I take the minus sign, what will happen? 1 minus root 3 will become negative number. How can resistance be negative? How can the resistance be negative? So we will choose the positive sign. The negative sign will make the value of the resistance only negative. So you will choose the positive sign. I hope this is clear. Yes, very good. All right. All right. Preeta, I would suggest check out the playlist which has already been made. I think you have not seen the playlist. Please check out the playlist over here. Just go down over here. Okay. Physics Super 6 final over. You can just click on play all or just click on this entire series. All the chapters are there, my dear friend. And in case you want any specific chapter again, you know, what you can also do is you can also search over here, or you can just search over here and just put, okay, your requirement, Shreyas sir, this chapter, you will get it. Okay, that's the best way to do that in case you are not able to find it in the playlist. Another option is in the crash course, all the lectures are there, right? You also have the VBuddy program where all the lectures are also recorded format also is given to you. So all the options I have given it to you. So let's continue with the problem solving. Okay, cool. Let's move on. Yeah, magnetic properties is not there. So just check out the magnetic properties lecture from my JE channel. That is also okay, because that chapter is same. Just check it out from my JE channel. It's the same thing. There is no need to see NEET specific something. Okay, it's the same thing. There is no change at all because the portion is same and it is a very easy peasy chapter. Maximum one question might come. Sometimes one question also does not come. Understand that. Okay, cool, Preeta. Yes, you have the 9 p.m. physics class at 12 o'clock. Sorry, 9 o'clock. Yes. Cool. Let's move on to the next question coming up on your screen. Two resistances are there. What does it say? Two resistances are there and 100 ohms and 200 ohms. They are connected in parallel. The ratio of the thermal energy developed in 100 to that in 200 is how much? See, because they are in parallel, what does it mean? Because they are in parallel, the voltage difference is going to be the same. So when you use the power comparison, use power is equal to V square by R formula because V is same. So P is inversely proportional to R. So P1 by P2 will be R2 by R1. R2 by R1. What is R2? 200. And R1 is basically 100. So it will be 2:1. So just check that out. 2:1. That is option number B. Very straightforward. Why am I not using I squared R? Because current is different. So again you have to find the current. Why waste your time? So instead use V square by R. So choose the formula correctly. Because many students ask, sir, how do I know V square by R only? Think, because it is in parallel. If it was in series, then which formula will you use? Put it up in the chat box. If it was given to be in series, the same question, then what will be same? Current. So will you use this? No, because voltages will be different. Then you will use I squared R and then you will see power will be directly proportional to resistance. So depending on the situation, you will change the formula. Got it? How this has to be done? So I'm training you guys for all these things because these things only will matter at the end of the day. Cool. Correct. Moving on to the next question. Copper wire is there, radius is there, resistance is there, current density in the wire for the electric field strength. Okay. Very nice question. This was asked in NEET 2022. People got confused. Sir, electric field inside the conductor? Yes, it's there in current electricity. Remember, E is equal to rho J. E is equal to rho J is the formula. So, we want to find the current density, that means J. The electric field strength, that means E is given. Rho is not given, but I think we can find it out by this concept that resistance is rho L by A. Therefore, rho is R A by L. So substitute R A by L over here and J as it is, and this is electric field. Question is to find the current density J. So J will be, therefore J will be, take L on the top, electric field into length divided by R into A. That's all. So electric field is basically 10. Length of the wire 10 meters. Resistance of the wire, where is it? Resistance is 10. And area of cross section pi r square. So pi into r. Radius is 10 to the power minus 2 by root of pi whole square. Deliberately they have given root pi because root pi square will become pi. Pi will cancel. Pi will cancel. So what is the answer that you will get? Just check it out. 10 to the power 5, guys. 10 to the power 5, because this 10 and this 10 will cancel. This will become 10 to the power minus 4. 10 to the power minus 4, which will give you 10 to the power 5. Pi has cancelled. Cool. Shall we go ahead? This was in NEET 2022. Excelente. Let's move on. So remember this formula. This formula is very important. Okay. E is equal to rho J. Electric field is resistivity into current density. Next one on your screen now. Wheatstone's bridge is used to determine the value of the unknown resistance by adjusting the variable resistance Y as shown for the most precise measurement. Well, this is a standard experimental practice that the null point that you get should always be somewhere in the middle. The resistances should be such that, you know, this and this are roughly equal. So basically you will see that the correct answer should be approximately equal and small, as simple as that. So for the most precise measurement of x, you will see that this and this should be equal, so that, you know, exactly half voltage is dropped. Why do you want half voltage, not just in this setup but also in potentiometer setup? Is because when you reach the end, or when you are at the beginning, there are some undesirable effects which come into play, which are called as the end effects. So to neglect those end effects, or to get rid of them, you somewhere try to measure it in the middle. Like for example, when you take a scale and you want to measure the length of, let's say, this phone, you will take a scale this big, right? And the scale is this big, okay? And you see, okay, it is 5 centimeters, it is 4 centimeters. You won't take 1 kilometer scale. Sir, I bought a 1 kilometer scale, sir, and in that also I can measure the length of the phone. Because then the value will come close to the beginning, it might cause some undesirable effects. Because for such a big scale, the markings won't be so close, the markings will be very far. That is the reason for that. Got it? Or you won't even use a scale only which is exactly this big, because then also it might cause some error, because exactly towards the end maybe the scale might not be sufficient, maybe it's not meant to measure exactly till whatever this particular object length is over there, maybe the markings are not that accurate because of the end effect. So somewhere in the middle you will always see the readings are very, very accurate. These are practical problems. Theoretically it should not matter whether you use small or big, but these are practical problems which arise. That is why it should approximately be the same. Keep that in mind. Okay, cool. Shall we move ahead? Thank you, Krishna, so much. Let's move on. Here is the next question on your screen. It says the effective resistance of a parallel connection that consists of 4 wires of equal length, area, cross section, material is basically 0.25 ohms. They are in parallel. What will be the resistance if they are connected in series? Simple, guys. It's like you have 1, 2, 3, 4 resistance in series. Parallel. So when they are in parallel, the equivalent combination is 0.25. So 1 by 0.25 is 1 by R plus 1 by R, like that 4 times. So it is 4 by R. So 1 by 0.25 is 4 by 1. 4 cancels. So R is basically 1 ohm. Once I get this, once I find each of the individual resistance, now connect them in series. So R. So what will be the total resistance in series? R plus R plus R. So it will be 1 plus 1 plus 1, which is 4 times. So it will be 4 ohms, which is option D. Yes, that is the correct answer. So easy peasy question was asked in NEET 2021 on the resistance. Everybody's wish it will be to get such a simple question. Yeah, chances of making a silly mistake are very, very high in these questions. In hurry, you might not cancel something, you might forget to take the reciprocal, or instead of parallel, you might read it as series, and series, you might read it as parallel. All such problems might happen in the end. So these are simple, but they can also be those traps where you make silly mistakes. Direct question based on formula. Direct question based on formula. I want everybody to answer this. No, what's your name? Krupa Satya. Krupa Satya, you will not get a single question from the deleted syllabus. If they give, then they are playing with the lives of 25 lakh students. 25 lakh students will protest. Remember that. 25 lakh. Do you understand it? It's a huge number. Number one. Number two, see, in JEE there were multiple shifts. 6 days the exam is conducted, or 5 days it's conducted. 10 to 12 papers have to be made, and that too 2 times in a year. So it brings up to around 24 JEE mains papers have to be made every single year at least. So now in NEET it's one paper. They have just one job to make one paper. That also, if they make mistakes, means something is wrong. So they should not make any mistakes. They will obviously put in that extra layer of security where they double check, cross check if this is in the syllabus or not. They should be doing it. Otherwise, it will be bonus. Okay. So don't bother about deleted syllabus. Yes, the correct answer. Just check if A goes with R, drift velocity. Yes, A goes with R. Perfect. And then B goes with S. Electrical resistivity is going. Yes, E is equal to rho J. I just told you about it. Then what about relaxation period? Relaxation period, just check it out. C goes with P. Yes, relaxation time has the formula mass by NE square P. Current density, guys, D is going with Q. D is going with Q. Just check this out. Yes, NVD. I is equal to NVDA. So A, you bring it down. Current by area is current density. So NVDA. Yes, that's it. So everything is fine. So this is the correct answer. Moving on to the next one on your screen now. Ready for this? Everyone? Cool? Let's move. Let's move. Three resistors have resistance R1, R2 and R3 are connected as shown in the figure. The ratio of I3 by I1 of the currents in terms of the resistance used is how much? I3 by I1. Okay, this by this is asked because they are in parallel. One thing is clear, their voltages are going to be the same. So voltage in this is I2, R2. Voltage in this is I3, R3. So let's do one thing. Let's write down I2 by I3, I2 by I3. Bring R2 below. It will be R3 by R2, R3 by R2. Now I realize one interesting property which you have learned in basic maths, and that is componendo property. Componendo property. Componendo property says that a ratio is there, numerator by denominator. You just add numerator to the denominator on both sides, still the ratios will be equal. So why am I doing that? You will understand in the next step. If I add numerator and denominator on the left hand side, I should do the same thing on the other side, R3 plus R2 by R2. Some of you might be quick in realizing why Shreyas sir has added I2 and I3 in the numerator. Look over here, you will quickly realize I2 and I3, if you add them, you should basically get the current which is going in by Kirchhoff's current law. So strictly speaking, I2 plus I3 using Kirchhoff's current law, shouldn't it be I1? Shouldn't it be I1, my dear warriors? Therefore, I1 by I3 will be R3 plus R2 by R2. So question is, what is I3 by I1? So it will be R2 by R3 plus R2. Yes, that is option number C. You can see that right over here. You can see that right over here. The question asked was I3 by I1, not I1 by I3. So just flip this. R2 will go on the top. R2 plus R3 will go below. Okay. So what have I used over here? Kirchhoff's current law, my dear students. I2 plus I3 is equal to I1. Kirchhoff's current law. Junction law. Perfecto. Right? See how things have to be played. Yep. Moving on. Next one. What does it say? NEET 2020 question. Resistance. Left gap of a meter bridge balances a 10 ohm resistance in the right gap at a point which divides the bridge into the ratio 3:2. If the length of the resistance wire is 1.5 meters, then the length of 1 ohm of the resistor wire is. Basically, they are asking how much resistance is there per unit meter. Okay, that is what they are basically trying to ask us. Now, in that resistance potentiometer experiment, meter bridge experiment, sorry, the length of the wire is 1.5 meters. It balances a 10 ohm resistance in the right gap at a point which divides the bridge. Balances a, yes, okay. So basically there is an unknown resistance and there is 10 ohm resistance like this, and here you balance it like this over here. Resistance wire is connected in the left gap, okay, and it divides the bridge in the ratio of 3:2. This is 3:2. This wire length is 1.5 meters. So 1.5 meters, if I divide it if I divide it in the ratio of 3:2, 3:2. So first of all, 3 plus 2, if I add 3 and 2 together, I will get 5. So divide 1.5 into 5 parts. Divide 1.5 into 5 parts. So 1.5 divided by 5, 1.5 divided by 5, 1.5 divided by 5, 1.5 divided by 5, 1.5 divided by 5. Take 2 parts over here, take 3 parts over here. That is the length on this side, that is the length on the other side. That is the trick used to divide any quantity in any ratio. If this is the quantity which has to be divided in this ratio, 3:2, 4:7, 5:8, whatever, add these numbers, you will get some number like over here 5. Now divide this into 5 parts, 1.5 by 5, 1.5 by 5, etc. Take 3 parts over here, take 2 parts over here. So this will be nothing but 2 into 1.5 by 2. This will be nothing but 3 into 1.5, not by 2, my bad, this is 5. 1.5 divided by 5, and this will be 3 into 1.5 divided by 5. So what will this be? Check this out. 15 goes with 5 3 times. 3 3s are 9. So this will be basically 0.9 meters. And this will be nothing but, this goes with this 0.3 times. 3 2s are 6. So 0.6 meters. That is what you basically get. That is what you basically get. Is that right? Everybody? Awesome. Awesome. Yes. But did I need that is the real question. I didn't think I needed that. I'm so sorry. This was not even needed. All we could have done is simple thing. R by 10 is equal to 3 by 2. This by this resistance is length 1 by length 2. That's all I had to do. Anyways, so R is equal to 10 into 3 divided by 2. So this goes with this 5 times. So this resistance will become simply 15 ohms. So 15 ohms for 1.5 meters. For 1.5 meters. So from this, the resistance per unit length is 15 by 1.5, which is basically your 10. 1.5 or 15 ohms is there for your 1.5 meters. Just check this out. I think this should have been +1, not -1. Just check that out, right? It should have been +1. Everyone with me on this? Clear? Awesome. Awesome. So this part was not needed. I'm just going to erase this. But anyways, you learned a new theory in case you had to divide things into some ratio. Okay. So R1 by R2 is length 1 by length 2. And I just got the new resistance as 15 ohms. Moving on to the next one coming up on your screen. A charged particle having some velocity drift in a field this much has a mobility of this much. So what is the formula that we can use? Mobility is the drift speed per electric field. Drift speed per electric field, and drift speed is given, electric field is given, the mobility has been asked. So drift velocity, just put it out over here, 7.5 into 10 to the power minus 4. Electric field is 3 into 10 to the power minus 10. That's it. 7.5 by 3 is 2.5, and this will become 10 to the power plus 6. 2.5 into 10 to the power plus 6, which is option number A. Is that right? Yep. Very good. Perfecto, my dear warriors. Yes, we'll have a water break soon, just after current electricity. Guys. Let's go with the flow, full energy. Here it comes, NEET 2020 question. The solids which have the negative temperature coefficient of resistance. That means when you increase the temperature, the resistance will decrease. This won't happen in conductors. This can only happen in semiconductors. Yes, this or even an insulator. Yes, even an insulator also it can happen, because even you will see that in insulators that there are no electrons only in the conduction band. But when you heat it, then these electrons might get excited and few of them might start to conduct. So yes, if this option C is there, you will mark insulator as well as semiconductor. Okay, I hope this is clear. Cool, because when you increase the temperature, these electrons begin to jump into the conduction band and they begin to conduct. If you remember, even a semiconductor was an insulator at 0 Kelvin. This was also a question. A semiconductor was an insulator at 0 Kelvin. That means extremely low temperature. But when you heat it back to room temperature, it begins to conduct slowly. So even an insulator at room temperature, after heating it sufficiently, might begin to slowly start to conduct at relatively higher temperatures. So yes, that is option C. Is that clear, my dear students? Did you understand why it is option C? If insulator is also there in the option. Moving on to the next one on your screen. Which of the following graph represents the variation of resistivity with temperature for copper? Copper is a conductor. That's something which you need to keep in mind. So for copper, it's a conductor, resistivity and temperature. So as temperature increases, resistance increases, even the resistivity increases. So this can't be true, this can't be true. Either it is 2 or 4, but is it a straight line? No, it is straight line maybe for a certain region, but most of it is non-linear. So it should be option number 2. Yes, that is option 2. Many students wrote option 4 thinking, sir, I thought resistance increases linearly with temperature. I hope you have read the theory properly. It increases linearly only for a small range, 50, 60 degrees Celsius, 100 degrees Celsius. But if you go from minus 273 to let's say 1000 degree centigrade, if you draw the entire graph, it will not be a perfect straight line. It will be curved. For a part, it will be straight. For a part, it will be straight. But that straight line's curvature will also change. So that is something which you need to keep in mind. Is that okay? So this is a trick question. Many students, made a silly mistake in this and they wrote it as, option 4, which is linear. That is not true. Moving on. 6 bulbs are there connected as shown in the figure to a DC source, EMF E and 0 internal resistance. Okay, fine. The ratio of the power consumption by the bulbs when all are glowing, and number 2 in the situation when 2 from section A and 1 from section B are glowing. Okay, now see guys, what will happen in this particular scenario? If all the bulbs are glowing, think of this as resistor 1, resistor 2, resistor 3. All these 3 are in parallel. I'll just create a duplicate of this. Yeah. These 3 will be in parallel. Similarly, even these 3 will be in parallel. The resistance, right, of these 3 together will be R by 3. The resistance of these 3 together will be also R by 3. These 2 will be in series. So it is like saying R by 3 is in series with R by 3, which is connected to this EMF. So what is the total resistance of this particular circuit? It will be basically 2R by 3. The resistance will be basically 2R by 3. Now, in this case, the power consumption will be E square by the total resistance, which is 2R divided by 3. You can also put 3 times E square divided by 2R. That is the power consumption in the first scenario, in the first situation, when all of them are glowing. But in the second scenario, where 2 from section A and 1 from section B are glowing. So imagine this is not there because 2 from section A are glowing and 1 from section B is glowing. That means this and this is not there. So now here you have these 2 resistors in parallel, and in parallel their value will be R by 2. And here only one resistance is there, let's say R. These both are in series. So you have R by 2 and you have R over here directly connected to this cell. Together they will behave like one single resistance of R by 2 plus R, which is 3R by 2. So what is the new power going to be? power will be E square by this resistance, which is 3R by 2. So it will become 2E square by 3R. So what is the last step? What is the last step? The question is ratio of the powers, P1 by P2. P2, I will just put it over here, 2E square by 3R. What is P1? What is P1? 3E square by 2R. 3E square by 2R. E square, R gets cancelled. I think I'll get 3 into 3 and 2 into 2, which is 9 by 4. 9 by 4 should be option number B. Yes, that is correct. Yes, that is correct. So it was just a simple series and parallel circuit. And I tell this to my students also, whenever you see bulb problems, there is no such bulb formula. Students ask me, sir, one sir gave me one bulb formula. Which bulb formula? Nothing. Bulb is a resistor. If I erase this and write it as a resistor, it is the same thing. So treat it like normal resistors. It will look very, very easy. Okay. So bulb formulas are like resistors. Even I tell my students ammeter, galvanometer, voltmeter questions. There is no formula there. It's just a resistor. Replace the galvanometer with a resistor. It's a simple series parallel circuit. No need to by heart any formula. You will waste time. You will get confused. What is this? What is this term? Etc. Don't. Moving on. Next question. In the circuit shown, the reading of the voltmeter and the ammeters will be, okay. See over here and see over here. NEET 2019 question, my dear students. NEET 2019 question. Voltmeter, 10 ohm, okay, 10. Okay, just because I added this 10 ohm, will it make any difference? Anyways, the current flowing through this is negligible. Just because you added some 10 ohm will still not make any difference. It will still be negligible because the voltmeter has very high resistance. This will be much larger, very high resistance, very high resistance. So it will not matter. So voltmeter reading will not change. This resistance will not change. So current will also not change. I think everything should be same as much as possible. Yes, it will be equal. V1 is V2, I1 is also I2. Because this will be like 10 kilo ohm, 20 kilo ohm, 5 kilo ohm, like that. In front of 5 kilo ohm, what is 10 ohm? Nothing. Useless, waste fellow. Like how you get scolded. One topper student is there. He is getting 700 marks. And one student goes, ma'am, I got 10 marks. Or he tells his parents, I got 10 marks. Parent, useless fellow you are. That student is getting 700 marks and you are getting 10 marks. So it's like that. Understood? Okay. Moving on to the next one. Which of the following acts as a circuit protection device? This is simple. Very straightforward. Inductor, conductor, switch, fuse. When light goes suddenly and everybody else has light in your neighborhood, what is the first thing probably your dad or maybe your elders must be doing? They will be going to that electric board and they will be checking whether the fuse has burnt. The fuse acts like a protection device. Maybe there was some short circuit in the house which was prevented by the fuse material burning because of the high heat produced in that fuse wire. It has a low melting point and it gets heated up rapidly, and if more current is drawn, it melts and it breaks the circuit connection. That is the usage of fuse. Is that right, everyone? Let's go ahead to the next one coming up on your screen. Oh wow, we have capacitors. Let's quickly have a water break. Everybody, half a minute water break. Let's time it. Half a minute to 1 minute water break. Come on. All right, let's go to capacitors, guys. Here it comes. Equivalent capacitance of the circuit, straightforward. First of all, you can see clearly these three capacitors are in series, and in series, be careful, don't add them, they are capacitors, so it will be divided. So 15 microfarad divided by 3, which is 5 microfarad. This is in parallel. This is in parallel with this. These two are basically in parallel. So the effective capacitance will be 5 plus 15, which is 20, which is option number D. Moving on to the next one, right? Simple. Just remember they are going to have slightly different formulas. Yep. Moving on to the next one coming up on your screen. To produce an instantaneous displacement current of 2 milliamperes, the space between the parallel plate capacitor, of capacitance this much, the rate of change of applied variable voltage difference must be. Simple, guys. It's some current has to be passed inside a capacitor, and the capacitance is this much. The rate of the variable voltage difference will be how much? So basically, if you want to create a current of 2 milliamperes, first remember Q is equal to CV. Charge on a capacitor is capacitance into voltage. So if I differentiate this dq by dt, capacitance is not changing. It will become C into dV by dt. dq by dt is nothing but current. So that's it. I got a relationship. So dV by dt is nothing but current by the capacitance. What is the current? Current is given to be 2 milliamperes. 2 milliamperes. And what is the capacitance? It is 4 microfarad. So 4 into 10 to the power minus 6. So it will be 0.5 into 10 to the power 3. 0.5 into 10 to the power 3, which is basically 500. 500 volts per second. That's it. dV by dt is rate of change of voltage. Don't get confused by all the jargons, all the terminologies used over here. Don't think it is a complex question. It is just current relationship with a rate of change of voltage. Because charge is related to voltage, rate of change of voltage will be related to the derivative of the charge, which is current. That is the initial step. If you understood it, that's it. It will become very easy. Solve this model of question. Okay, moving on to the next one coming up on your screen. Here it is. The equivalent capacitance of the system in the shown circuit is, this is again simple. These two are in parallel. So in parallel, just add them. So it will be 3 plus 3, which is basically 6. 6 and 3 are in series. So in series, it is C1 C2 by C1 plus C2. So it will be 18 by 9, which is basically 2. So 2 is there. Yes, option D. 2 is the answer. First, these are in parallel. So add them. In series, use the resistors in parallel formula like R1 R2 by R1 plus R2. Here it will be C1 C2 by C1 plus C2. Cool. Moving to the next one coming up on your screen. The distance between the two parallel plates of a capacitor is doubled and the area of each plate is, oops, I showed the answer. Okay, anyways, I will continue. Is half, then the final capacitance is equal to, capacitance is given by epsilon naught A by D. As you can see very clearly, the distance between them is doubled. So this is basically made 2 times. And the area of each plate is halved. So this area has been made half. 2 is there in the denominator, 2 is again there in the denominator. So capacitance will be made 1 by 2 into 1 by 2, which is basically 1 by 4 times. So it will become 1/4 of the original capacitance. Yeah, both the denominator and the numerator contributes to the 1/4, right? Change. Keep this in mind. Cool. Very straightforward. Moving on to the next one on your screen. The effective capacitance is of 3 and 16 when they are connected in series and parallel is 3 and 16. The capacitance of the two are how much? Okay, simple. See, when they are in series, it is 3. That means 3 is equal to, let's say, x plus y. 3 is basically x plus y. Then this is when they are in parallel. That means 1 by 16 is equal to 1 by x plus 1 by y. Okay, so what you do is just solve this now properly. So 1 by 16 will be xy. divided by x plus y over here. X plus y is basically 3. So 3 by xy, and here you have 1 by 16. Cross multiply over here. So xy is basically 48. Instead of y, what you do is put it as 3 minus x. Put it as 3 minus x is equal to 48. So get 3x minus x square is equal to 48. So x square minus 3x, x square minus 3x plus 48 is equal to 0. So you will get now two roots of this particular equation. You will get two roots of this particular equation. What are those two roots, guys? Think about it. What are those two roots that you will get? Those will be the answers, by the way. Those will be the answers. Okay, so I think one of the answers you should get it as 12, one of the answer you should get it as 4. So that's it. 12 and 4 should be the answer. Cool, everyone? That's all. And you know a better way of Okay. Sorry. No, we will not get that as the answer. I made a blunder. These are capacitors, not resistors. I'm so sorry. These are capacitors, guys. Just 1 second. Wow. Where did it go? See, these are capacitors. So when they are in series, then I should actually use this 1 by x plus 1 by y is equal to 1 by 3, because they will have parallel formula. And when they are in parallel, they will just add. So 16 is basically x plus y. So now it is solvable. So again, do the cross multiplication. So you will get x plus y divided by xy is equal to 1 by 3. But x plus y is 16. So 16 by x into, instead of y, you can also put it as 16 minus x is equal to 1 by 3. Cross multiply. This will become basically 48, right? This will be equal to 16x minus x square. That's it. So you will get x square minus 16x plus 48 is equal to 0. So the values of x that you will get will be basically 12 and 4. So that should be the answer. 12 and 4. So once you get 12, the obvious next answer will be 4. So if x you get it as 12, y will be equal to 4. Is that okay? Yes. I hope this is clear. Everybody with me on this? Shall we go ahead? Pakka? So you just had to form two equations. One is for parallel, one is for series. Solve it properly till you get the answer. You might get a quadratic answer. Some of you will be asking, sir, can I substitute and get? Yes, you can definitely do that. Like this can't be the answer, because if you add them, you will never get 16. If you add them, you will never get 16. This can be, this can be, this can be. So then you have to try what will happen when they are in parallel. So again, you try. If they are in parallel, do you get 3? Do you get 3 over here? Do you get 3 over here? Maybe B and C will get eliminated. Then also you can get the answer. Both options, both methods are okay. Both the methods are okay. Okay, fine. Let's move on to the next one. The capacitor is charged by a battery. Then it is disconnected from the battery and connected to other uncharged capacitor as shown. The electrical energy stored by the system is how much? That is the question. The electrical energy stored by the system is basically how much? So over here, what we need to do, this is charged as shown. It is disconnected. So the moment you charge, there will be some charge on it, which is given by CV. The C value is basically 900 pico. So 10 to the, I'll just put it as P only, it's okay. 900 P into V, which is basically 100. So that will make it 90,000, no, 90,000, yes, 2 zeros and 2 zeros over here, pico over here. That is the amount of charge on it, which is basically 9 into 10 to the power 4 pico. Just keep it as it is. This is picocoulomb. Okay. Now, once you disconnect it and connect it to the another capacitor, which is also having the same capacitance, that charge will get distributed. that charge will get equally distributed because the capacitances are same. So here you will have 4.5 into 10 to the power 4 picocoulomb. Here also you will have 4.5 into 10 to the power 4 picocoulomb. The question says, what is the energy of the system? What is the energy of the system? So the total energy of the system, you find any one energy using half CV square multiplied by 2. Multiplied by 2 because both capacitors are there. 2 gets cancelled, so it will become CV square. Capacitance is how much? 900 pico. So 900 pico is there, so 900 P, and into voltage. Okay, now if you don't like this formula, because we'll have to find the voltage first, better to go with Q square by C formula. Better to go with Q square by C formula because charge is known over here. So I can use half Q square by C because charge was known in this case. 2 anyways got cancelled. Charge square, which is 4.5 into 10 to the power 4 pico, square it, whole thing divided by capacitance, which is 900 pico. Solve this, you will get the answer as 2.25 10 to the power minus 6. Okay, so solving this, you should get the answer over here. Is that clear? Why we multiplied by 2? Because there were 2 capacitors, as simple as that. Very good, very good. Let's go ahead to the next one coming up on your screen, and after that we'll slowly have a lunch break also. Very soon we'll have a lunch break also. Okay, before going to magnetism. A parallel plate capacitor has a uniform electric field in the space between the plates. If the distance between the plates is d and the area of the plate is a, the energy stored in the capacitor is, okay, this is straightforward. The energy stored in the capacitor is half into C into V square, C into V square, C into V square. Capacitance is epsilon naught A by D. Voltage is electric field by distance. So square it. So I will get half epsilon naught A E square, and here I will have D square. Just check this out. Half epsilon naught A E square, and I will have D square. Is the answer given in terms of everything over here? I think they have missed a few things. Area. Okay, we can write it in this terms also. We can write it in this terms maybe. Doesn't look like. Where is that D square going to go? Volume is not given. The energy is stored in the capacitor. I think there is a printing mistake over here. Just ignore the options. Just ignore the options. I think there is a printing mistake. This should have been half epsilon naught A E square, and then there is D square, and then there is one more D over here. So this should have been D cube actually. This should have been D cube. Okay. So this should be the correct answer, right? Half epsilon naught A E square by D cube. Yes, D cube. Yep. Check this out. Yeah. Just check this out. D cube. Yes, yes, yes. Vibhusha, I made it D. Oh, I think I know what mistake I did. Looks like I need a break now. Clearly. It should have been half. Capacitance is epsilon naught A by D, and electric field is dV by dr, so V by D. So voltage is E into D, E into D. So if I put over here, instead of voltage, E into D whole square. So I'll get half epsilon naught A, and then E square D square by D. D gets cancelled. So I'll get half epsilon naught A into E square, and then one single D will be there. Then it goes to option D. Yes, it is correct. Perfect. There you go. Cool. V is ED. I wrote V is E by D. Happens. I'm also a human. Okay. Equivalent capacitance of the combination shown in the figure. What do you do in this situation? A very interesting scenario arising over here. This wire is directly connected across this capacitor. What is going to happen? One capacitor is just going to go completely waste. Why? Because this point, this point, this point, this point, this point all have the same voltage. So it is a completely useless capacitance. Now you just have to account for these two capacitances, and they both are in what combination? They are in parallel. If they are in parallel, just add them. You should get the answer as 2C. 2C. Is that right, everybody? Understood what we just did? This is useless because it is shorted. The voltages are same. They are connected by the same wire. So voltage difference is only not there. What will it store? Only voltage difference can store the charge. Yes, correcto. All right, shall we move ahead to the next one? Coming up on your screen. Get ready, guys. Get ready, get ready. Coming up on your screen. What does it say? It says the capacitance of a parallel plate capacitor with air is this. With a slab, it becomes 30. The permittivity of the medium is how much? Question is, what is the permittivity of that particular medium? See, with the medium, if the capacitance becomes K times, first of all, we can find the dielectric constant of the medium. Because the new capacitance is 30, old capacitance was 6. The dielectric constant is basically 5. And permittivity of the medium is the dielectric constant into permittivity in vacuum. So it will be 5 into permittivity of vacuum, which is 8.85 into 10 to the power minus 12. Come on, 8 5s are 40. So close to that is what you should get the answer. Yes, 0.44 into 10 to the power minus 10. Yes, very good. So you should get the answer over here as close to 44 into 10 to the power minus 12, which you can shift the decimals later on and write it as 0.44 into 10 to the power minus 10. That is what it is. Because 8 5s are 40, so it will be slightly more than 40, maybe around 44. So 44 into 10 to the power minus 12, shift the decimals. That's how you can get it. Cool. That was a NEET 2021 question. Two formulas are there. Adding a slab increases the capacitance K times. Second, permittivity is dielectric constant into permittivity of vacuum. Okay, permittivity of vacuum. Keep this in mind. Moving ahead to the next question on your screen now. What does it say? A parallel plate capacitor of capacitance is being charged by a voltage source whose potential is changing at the rate of this. The conduction current through the connecting wires and the displacement current through the plate of the capacitor would be respectively. This is actually a electromagnetic waves question because the displacement current and conduction current concept comes over there. But we know both of them should be always the same, conduction current and displacement current. So D can't be the answer. Even B can't be the answer. Even now A and C can be the answer. Now A won't be the answer because voltage is changing, capacitance is there. So how will it be 0? I mean 0 can't be the answer. There will be some current, no? So this also can't be the answer. So option should be C. So without solving only we can mark as option C. Within 5-6 seconds you can mark the answer without solving the question. Did you understand? Because always remember, conduction current is the displacement current. Now how do you find this? This is dq by dt. So remember, charge is nothing but capacitance into voltage. Capacitance being constant, it will be just dv by dt. So the conduction current, which is also the displacement current, is C times dv by dt. So capacitance, how much is it? 20 micro. So 20 into 10 to the power minus 6. Voltage change is 3 volts per second. So 23 is a 60. So 60 into 10 to the power minus 6. So 60 micro amperes is the answer, which is option C. Perfect. Okay. So displacement current and conduction current both are the same thing. If you have forgotten what is displacement and conduction current, quickly, the current which actually flows in the wire due to electrons is called conduction current. But when you have charges changing and field which is changing and the field is not constant, that field which changes makes the surroundings believe that as if there is a current flowing, and it produces a magnetic field just like this actual current was producing magnetic field. So even this electric field ends up producing the same magnetic field, and it is not because of actual current, it is because of something called as the displacement current, which is equivalent of that current which produces the same magnetic field. Okay, it is not because of charges, it is because of electric field. This is actually because of the charges. I hope you remember that difference now. Okay, revise that theory. So let's do moving charges and magnetism. Let's see how many questions are there in this. If it is very less, then we can just do it before the break. No, doesn't look like it is less. Okay, so we'll take a small break then. We'll take a lunch break because this chapter is definitely going to be a big one. Okay, cool. So we will meet after the break then. So where is my break slide? It's okay. Even if my break slide is not there, I'll just write it over here. The time is now 1:10. We'll meet at 1:30. Meanwhile, please like. Remember, you are a part of 4-day challenge. Where we are solving 1000 plus PYQs. Okay, I'll see you in a bit. Okay, 1:30 p.m. Hello, mic check, mic check. Let me know if I'm audible and visible, guys. Join in. Happy afternoon, Pratyusha. Yes, Capto is back. Hello, Anu. Yes, 1:30. Captain is back. Don't worry. So let's begin. Let's begin with the lecture. And before the lecture, before the break, sorry, we completed capacitors, current, electricity, and electrostatics. Now it's time to move on to magnetism and then ray optics, wave optics, and modern physics. Okay, let's go with full josh, full energy. We'll have minimal breaks after this, like it will be just a 1 minute break for water. That's it, but we'll go in the flow. We'll try to complete as much as possible. Okay, so starting off with the next question. Long straight wire of length 2 meters, mass is suspended horizontally in a uniform magnetic field. The amount of current flowing through the wire will be. If it is suspended horizontally means, there are no net forces acting on it. So the weight of it, which is mg, is balanced by the force of magnetism, which is basically ILB. So essentially, ILB should be equal to mg, or rather the current will be mg by LB. Mass of the wire is 0.25 kg, gravity is basically 10, then length of the wire is 2 meters and magnetic field is basically 0.7. Solving this, you should get it as 2.75 amperes. 2.75 amperes. Simple question because it was suspended. That means it is in equilibrium. It is at equilibrium, so net force is going to be 0. That is the keyword. So read every word carefully. Moving to the next one. Uniform field, uniform magnetic field, same direction in a certain region. Electron is projected such that the velocity is pointed in the direction of the fields. Then what do you think the electron will do? So you should know what individually the fields will do. Then you will be able to understand it. So uniform electric field is there and electron is projected. So guys, imagine the electric field is in this direction and the magnetic field is also in this direction, and you are taking an electron, and throwing it here with certain velocity. First of all, because of the magnetic field, the QV cross B force will be 0 because velocity is parallel. So sine 0 happens to be 0. So no force due to magnetic field, but due to the electric field, the force will be here. The force will be here, which is going to be Q into E. Q is the charge, E is the electric field, and this will cause retardation. The acceleration will be here, velocity is here. So the speed will reduce, but it will move in the straight line. So option C is correct. I hope you understood it. The magnetic field has no effect because the directions are parallel, but the electric field is what is going to reduce the field. Moving on to the next one on your screen. Wire is carrying some current. It is kept in the magnetic field. The magnitude of the magnetic force acting on it is how much? So the formula that you need to use is F is equal to I length cross B. That is the actual formula, not just ILB. This is in vector form. The length is how much? Has length L. Directly it is given as L, but it is in the x-axis, so it is L I cap, and magnetic field is basically 2 I cap plus 3 j cap minus 4 k cap. That is what the magnetic field is. So this will become I. This, do not confuse with this I. If you want, you can put it as a different symbol, capital I, so that there is no confusion. Okay, so I cap does not go with I cap. I cap gets multiplied with j cap. So I cross j is k. So it will become 3L. I cross j will be k. So 3L k cap. I goes with k. I j k. So I cross k will be minus j. So minus minus becomes plus. So it will become plus 4L j cap. 4L j cap. So that's it. That's what it is. And now this is the total force. So if I want to find the magnitude of the force, IL is common, so I will just take 3 square plus 4 square, which will make it root 25, which is 5. So 5 times IL. That should be the answer. 5 times IL. Yes, option B is correct. Option B is correct. If you are wondering how I did the cross multiplication, remember this goes with this. I cross J will be basically K cap. And over here when I multiply this with this, remember I cap cross K cap is minus J cap. So minus and minus became plus. This minus and this minus became plus. That is the logic behind this. So is that okay, my dear students? Understood how we have done it? And once I got the components, both are perpendicular, so you find the magnitude by squaring them, adding them and putting them under the root. That's all. So the magnitude of the force is asked. Read the question very carefully. The magnitude of the force is asked. That's why I have taken mod. Right. Moving on to the next question. This was 2023. Next question from 2023 is, this was a standard question. This has been asked many different ways. Question is, what is the magnetic field at that particular point? Now, at this particular point, the magnetic field is due to the semicircular arc plus the wire here and here. So if you just consider the semicircular wire, if you consider just the semicircular wire, which is right over here, due to that, if you use a right hand thumb rule, current is going anti-clockwise, thumb will come towards you. Thumb will come towards you. So due to the arc, the magnetic field is towards you. It is given by mu naught I by 2 times of R, but half of it. Why did I take half? Because for a complete coil it is mu naught I by 2R. For a semicircular coil it will be half of it. So it is mu naught I by basically 4R. Now talking about only this wire or even this wire, this is a semi-infinite wire. So the magnetic field due to a semi-infinite wire, okay, what is the formula for it? What is the formula for it? It is nothing but mu naught I by 4 pi small r, or basically the distance. In this case, you can see the distance itself is r. The distance itself is r. So it is basically 4 pi r due to a semi-infinite wire. Both the wires same current, so they will produce the same magnetic field. This wire carrying current here, the magnetic field lines will come from the top, go below like this. They will go inside. They will go inside because of the top wire. They will go inside. And due to this wire, the current is going like this. Again, the magnetic field lines, using your right hand rule, they will again go inside. Hold your thumb in the current direction, the curled fingers pointing inside over here, over here, over here. It is going in. So both times it is inside. So the total magnetic field will be into 2 because there are 2 such wires. So that is why it will be mu naught I by 2 pi r. Mu naught I by 2 pi r. So the total net magnetic field, will be not the addition but the subtraction, because one is coming out, one is going in. Who is bigger? I think this is bigger. 2 pi will be, yeah, obviously this will be smaller, this will be bigger. So this is obviously going to dominate. So mu naught I by 4r minus mu naught I by 2 pi r. That is what it should be. Now take common brackets, and you will see correct answer is basically option B, pointed away from the page, because this is there and that is also there. Yes, perfect. Yes, there you go. Is that clear, my dear students? Everyone? Awesomeness, awesomeness. Let's move on. Let's move on. Let's move on. Next question. A closed packed coil having 1000 turns has an average radius this much. Okay. If the current carried by the wire of the coil is 1 ampere, the value of the magnetic field produced at the center of the coil will be, permeability is this much. A closely packed coil having this many turns, okay, has an average radius. Okay. So basically this is a question on toroid, guys, nothing else. The magnetic field of a toroid coil is nothing but mu naught n I divided by 2 pi r. That's all. So mu naught is basically 4 pi 10 to the power minus 7 number of turns is basically 1000 and current is basically 1, 2 pi as it is, radius is 62.8, which I can write it as 2 pi into 10, because 2 pi is basically 62.8, 2 pi is basically 62.8, but in centimeters, because 2 pi is 6.28 into 10 will make it 62.8, and again multiply 10 to the power minus 2 to make it into meters. That's all. So that's it. Pi will get cancelled, one of the pi will remain, and what else is there? The value of the magnetic field at the oh, this is, I'm so sorry, this is not a toroid. I'm so sorry. This was just a normal coil, regular coil. So sorry. We don't need to use the toroid formula at all. This was just a regular coil with many terms. Sorry, this was a closely packed coil. So the magnetic field at the center of the coil will be just mu naught I by 2r, but there are n turns, so into n. Mu naught value is 4 pi 10 to the power minus 7. Current value is 1. Number of turns is 1000. And radius is 62.8. 62 I can write it as 2 pi multiplied by 10 and convert it into meters like this. That's all. So now 2 pi into 2 will become 4 pi. So 4 pi will cancel. So you will see 10 to the power minus 7, 10 to the power 3 over here, and this will become 10 to the power minus 1, I believe. So this will become minus 6 and 3 will become minus 3. So 10 to the power minus 3, which is option number A. Yes, that is the correct answer. Perfect. Is that clear, everyone, with me? Yep. Yeah, normal coil. Yes, Krishna. It was a normal coil, not a toroid coil. So we don't have to use any other formula. It was just a normal regular coil. Next one coming up on the screen. The shape of the magnetic field lines due to a long straight current carrying wire. This is standard thing. If you have a wire which is long carrying some current, the magnetic field lines, how do they look like? They are like this, concentric circles, right? The magnetic field lines are concentric circles. So that's it. That should be the answer, circular in nature. This is straightforward. There is nothing to calculate over here. Very good. Moving on to the next one on your screen. Two very long straight parallel conductors A and B carry some current and are at distance of 10 from each other. The direction of the current in the two conductors is the same. The force acting per unit length between them. The formula for force acting per unit length, remember, it is mu naught I1 I2 divided by 2 pi d. That's all. Mu naught is 4 pi 10 to the power minus 7. Current 1 is 5. Current 2 is 10 divided by 2 pi into distance between them 10 centimeter, which is basically 0.1 meter. So that's it. 4 goes with 2. 2 times 2 5s are 10. Again, this pi and this pi also goes. So you will have 10 to the power minus 7 and then 10 over here and then 0.1 over here. Just check this out. I think the answer will be, first of all, they are in the same direction. If they are in the same direction, what does it mean? If the direction of the current is same, will they attract or repel? Obviously, they are going to attract each other. They are going to attract each other. So it should be attractive in nature. So it should be option D. It should be option D, 100%. It should be attractive. It should be attractive. It can't be repulsive. Next thing is, I am seeing only powers of 10. So yes, directly I can mark it without even having to calculate. But yeah, you can calculate. So 10 raised to 3, 10 to the power minus 7 will make it 10 to the power minus 4. Yes, that is the correct answer. Did you understand what I just did over here? After this, I know it has to be 1 into 10 to the power something. It can't be these two. It can't be these two because there is no number over here. Second thing I saw from here, current direction is the same. That means it has to attract. So this can't be the answer. So only option left is option D. Directly you can mark it. Right? Shall we go ahead to the next one? Yes, D for doctor is the correct one. Moving on, the magnetic field on the axis of a circular loop of radius 100 centimeters carrying current is this much ampere. At a point 1 meter away from the center of the loop, what is it given by? Okay, so basically you have a loop and on the axis of a loop of radius this much, the point 1 meter away. Okay, Question is, what is the magnetic field? The radius is also 1 meter only. The radius is also 1 meter only. Okay. The current is √2 amperes. So the magnetic field formula is given by mu naught I. You have R over here, 2 over here, R square over here, R square plus X square, R square plus X square whole raised to 3 by 2. This is the formula for the magnetic field on the axis. Everything is given, just substitute it, nothing else. Mu naught is 4 pi into 10 to the power minus 7. Current is √2. Radius is 1, so 1 square divided by 2 into 1 square plus 1 square raised to 3 by 2. That's it, guys. I mean, 1 square plus 1 square is 2. 2 raised to 3 by 2. Just check this out. It will become 4 pi 10 to the power minus 7 √2 divided by 2. Here 2 raised to 3 by 2. 2 raised to 3. 2 raised to 3 is 8. So root of 8, which is 2 √2, which is basically 2 √2. So I'll just put it as 4 pi 10 to the power minus 7 into √2. Whole thing divided by 2 into root of 8 is 2 √2. 2 2s are 4. So √2 also cancels. So it will become pi into 10 to the power minus 2, I believe. So just check if it is fine, everything. Yes. Did we miss anything? √2 amperes, unless this was some microamperes or something, I think, or maybe some milliamperes or something, it will be fine, but otherwise everything else is correct. So I should get it as 10 to the power minus 2. I think this was 10 to the power minus 2 if I'm not wrong, right? Just check this out for this given value of current, for this particular given value of current. Just check this out. This makes sense. Cool. Okay, everyone, understood what we just did over here? Perfect. Can we go ahead to the next one coming up on your screen? Here it is. A long solenoid of radius 1 millimeters and 100 turns are there. 1 ampere current is flowing through the solenoid. The magnetic field strength at the center of the solenoid, how much it is? At the center of the solenoid, how much it is? That is the question. Okay, so simple, magnetic field at the center of the solenoid is mu naught Ni. Mu naught is 4 pi 10 to the power minus 7. 100 turns is there per millimeter. 1 millimeter is 10 to the power minus 3 meters. Current is 1. That's it. So everything is in powers of 10. So 4 pi into, this will become 10 to the power 3 on the top with 2 more zeros will make it 10 to the power 5. Plus 5 and minus 7 will become minus 2. So 4 pi into 10 to the power minus 2 Tesla. 4 pi is approximately 12 point something, because pi is 3, 4 3s are 12, so 12 point something, 10 to the power minus 2 Tesla. That is the answer. Next one. From Ampere's law, for a long straight wire of a cross section carrying a steady current, the variation of the magnetic field inside and outside the region. Read the statements carefully. You will realize this is actually a theory question. This is actually a theory question. So if you have a long wire, certain radius r, you will see that there is magnetic field inside also, and also outside, that particular wire, and if you happen to draw the graph of magnetic field versus distance, you have to draw the graph separately, inside and outside. Inside, if you remember, it is directly proportional to the distance, and outside, the moment you go, it is inversely proportional to the distance. So this is how the graph looks like for a long straight wire of circular cross section carrying some current. So the answer should be linearly increasing function up to the boundary, and then linearly decreasing for the outside region, then decreasing with, oh no, B option is not correct, sorry, it should be 1 by R. This should be the correct answer, guys. This should be the correct answer, C option. It is then decreasing with 1 by R dependence on the outside region, 1 by R. So here it is basically linearly dependent, proportional to R, and the moment you go outside, it is 1 by R. It is 1 by R. Yes, yes. Okay, I hope this is clear. Right. Krishna, in the previous question, Where did it go? Here, this one. 10 to the power 3 will go on the top. 3 plus 3 zeros and 2 zeros will give you 5 zeros. Minus 7 plus 5 will make it minus 2. So 4 pi 10 to the power minus 2. Okay? Is that okay? Fine? Clear? Great. Let's move on. Let's move on. So I think I should, go to the next one coming up on your screen here. Yes. What is the next question? A thick current carrying cable of radius r carries current I uniformly distributed. The variation of the field with the distance is exactly what I gave you in the previous slide. Same question in 2021 and same question in 2022. See guys, this is the graph, proportional to r, inversely proportional to r. So it decreases outside with 1 by r dependence and linearly increases with proportionality r dependence. So this is the exact graph which you get. So answer should be option A. Yes. Acha, the previous question after this also. Okay, in that, what was it? What was it? Wow. You know what I have done? This is 7. While writing over here, that 7 looks like 2. So nice. So nice. So, while writing over here, that 7, I've just written that like that. That 7 looks like 2 and I thought it was 2. It is 7 only. So, it is 10 to the power minus 7. Everything gets cancelled. 2 2s are 4 pi and pi is just 3.14. Root 2 got cancelled. So, it is pi basically into 10 to the power minus 7. Everything was fine. So, there was no minus 2 over here. Everything was okay. Alright. Cool. Shall we go ahead? Next question. Krishna, I hope this was clear. Next one coming up on your screen. Next one coming up on your screen. What is this question saying? This question is saying that we have a long straight wire. I think this is that long straight wire, carries 5 amperes. Okay. An electron is moving with some speed parallel to the conductor. Perpendicular distance is also given. Find the force experienced by it. So there are two concepts which I think will be involved in this particular question. Yes. Two concepts which will be involved in this particular question. What are those two concepts? Think. First concept will be, due to this wire, there will be a magnetic field here. So you hold the current in this direction, so thumb in this direction. So there will be a magnetic field which will be coming towards you. So that magnetic field will be given by mu naught I divided by 2 pi into r. Now that magnetic field which is coming towards you is perpendicular to the velocity. So there will be a force acting on the charge. So it will be Q V cross B. So it will be Q into V into B and angle is 90. So sine 90. The charge is basically electron charge. Velocity is V. Magnetic field, just directly import it from here, which is nothing but mu naught current by 2 pi r. Everything you know. Electron charge is 1.6 10 to the power minus 19. Velocity is 10 to the power 5. Mu naught is 4 pi into 10 to the power minus 7. Then what else is there? Current is basically 5. The whole thing divided by 2 pi r. So 2 pi into r. R is 20 centimeters. That means 0.2. That's it. Everything has been substituted. Everything is known. Just calculate the value and see if you get it as 8 into 10 to the power minus 20. 8 into 10 to the power minus 20. Even without solving, I think you can guess the answer little bit here and there. I'll tell you how. Just look at the numbers. 16 and 5. 16 5s are 80. 16 5s are 80. So forget that 0. Think about 8 only. 2 2s are 4 below. Forget the decimals. 2 2s are 4. 8 divided by 4 is 2. 16 and 5 becomes 8. 16 5s are 80. Okay, 8 and this 4 will make it 2. 2 4s are 8. So 8 is there over here. Pi got cancelled. So pi can't be there in the answer. It has to be 8. Forget the powers of 10. Directly you can mark 8. That's how you can simplify the calculation in the examination. Quickly you can calculate. Did you understand the trick what I did? Perfect calculation trick, that is. Forget the powers of 10 and the decimals and the zeros. Just take care of the numbers. Pi has gone out, so pi can't be there in the answer. It has to be either this or this. So what is the number that you are getting apart from the power of 10? If you are getting it as 8, directly mark it as 8. Don't bother about the powers of 10. Moving on, next question coming up on your screen. Long solenoid, this much current, this much turns, the field at the center of the solenoid directly. This was second time this question has been repeated with different values. So 4 pi into 10 to the power minus 7 number of turns is 100, but for 50 centimeters, that is half a meter, current is 2.5 amperes. So directly you should get the answer as 6.28 and into 10 to the power minus 4 Tesla, right? 1 pi will be there, 1 pi will be there, 1 4 and this 0.5 and 2.5, guys. This will go 5 times. You can see that this will go basically 5 times. 5 4s are basically 20, and then pi, and then 10 to the power minus 7. That is what you're going to get. Cool. I hope this is very clear, and this 2 zeros is also there. So this will make it 2 pi into 10 to the power minus 4, which is 6.28 into 10 to the power minus 4, which is your D option. Cool, guys. These are direct substitution formula based question. Nothing great over here. Nothing great over here. Let's move on. Next question coming up on your screen. Okay, this is done. A cylindrical conductor of radius r is carrying some current. The plot of the field versus the distance from the center is correctly represented by, guys, third time it has got repeated. That means it shows how much important it is. How much important it is. We just did it. If you have a conductor carrying current, inside the field varies linearly, outside it varies inversely. So it has to be option D. Third time this concept got repeated. Magnetic field inside the solenoid 2 times in just last 5 years. So it shows what topics you need to study, what topics are more probable in the examination. Seeing it? Very good. Moving on, next question on your screen. Ionized hydrogen atoms, alpha particles, same momenta, enter perpendicular, the ratio of the radii. Standard kind of question, even these years you can see popular variety of question is this, where the radius of 2 different particles is asked inside magnetic field. Radius is mv by qb. mv is momentum, so it is p by qb. Momentum is same, if I'm not wrong. Yes, magnetic field is obviously same. So radius is inversely proportional to the charge. So radius of hydrogen upon the radius of alpha will be charge of alpha upon charge of hydrogen. Charge of alpha is 2e. Charge of hydrogen is just e. So it is 2:1. So 2:1 should be the answer, which is option B for biology. Right? Simple, easy peasy. Moving on to the next one coming up on your screen. Magnetism and matter, going on. These questions will not be too many. Usually they ask very few questions, if you notice, and that is what we'll see. Not many questions will be asked over here. But it depends completely on the luck, and it depends on how much theory you have studied, and it can be a boring chapter at times, magnetism and matter, because it's little bit theoretical and little bit not so I would say application based. It's more of those formulas and those theory points. So sometimes people leave this chapter, but if you have completed other chapters of high weightage, I would advise you, please complete this. The variation of susceptibility with absolute temperature of paramagnetic material. For paramagnetic material, the Curie's law comes into play, and the susceptibility is inversely proportional to temperature. So the graph should be basically this one, because this is 1 by T. If you notice, this is 1 by T. So susceptibility is directly proportional to, bring that time on the top, it will be 1 by T. 1 by T over here. So it is directly proportional to this. So it has to be a straight line if you put susceptibility here and 1 by T over here. Correct? It is inversely proportional to temperature, directly proportional to 1 by temperature. So hence option 1 is the correct answer. That is Curie's law. If you increase the temperature, the magnetic properties decrease, susceptibility decreases. That's what it is. Anyone tell me, doctor, forget anyone, I will tell you. Okay, you only answer in the chat box. Is only formulas enough, only physics formulas enough to get 100 marks in NEET Physics? Think about it and tell me. Okay, meanwhile we'll start solving this problem also. Big circular coil, 1000 turns, average radius is rotating about horizontal diameter at 2 radians per second. The vertical component of the Earth's magnetic field is this much and the electrical resistance of the coil is this much, and the maximum induced current. I think this was from electromagnetic induction, but it's okay, we can still solve it. Yeah, so guys, it is definitely not going to be enough just knowing the formulas, because if you just know the formulas and go to the exam center, what will you do? You should know where to substitute, when to use what formula. Sometimes there will be two formulas to be used. Sometimes there will be case based formula. For example, gravity at a very small height has a different formula. Gravity at a very large height has a different formula. So you should know when to use what. And you should know how to equate. Sometimes it will be given the maximum height is 3 times of the range. So you should know how to equate them. You should have practiced a lot of problems. So understand that it is not going to be enough. See, there will be many YouTube videos. I don't know why people make such videos saying, oh, you just do formulas and you'll get 100 marks. Just I'm giving you the sheet. Pakka, pakka, pakka. I don't know. I mean, this is not possible, guys. So please do not, go after such videos. In fact, I would suggest follow this channel. In fact, I would say follow the lectures over here, and those 100 marks I will guarantee you easily. I mean, I will guarantee you even more than that if you follow the plan, if you follow the lectures, and if you understand how to use these formulas. Just see how the problems are being solved. Just watch the one-shot classes over here. That's enough. Okay? Yeah. Now, what to do over here? Yeah. So basically, you have some turns, you have some radius, and actually, this is a problem of electromagnetic induction and AC, which I think was misplaced over here. So the magnetic field is given, the electrical resistance is given, and everything else is given. So if you have a coil and this is the diameter and you rotate it like this, then the EMF induced in it is given by Born, BA omega n sine omega t. So this is your amplitude, which is called as E naught. So the current which will be introduced in it, the maximum current, will be E naught by the resistance. So it will be BA omega n divided by the resistance. So that's it. Substitute everything, you will get the answer. B you know, A you know, omega n, everything you know. Magnetic field is 2 10 to the power minus 5. Then area. Area you don't know, but directly you can find it out indirectly. Radius is 10 meters. So pi r square. Omega 2. So 2. Number of turns 1000. So 10 to the power 3. The whole thing divided by resistance. Resistance is 12.56. 12.56. You know, this is a special number actually, 12.56. If you realize, this is actually 4 pi. Deliberately they have given, because the pi over here and pi over here will get cancelled. Okay, solve this and see if you get the answer as 1 ampere. I mean, directly you can solve it. I mean, mentally also. 2 2s are 4. 4 and this 4 gets cancelled. Pi and pi gets cancelled. So the answer will have powers of 10 only. And the powers of 10 are getting cancelled. So answer is coming 10 to the power 0, which is 1. So answer is coming out to be 1 ampere, guys. Just check this out. Is that okay? Straightforward. Yeah, calculations are very simple. So sometimes many people will start dividing. But if you are a little bit smart, you have solved many problems, you will realize, 6.28 is 2 pi, 12.56 is nothing but 4 times of pi. So few things here and there, if you remember, na, it will become very easy for calculation purposes. That's all I would say. Okay, next question on your screen. Here it is. In the product F is Q, V cross B, V is as it is. Magnetic field has 3 components, of course. Q is 1, velocity is this, force is this. What will be the complete expression for B? Guys, I'll tell you what. This question was a sick question. I mean, the person who made it literally had a very bad day. I think his wife fought with him that day, or his kids were not listening to that person, or I don't know, some problem was there in his family that day. So because of which he made this question. See, velocity is given, magnetic field is given, finding the force easy. This is opposite. I mean, like, force is given, velocity is given, magnetic field is asked. Do you understand it? Yes, cricketer, city intimation slip is out. Yeah. So one way to do it is, trial and error, try out each and every value over here and see whether it matches, right? Or else, like, there is no other simple method because there is no vector division. See, if you want to find magnetic field, force is nothing but 4 I cap minus 20 j cap plus 12 k cap is equal to, charge is 1 only, forget it, velocity is 2 I cap plus 4 j cap plus 6 k cap, cross what components? Something I, something j, something k. The problem is I don't know x, I don't know y, I don't know z. I don't know I don't know y, I don't know z. These are the components of the magnetic field. So one option was you try each and everything and see if it works out. Other option is you solve this, like you will have to literally expand this using your determinant method. You will get some expression in x, some expression in y, some expression in z, and then match it whether it is matching over here. That is one lengthy way. I mean, these are the only two ways to solve it. I hope this is fine, or maybe not fine. But if you're a little bit smart, what you will do is you will think a little bit, sir, he had a bad day. The person who said that paper was a sick person. But I am little bit smart, sir. So what you will do is you will just look at the I component, 6i minus 8i minus 6i 8i. All the I cap components are different. If I even get one component, my job is done. So how can you get I component? How can you get I component? You think about it. There are only two ways by which you can get I component. One is J with K and the other one is K with J over here. These are the only two ways you can get it. So 4J cross ZK, 4J cross ZK, J cross K is I. So it will become 4Z basically, what is it? 4Z basically I cap over here. And then what you will do is multiply K with J, that will also give you I cap. So but it will be minus I cap. So it will be minus 6y I cap. So basically it will become 4Z minus 6y, and here you will have I cap. Forget the rest of the terms, j cap and other things. Just over here, look at it. This is 4 I cap. So 4 over here and 4 over here should match. 4 I cap is the coefficient here and the I cap's coefficient should match. So basically your logic will be that somehow 4 should be equal to 4 times the z component minus 6 times the y component. So in every option what you will do is check the z component and check the y component, do this and see if it is equal to 4. Like for example over here, 4 into z means 4 into minus 8, 4 into minus 8, minus 6 into y means 6 into 6. Is it equal to 4? Is it equal to 4? No, right? If it is not equal to 4, this option is eliminated. This option is eliminated. The method of doing this is much simpler. It is little bit easier because you are only eliminating options and you are only checking one component rather than checking x, y and z, all the three. So I think this option will match, maybe option C. So you just find out, 4z minus 6y. Just find out 4z minus 6y. You will see that it will be basically 4. Is that clear? Understood what we just did? So usually many people will leave this question. That is okay. But if you don't want to leave this, you want to score 180 out of 180, then this is the shortcut trick which you can use, is what I told you. Perfect. Let's go ahead to the next one. A uniform conducting wire of length 12A, resistance R is wound up as a current carrying coil in the shape of an equilateral triangle square. The magnetic dipole moment of the coil in each case respectively are. Okay, 12A. So first, if you make it as an equilateral triangle, A, 12 12A, right? So 3A is the perimeter, 4 turns will be there. 4 turns will be there, each side length is A. And second time, it's a square, so 3 turns will be there. A will become 4A, 4A, 4A will make it 12A. So basically 3 turns will be there. If you take the magnetic moment of a square, which is number of turns into current into area, number of turns 3, current I, area A square over here. So 3IA square will be for the square. For the triangle, the magnetic moment, if I use NIA for the circle, number of turns 4, current I, area is the problem. What do you think is the area in terms of the side? Area in terms of the side. In fact, you don't even have to, oh no, we'll have to do the math, because I can see 3IA square is there here also and here also. 3IA square is there here also, here also. This can't be the option, this can't be the option. But think logically, guys. Think logically. In the exam, if you had to choose between A and B, will you choose A or will you choose B? Will you choose A or will you choose B? Tell me, guys. Will you choose A or will you choose B? See, when you find the area, half base into height, when I find height, some root component will be there, root part will be there, because I'll use sine 60 or something like that. So it will definitely have some root in it, I realize. So I will go blindly with this option and let's find out whether it is correct. Yes, it is correct. So this is the kind of techniques I use to solve, objective exams, and my students also use these things. They don't completely solve the problem. Now a normal student, what will he do? He'll find the area of a triangle. How? They will say this is A. Okay, the height is how much? The height is basically, this is 60 degrees. So it is A sine of 60. So it is basically A root 3 by 2. So what is the area? It is half base into height, which is A root 3 by 2. So it will be 2 to cancel. So A square root 3 by 4. So substitute it over here. So it will become A square root 3 by 4. 4 cancels and you will get IA square root 3. IA square root 3 is option B. Same thing I was getting, but unnecessary wastage of time. Understood, guys? How we solve it? And I hope you are learning all these tricks. I know you might be thinking, sir, you are brilliant. You are able to think about this. How will I think? Trust me, if you watch all my classes, see how I'm solving problems, you will also be tempted to use these things in the problem solving of whatever books you have. Just apply these methods and over time, you have still 1 month to go. You will see that you will use these tricks in many problems in NEET Physics and you will complete the paper well in advance. Other people will be struggling, you will be using my tricks. Very few teachers know these things, especially in the NEET, because NEET Physics, JEE Physics still I can say that, but NEET Physics very rare. Very rare. Okay, moving on. An iron rod of susceptibility subjected this much, the permeability of the rod is, the susceptibility is given. Susceptibility plus 1 is the relative permeability. So it will be 1 plus 599, which is 600. Relative permeability is permeability of the medium upon permeability of free space. So medium's permeability is 600 into mu naught, but mu naught is nothing but 4 pi into 10 to the power minus 7. That's it. So 6 4s are 24. So 24 pi into 10 to the power minus 5. 24 pi into 10 to the power minus 5. Where is it? Is it there somewhere? Yes, it is option D, because you can shift 1 decimal and make it 10 to the power minus 4 also. Shift 1 decimal. Yeah, it will become 2.4 into pi into 10 to the power minus 4. Yes, perfecto. Understood? Clear? Yep. Let's move on. I hope you guys are liking the session, not literally also, but also otherwise. Yeah, I hope you have smashed the like button down there. Moving on to the next question on your screen. A point on the Earth's surface, dip angle has been deleted, so no point discussing this. Let's go directly to the next chapter. Yeah, electromagnetic induction. An EMF is generated by the generator, this much turns, loop area, coil rotates at this much speed, uniform field of this much. What is the maximum value of the EMF? The maximum value of the EMF is born BA omega n. This is the formula. Magnetic field 0.05, area 1 meter square, omega 1 revolution per second. So first of all convert it, 1 revolution per second. 1 revolution is 2 pi radians, so 2 pi radians per second. 2 pi radians per second. So here I will put 2 pi, and then the last thing, number of turns is basically 100. So that's it. I think you should get the answer as either A or B. Just check it. Yes, it is B only. It is B only. Perfect. How did I know it is A and B? Mentally I calculated it. 2 5s are 10. So everything is powers of 10. 2 has gone. No number is there. Only pi is there. So pi value is 3.14. So it will be some 3.14 into 10 to the power something. It can't be C, it can't be D, it has to be either A or B. I hope you got it. How I eliminated it very quickly. Right? Shall we move ahead to the next one? Coming up on your screen, and here it is. The net magnetic flux through a closed surface always is going to be, this is Gauss law in magnetism, it is always going to be 0. Yes, the net magnetic flux through a closed surface is always going to be 0 for a closed surface. For a closed surface. This is Gauss law of magnetism. Because they do not start or end, they will always be closed loops. Magnetic flux is given the EMF induced at 5 seconds. The EMF induced at 5 seconds. Come on, my dear warriors. How do we do this particular question? So this is Faraday's law. EMF is d phi by dt. d phi by dt. Magnitude wise only I am talking about it. So derivative of 2t cube is 3t square. Derivative of 2t is 2. Before that 4t square's derivative is 4 into 2t. 2t's derivative is 2 into 1. 5 is a constant, so derivative is 0. So this will become 2 into 3t square plus 8t plus 2. But the question is to find the EMF at 5 seconds. So the EMF at 5 seconds magnitude wise is 2 into 3 into 5 square plus 8 into 5 plus 2. Come on, do the math and see how much is it coming out to be. How much is it coming out to be? Come on, let me know. 192, 108, 197, 150. 8 5s are 40. 5 square 25 into 3 75. 75 plus 40 plus 2. Come on, do it and tell me how much are you getting. See if you are getting it as 192. See if you are getting it as 192. A for Ames. Very nice. Very nice. Congratulations. Very good, Krishna. Very good, Pratibha. Come on, guys. Keep the Josh high. Keep the Josh high. Moving on to the next one. On your screen now, the square loop of certain side and resistance is in a magnetic field. The plane of the loop is perpendicular. The plane of the loop is perpendicular to the magnetic field. Plane of the loop is perpendicular to the magnetic field. Okay. So that means if this is the loop, the plane is perpendicular to the magnetic field. So the flux is B into A into cos of 0. You might be wondering, sir, 90 degrees, right? But think again, the area vector is parallel to magnetic field. So actually the angle is 0. So magnetic field is 0.5. Area is 1. Side is 1. So 1 into 1 only will be the area. Cos 0 is again 1. Yeah, so it's just 0.5. Nothing else. Yeah, 0.5 Weber. There is no need of this resistance. It's a completely useless piece of information. What do I do with the resistance? Nothing. So it is just completely useless. Just had to find the flux. Nothing more was asked. No problem, Pratusha. Join in and get all your friends as well. Yep. Moving on. Next question coming up on your screen. Two circular loops R1, R2, same plane, centers coinciding. R1 is much larger. Mutual inductance between them is proportional to. This is like this. There is a small loop and there is a very big loop. This is basically R2 and this is basically R1. Due to R1, there will be a magnetic field inside. There will be some magnetic field which will be passing through this loop. I will call that as B1. and that B1 will be given by mu naught I by 2R1. Because of that magnetic field 1, there will be some flux. There will be some flux in this particular area. There will be some flux in this particular area. The flux in the second coil due to the magnetic field of the first coil will be B1 into pi R1 square. So B1 is nothing but mu naught I by 2R1, and this is pi R1 square. Now just rearrange it, you will realize the flux into is mu naught pi R1 square by R2. Sorry, I think this was R2, guys. I'm so sorry. This was R2, this inner radius. So this was R2, this was R1. Yeah, this was R2, this was R1. Radius of the inner coil will be used to calculate the area over here, and here current is there. You can see flux is directly proportional to the current. That means this must be the mutual inductance. So mutual inductance is proportional to R2 square and inversely proportional to R1. So it is option number A. Option number A. You can see mutual inductance is directly proportional to R2 square and inversely proportional to R1 over here. So always find the relation between flux and current. Flux and current. The moment you get that, the relation between flux and current, that's it. The remaining things, the constant things will become the mutual inductance. Is that clear, my dear warriors? Shall we move ahead to the next one? Cool. Let's go ahead. 800 turns coil. Effective area this much is kept perpendicular to the magnetic field when the plane of the coil is rotated by 90 degree. In 1 second, the EMF induced in the coil. So the coil was like this. Now you turn the coil and the coil basically becomes like this. So let's say the magnetic field lines were going like that only. This is how the magnetic field was. So you have turned it. Here the flux will be BA initially. Here finally the flux will be 0. The flux will be 0. So there is a change of flux. The change of the flux is nothing but final minus initial, which is basically minus BA, let's say. Now that will cause the EMF. EMF is del phi by del T with this sign. So minus of minus BA upon that time taken to change it. Minus minus cancels, it will just become BA divided by the time taken. Magnetic field is 5 into 10 to the power minus 5. Area is 0.05. But there are many turns, I think 800. So multiply by 800 and then divide it with the time interval, which is 0.1. And then divide it with the time interval, which is 0.1. You'll have to multiply by n because there are n number of turns. So think about it. Each turn will be associated with some flux. So technically, you should multiply this with n. You should multiply this with n everywhere. If there was a single turn, then there was no problem at all. Cool. So the answer comes out to be 0.02 volts after solving this. Okay. 0.02 volts after solving this. Shall we go ahead to the next question? And here it comes. In which of the following devices eddy current effect is not used? Come on. NEET 2019 theoretical question. Everybody should be able to answer this. Sumati, Krishna, Pratyusha, Afifa, come on, Pratibha. Everyone should be able to answer this, and all the new students also are joining in. Reshu, everyone. Come on. Khadija, come on. Cricketer San, Kanaya, Javed. Javed, the lecture will be there for another maybe 1-2 hours. Not more than that. Yep. Where do you think will you not use eddy current effect? Yes. Magnetic braking, you will use. Electromagnet, yes. Induction furnace, yes. Electric heater, you use Joule's law of heating. So the odd man out over here is electric heater, which is Joule's law of heating. NEET 2019 question. C for Captain Shreyas if you answered it. Very, very good. Very good. Perfecto. Let's move on now to the next one, alternating current. Slowly we have completed most of the 12th part now. Hardly few things are remaining, modern physics, and these questions will be very quick. AC source is connected to the given circuit. The value of the flux, the value of the phase difference will be how much? See, look at this over here. I think you will have to draw the phasor diagram, only then you will get it. First, find the inductive reactance, which is omega L. Omega is 100 pi. You can see this is basically your omega, and inductance is 1 by pi. So it is basically 100 ohm. Now draw the diagram of resistors as vector quantities. Normal resistance is always going to be drawn horizontally. Inductive resistance is going to be drawn vertically up. That is also 100 ohms. So there is no capacitance over here. That means the total impedance will be over here, and that will be 100 root 2 ohms, because both are 100. So how much is the phase angle? The phase angle, you can clearly see, it is 45 degrees. It is 45 degrees because, come on, it's going to form an right angled triangle, isosceles one. Both are 100, right? So this is 100 root 2, this is 100, 100, equal components. That means both the angles have to be equal. Both the angles have to be equal, which will only happen for 45 degrees. Simple. Shall we go ahead? Okay, moving on. Next question. If Z1, Z2 are the impedances of the circuit A and B as shown, then choose the correct option. Z1 equal to Z2 more than, less than, or Z1 plus Z2 is basically equal to 20. So these are the things. Now over here, there is no other option but to actually sit and calculate it. So over here, this is 5 millihenry. Okay, and first of all, this is a DC circuit. This is a DC circuit. So the inductor will have no resistance at all. So the Z over here in the first case is simply put 10 ohms, because inductor will behave like a simple wire. This is DC, direct current. This is not AC. Look at the battery over here. This is AC. This is AC. You can clearly see that this is AC. Here, obviously, there will be some, XC value. XC will not be 0. Already there is 10 ohms. So Z will 100% be more than 10 ohms, because capacitance also has resistance and 10 ohms is also having some resistance. So Z will be more than 10 ohms. So Z2 will be more than Z1, guarantee. Yeah, option number A. What a beautiful question, right? DC current was given and many people thought, sir, what is the frequency? I don't know. You have to be careful. Oh, it's DC. It's going to behave like a wire. No resistance at all for a wire. Got it? Perfect. Moving on. Next one on your screen. A maximum power is dissipated in AC when it is resistive, LC, inductive, capacitive. Maximum power is when cos phi is 1, when phi is 0. Cos phi is your power factor. And this happens only when the circuit is purely resistive circuit. There is no phase difference at all. Yes, A for Andhra Pradesh. Perfect, my dear warriors. Excellent. Moving on, next question, guys. Okay, so lot of questions we are solving. Crazy amount of questions. Look at it. We are already on some crazy slide 468, right? Crazy amount of questions. All right. So next question, guys, coming up on your screen. Here it is. In a LCR circuit, the inductance is 10 millihenry, capacitance is 1 microfarad, and the resistance is 100 ohms. The frequency of resonance will occur at omega is 1 over root LC. That's all. So you know L, you know C. L is 10 milli, so 10 into 10 to the power minus 3. And then capacitance is 1 micro, so 10 to the power minus 6. This will make it 10 to the power minus 9. And this will make it 10 to the power 8, minus 8 under the root. 10 to the power minus 8 under the root will make it 10 to the power minus 4 under the denominator. So it will become 10 to the power 4. But the question is frequency. So omega is 2 pi f. So this is basically 2 pi f. So frequency will be 10 to the power 4 divided by 2 pi hertz. 10 to the power 4 divided by 2 pi hertz. Just check it out if you are getting it as 1.59 kilohertz. 1.59 kilohertz. That's it. This was 2 pi f. This was omega. Okay, not frequency. So convert it into frequency, nothing more. Moving ahead to the next one on your screen. A 12 volt 60 watt lamp is connected to the secondary of a step down transformer. Primary is connected to AC of 220. Assuming the transformer to be ideal, what is the current in the primary winding? So basically this is primary, this is your secondary. Secondary is connected to 12 volt 60 watts and it is ideal transformer. Ideal means this is also going to be 60 watts and AC means is 220 volts. So if that is the scenario, power is voltage into current. Power is 60, voltage is 220, current is I. So I will be equal to 6 by 22, which is 3 by 10. Just check this out. Yeah. What did I do? Oh, sorry, 3 by 10. Sorry, this was 220. This was 6 by 22. So this was 3 by 11. Yes, 3 by 11th of an ampere. What I have done is, because it is ideal, whatever power is there at the output side will be the power at the input side. And on the input side, I can directly say power is voltage into the current and I don't know what is that current. So that is what I have found out, 3 by 11, which comes out obviously as 0.27 amperes. Yes, everybody with me? Because it will be as 30, 11 2s are 22, 8 will remain and 11 7s are 77, right? So it should be 0.27 ampere. Perfecto. Moving on. AC source is connected to a capacitor. Due to the decrease in the operating frequency, what do you think will happen? Think carefully. AC source is connected to the capacitor. And due to the decrease in its frequency, what do you think will happen? XC is 1 by omega C. If suppose omega decreases, XC increases. If X increases, because we know current is voltage by Z and Z depends on XC. So what will happen? The impedance is increasing because the resistance of capacitance is increasing. So the current will decrease. That should be the answer. So option B is correct. Option B is correct. Displacement current increases, wrong. Displacement current decreases, correct. Reactance remains constant, wrong. Reactance decreases, also wrong. Reactance actually increases. So all the other options are wrong except for option B. Moving ahead to the next one. The magnetic energy stored in an inductor of inductance 4 microhenry carrying a current of 2 amperes is how much? Come on, this is straightforward. Magnetic energy. Magnetic energy formula is half L I square. Energy, I don't know, I want to find it out. Inductance 4 micro, so 10 to the power minus 6. Current 2, so 2 square. 2 cancels, 2 4s are 8. 8 into 10 to the power minus 6. So 8 microjoule should be the answer. C for Captain Shreyas. Direct formula, guys. I mean, if you get such questions, be happy. I mean, you should jump with joy. Sir, such lallu pallu questions came, sir. Right? Perfect. Moving on. So you can see AC, lot of questions are there. Lot of questions. Magnetism, not so many questions. AC, electrostatics, current, electricity, high weighted chapters. Multiple questions in a single attempt, in a single year. Yeah, I would like to know, Krishna and others, what kind of session do you want? One session though we have decided, I'll keep it as a surprise. But do you want like a long revision of unit wise, let's say complete mechanics one day, complete wave optics one day, complete modern physics one day, complete I don't know, electrostatics and current, electricity and magnetism one day, and then something like that, you know, and thermal fluids one day, if that is what you want, or just one day complete physics And same thing follows for biology and chemistry. One day for inorganic, one day for organic, one day for physical, or maybe we can extend it to more days, right? That is one option. So let us know what do you want. Let us know what do you want, right? We can do something like that. Or do you just want like chapter problem, chapter problem, chapter problem, chapter problem, or do you want like a complete again whole syllabus problem solving session, or just older PYQs? So many things are there. So many things are there if you think about it, right? And we are planning to do as and what you require, and you know, whatever is the best things for you, which is going to improve your marks. So you need to put it up in the comments, and we can probably also have these discussions on our Telegram channels as well, right? Cool. So what do you do in this question? I think you have to find XL, XC, and that's it. So XL will be omega L. Omega is 2 pi into 50 into L is 50 by pi. So pi cancels, right? 2 into 50, 100. 100 into, oh, but this is millihenry. So 10 to the power minus 3 is also there. So 2 into 50, 100. And this 0 will make it cancel with 10 to the power minus 3. I think you should get this as 5 ohms. XC is 1 by omega C. So 2 pi into 50. And capacitance is 10 to the power 3 by pi micro. So 10 to the power minus 6. Check this out. 2 into 50, 100, pi cancels. 10 to the power 3 and 100 will make it 10 to the power 5. So it will become 1 by 10 to the power minus 1, which is 10 ohms. 10 ohms. Okay. Now, all this I got. Now draw the phasor diagram. Resistance of 10 ohms here. Inductive reactance like this, 5 ohms. Capacitive reactance like this, 10 ohms. 5 and 10 cancels, so it will become 10 over here, and I think 5 over here like this. 10 over here and 5 over here like this. So now you can find the total impedance Z. So Z will be basically 10 square plus 5 square. 10 square is 100, 5 square is 25. So root 125. Root 25 is 5. So 5 goes outside. 125 is 25 into 5. So 5 root 5 should be the correct answer. Yes, it is the correct answer. There you go. Cool. Yes, B for biology is the correct answer. Very nice, guys. Very nice. Proud of all of you. Moving to the next one. What does it say? Oh, it's a statement question. Statement 1 and 2 is there. Which one is correct? Which one is wrong? In the light of the above statements, choose the most appropriate answer. In a AC circuit, current through a capacitor leads the voltage across it. In a AC circuit, current and the voltage across the capacitor. If it is going like this, the current is ahead of the voltage. Yes, that is the correct statement for sure. In the AC circuit containing pure resistance, the phase difference between the current and the voltage is pi. No, it is not pi. It is actually 90 degree, which is pi by 2. So statement 2 is wrong. A lot of people in hurry, they think, yeah, pi, correct. But no, pi it is written, not pi by 2. So that is why statement 2 is incorrect. Statement 1 is correct, right? So that is why this would be wrong. This would be wrong. Cool, guys. Shall we move ahead to the next one? Perfect. Awesome. 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 Moving on. Next question. In an inductor, something inductance connected to this, let the inductive reactance be X1. If 220 volts DC sources replace the AC source in the circuit, then the inductive reactance in the circuit is X2, X1 and X2 respectively are. See, when you connect it to the AC source, not only the actual resistance will come, but also the inductive reactance will come, but actual resistance is not there. So in the first situation, when you have connected it to the AC source, the inductive reactance will be just omega L. This is in the first case of connecting it to the AC source. In the second case, when the reactance is X2 and you are connecting it to a DC source, the inductor will just behave like a simple wire and the inductive reactance will be 0. 2 times this concept has been repeated. So no reactance in the second case, reactance in the first case. So yes, it should be something and 0, not infinity. Either this or this. It can't be infinity. It is not infinity. So guys, it has to be either this or this. This option and this option gets eliminated. Okay, it behaves like a wire. That means no resistance at all. That means no resistance at all. I hope this is clear. Right? Shall we move ahead? Yes, definitely. Krishna, I will be doing whatever is the best for you and I'll be letting you know what we are doing maybe by tomorrow. Yeah, tomorrow I'll make the final announcement of what is the plan ahead for all the students. Moving ahead to the next question on your screen. A standard filament lamp consumes 100 watt when connected to 200 volts main supply. The peak current through the bulb will be. Okay, so power is given, voltage is given, peak current in the bulb. What will you do in this particular case, my dear students? What will you do in this particular case? See, this is, I'll tell you, RMS voltage. So VRMS and IRMS will give you that power, which is basically 100. VRMS is 200. IRMS you might get it from here. IRMS you might get it from here as 1 by 2. But IRMS is maximum current by root 2. Maximum current by root 2, right? So basically I naught will be root 2 will cancel. It will become 1 by root 2, which is 0.707 amperes. So maximum current is asked, not RMS. So it should be option B. Yes. Whenever, remember, voltages, currents are normally given, they are always RMS unless they say something else. If they say something else, that's a different story. Otherwise, it is always RMS. Next one on your screen, peak voltage of the AC source. Okay, this is straightforward. I want everybody to spam the answer. I want everybody to spam the answer. Come on, guys. This is like so easy peasy lemon squeezy. Peak voltage IRMS is I naught by root 2. So I naught is IRMS into root 2, which is C for Captain Shreyas. Correct. Root 2 times the RMS value. Root 2 times RMS value gives you the peak voltage or the peak current. Right. Next one on your screen. So many questions on AC. That means AC is a very important chapter. You can't skip it. Series LCR circuit. Inductance, capacitance, resistance given, voltage is also given, the resonant frequency is V0 and the frequency of the AC source is V, then V0 are they equal or not equal? So first of all, the resonant frequency is V0. So V0 you can find it using 1 by root LC. Okay, this is, but it is in hertz, so I'll have to multiply it by 2 pi. So 2 pi nu naught is 1 over root of LC. L is given as 10, capacitance is 10 micro. This is mu naught. Second thing, for the frequency of the actual source. Well, over here, the voltage frequency is given as 100T. So basically 100 is 2 pi nu. So nu is basically 100 by 2 pi, which is basically 50 by pi. Now just check whether this comes out as 50 by pi or not. If it comes or not, accordingly you can decide. So I think it comes out to be equal. Just check it out. Over here, this nu naught will come out to be as 50 by pi. If it is coming out to be the same, then both of them are equal, which is going to lead us to option number B. Okay, just take this pi below. All these are powers of 10. It will go on the top, take the root, everything. Simple it is. Next one on your screen, inductor, capacitor, resistor. Okay, in series, the potential differences are 40, 10 and 40. Amplitude of the current through LCR is this much. impedance of the circuit is how much. Okay, so first of all, you cannot just directly add these voltages. If this is 40 across the inductor, always inductor's voltage is on the top, resistor's voltage is always horizontal, and capacitors is always down like this. 40 and 10 are opposite to each other. 40 and 10 are basically opposite to each other. So cancel them and you can write this as just 30 volts here and 40 volts over here. This you can further write it as one single voltage. They are both perpendicular. It will be root of 30 square plus 40 square, which is basically 50 volts. That is the total voltage. Now once I get this, the total voltage is the total current into impedance. So 50 is 10 root 2 into impedance. So Z is 0, 0 cancels, 5 by root 2. 5 by root 2. Oops, 5 ohms. Did we make a mistake somewhere? Just check this out. Have we done any mistake somewhere? So this was 40 volts. Yes, perfect. This was 10, this was 40. So 40 for the inductor, capacitor 10. So 40 minus 10 is basically 30. Perfect. This is 30, this is 40. So this should be 50. Perfect. So 50 is equal to current, which is 10 into root 2 amperes. Perfect. So root 2 goes below. So it should be 5 by root 2 only. This is the correct answer. This is the correct answer. Nani, is it possible to get 80 plus from now? Yes, definitely, my dear warrior. You can definitely get it. It's not that difficult. Cool. Shall we go ahead to the next question coming up on your screen? Okay, what do we have the next question as? We have it as current relationship we have to give if voltage is given and it's a capacitor. If the voltage is a sine, 100% current will be a cosine. Current will be a cosine function because there is a phase difference between current and voltage. So it can't be sine for sure. It can't be sine for sure. Either it has to be this or this. So now the next part will be to figure out whether it is this value or this value. Maximum current will be maximum voltage divided by the resistance. In this case, the impedance of capacitor, XC. So V max is nothing but V naught. XC is 1 by omega C. So it will be V naught omega C. So V naught omega C is option number B, I believe. Yes, that is the correct answer. Can you see that? V naught omega C is right over here. So this should be correct. This can't be correct. That's how you choose the correct options. Right, my dear warriors, shall we move ahead to the next one coming up on your screen? Step down transformer connected to a AC supply of 220 volts is made to operate at 11 volt 44 watt lamp. Ignoring the power loss in the transformer, what is the current in the primary circuit? Again, transformer question has been repeated, like you can see. Lamp. So secondary coil, if I show, it is at 11 volt 44 watts. The primary coil, if I look at it, is 220 volts and current is not given. So if it is 44 watts here, it will be 44 watts here, and 220 volts into the current will give me the power. Power is voltage into current. That's all. So the current is basically, this goes with this 2 times. So 2 by 10, which is 1 by 5 of an ampere, which is 0.2 amperes. 0.2 amperes. Is that okay? Everybody with me? Right. Very good. Very good. Very good. Yeah. IRMS, what do you mean by RMS is given right on the question. For here, this one, the amplitude of the current. Oh, my bad. Over here, I think the amplitude of the current is given, and this was, I think, something which we need to look at. if the amplitude of the current is given, just 1 second, then this voltage is also the RMS voltage, by the way. So the actual current IRMS will be amplitude, which is 10 root 2 by root 2, which is 10 amperes. So let's see, if I put 10 amperes over here, Z will become 5. So 5 means this is the correct answer. Yes. So this was the amplitude of the current. So I need to convert it into RMS, because this voltage, whatever I got over here also, right, this was also RMS. So if I write V is IZ, if this is RMS, this is RMS. If this is peak, this is peak. If this is average, this is also average. It has to be identical. So I think I misread this. I did not read that it was the amplitude. Yes, definitely it will be correct. Thank you for pointing it out, Afifa. Very good. Proud of you, my warrior. Good. Let's move on to the next question coming up on your screen. A step down. This is done. What is this? A series LCR circuit containing inductor, capacitor, resistor connected to the variable frequency, angular frequency of the source at which power transferred to the circuit is half the power at resonant angular frequency R. So guys, quite a lengthy problem over here. So if you remember half power formulas, I think it is like a dicey thing whether it will be asked or whether it will not be asked, right? So still I would say if you go through it, it will be better. It will be better for all of you, right? So sometimes they might ask you the question, sometimes they might not ask you the questions and all of that. So it is a really big derivation if you think about it, but still the bandwidth formula, if you remember, it is going to have R and L over here, right? This is the bandwidth formula. And half power, if this is omega and this is your current or something, the graph goes up and comes down like this. The maximum value you get over here, which is 1 over root LC, and the bandwidth is basically the difference between these two. That is basically R by L. So the two frequencies that you get, one over here and one over here, omega 1 and omega 2. So omega 2, think about it, will be this value, 1 over root LC, plus half of this, plus this is totally R by L, half of this, so plus half of R by L. This is one thing. Omega 1 will be half of root LC, and over here go behind, so it will be 1 by root LC minus half of R by L, So this value and this value is half RL, half RL will become R by L, right? Half R by L and half R by L is going to give you complete R by L. So these are the two frequencies for which you get half the power. These are basically called half power points. These are half power points. This is your resonant frequency. This total difference between the two frequencies where the power becomes half, that is called as the bandwidth. So ideally they should not ask, but still, I mean, you can just go through it. They should ideally not ask these kind of questions right now. Cool. Moving on now to the next question. I have told you how to solve this. You can substitute the values. 40 microfarad capacitor is connected to this source. 50 Hertz is the supply. The RMS value of the current of the circuit is nearly how much? Okay. So first of all, you have to find XC. There is no option. 1 by omega C. Omega is nothing but 2 pi F. Frequency is 50. Capacitance is 40 into 10 to the power minus 6. Cool. From this XC, what you will do is you will find the RMS value of the current, because VRMS is IRMS into resistance. That's it. So IRMS will be the VRMS. VRMS is given to be 200 volts, and XC will come down, which is exactly this. So it will be 1 upon this whole thing which you got, 2 pi into 50 into 40 into 10 to the power minus 6. Everything will go on the top, multiply it and see what is the answer that you get, close enough to 2.5 amperes. That's what you should get. Okay, that's all that is there in this particular question. The capacitance is given, the voltage is given, the frequency is given, current is asked. So first you find the resistance of the capacitor, which is called as a capacitive reactance, and then use Ohm's law. V is IR, current is voltage by the resistance. That's all. As simple as that. Cool. Shall we go ahead to the next one? Yeah. In a series LCR circuit, when L is removed, the phase difference between the current and the voltage is pi by 3. If capacitor is removed, the phase difference becomes pi by 3 again. Then the power factor of the original circuit will be, okay, see, in the first case, inductor is removed. So the phase difference between current and voltage, okay. So let's say this is VR, L vanishes, VC will remain, VC will still remain. So it will produce a net voltage. It will produce a net voltage like this in the first scenario. And the phase difference between current and voltage is pi by 3. Remember, the current is always here. So it is pi by 3, meaning it is 60 degree. This is the first scenario. Second scenario, capacitor is removed. So inductor's voltage is still there. Inductor's voltage is going to be still there. So VL is there. This is VR. It will produce a resultant voltage like this. And this angle is again given to be 60 degree. So whether you remove this or whether you remove that, the net voltage makes 60 degree either this way or that way. What do these two diagrams tell you? What do these two diagrams tell you? In fact, if you take this diagram and flip it, if you bring that VC on the top, it will merge with VL. Or you take this VL, make it upside down, it will become this diagram. What does this tell you? It tells you VL is equal to VC. And this only happens during resonance. This happens only during resonance. So basically your power factor will be basically 1. Power factor will be basically 1. Hence the answer is option B, which is 1. Option B, which is 1. Is that okay? Everybody clear till this point? Simple, easy peasy, right? Moving on, next question on your screen. Wow, we have done with AC. Moving on to electromagnetic waves. Some questions we have done it before only from electromagnetic waves like displacement current, conduction current. Some questions got mixed up, right, in the beginning. So some questions we have already done before. So keep that in mind, right? Moving on to the next question on your screen. Electric field has some frequency and amplitude. The amplitude of the magnetic field is, see, electric field amplitude by magnetic field amplitude is speed of light. So magnetic field amplitude is electric field amplitude by speed of light. So electric field amplitude, if it is 48, speed of light is 3 into 10 to the power 8, right? So this will become how much? 16. So 16 and 10 to the power minus 8. So how much is it? 1.6 10 to the power minus 7, I believe. Yes, correct. 1.6 10 to the power minus 7. You shift the decimal here. So the power of 10 will become 10 to the power minus 7. That was a simple pimple question which was asked. Very good. Very good. Excellent. Shall we move ahead now? Yes, ready for it, guys. Ready for it. Let's go. Magnetic field is given by this equation. What is the electric field? This is also a common variety of question. So first thing, if this is cos, everything should be cos. This is sine. So observe this. This is cos. This is cos. This is cos. This is sine. Can't be true. This is sine. This can't be true. Got it? That is the first thing. Next thing what you should do is check the inner terms. 1.6, 1.6, okay. 48, 40. 8, okay, 10 to the power 10, perfect. Now this is k cap, this is I cap, this is 9, this is 3. We can eliminate the options now. We know that electric field by magnetic field is speed of light. So electric field, I want to find it out. Magnetic field is 3 into 10 to the power minus 8. Check this out. Is equal to speed of light, which is 3 into 10 to the power 8. So electric field will be 3 3 is a 9. Minus 8 and plus 8 will become 0. So 9 should be there here. Yes. So this is wrong. So automatically answer A will be correct. I think it was not marked over here for some reason, but yeah, it will be option number A. Is that okay, everyone? Clear? Got it? So if you want the direction of it, what you can do is, remember, electric field cross magnetic field should be parallel to the speed of light. Electric field, if it is in k cap direction, magnetic field, if it is in j cap direction, is it parallel to your minus I cap? Because there is a plus over here, it is going in the x axis, but negative because there is a plus sign. K cross j is minus I cap, I j k, j cross k is I, k cross j is minus I. Perfectly, it is matching over here also. You can see that k cap is matching. So yes, option A is the correct option. Okay, continuing with electromagnetic waves, I think somehow the slide came up again. Let me just delete it, not needed. What is this? A plain electromagnetic wave, frequency this much, amplitude. I think this was just repeated. I think it is coming 2 times. 2 times we have done this. This also we just, okay, did it. Okay, which color of light? Let me just delete then. 1 second. Okay, which color of light has the longest wavelength? Blue, violet, already answer is marked. Red, yes, red has basically close to 700 nanometers, and when we talk about violet light, it is close to 400 nanometers. This is the closest. Yellow is somewhere in between of this. Yellow is somewhere in between of this. Is that okay, my dear warriors? Perfect. Shall we move ahead to the next question? Okay, coming up on your screen. This was direct. Okay, the ratio of the magnetic field and electric field of a plane wave in free space in terms of permeability and permittivity is how much? The ratio of the magnetic field upon electric field. Guys, E by B is C, so B by E will be 1 by C. So it is direct, I feel. It is direct 1 by C. Yes, option is already marked. I don't know why option is already marked. Am I going to the next slide by mistake? Yes. So B by E is 1 by C. Yes, that is the correct answer. Very good, very good, very good. Let's go to the next one. I think next we had match the following: AM wave, microwave, infrared, X-rays. What are the wavelengths? Either you know it or you don't know it. If you don't know it, that's it, gone. Then you have to go back to NCERT and read the tables and the charts properly. There is a nice chart of the electromagnetic spectrum, X-rays, gamma rays, AM rays, everything, their frequencies, their wavelengths. It's better to have a slight idea of what order they are. See, X-rays are very small, so of the order of atomic size, so it will be 10 to the power minus 10. So if you look at the answer also, A goes with, D goes with 1. D goes with 1, which makes sense. X-rays are very, very small in typically angstroms. Typically angstroms. Keep that in mind. Your microwaves are decently small, but AM waves are little bit big. AM waves are little bit big, so they are in few meters. So that is why you will have this going to 2. They are going to 2. Once you get these two options, I think you can automatically select other things, right? Infrared will be smaller, microwaves will be slightly bigger. So that is why you will see over here that microwaves over here will be connected to the small this one over here, right? And infrared, which is there, will be connected to your 10 to the power minus 4. As simple as that. Yeah. So if you get even 2 things, you can get the other things as well. 2 or 3 things. Usually in match the following, that's how it works. So the length propagates through, when light propagates through a material, relative permittivity and permeability, the velocity of the light is given by, see, speed of light in vacuum is 1 by root mu naught epsilon naught. Speed of light in any medium will be given by root of ER E naught mu R mu naught. So take this root ER mu R outside and leave this separately, epsilon naught mu naught. 1 by epsilon naught u naught is C, so C divided by ER mu R. These are relative terms. So I think option number D matches it. Yes, D option is the correct answer. D option is the correct answer. Cool, guys? Everybody? Perfecto, perfecto. Moving on to the next one coming up on your screen. You can see in the last few years, even EM waves questions are very, very common. For a plane wave in the x direction, which of the following is a combination gives the possible direction of electric and magnetic fields? Okay, see, remember, electric field cross magnetic field should be parallel to the speed of light. So light is going in x direction, that means it should be I cap. So whatever you take over here, finally the answer should only contain I cap. The answer should only contain I cap. You can try out different options. This has to be done option by option. There is no other way. Go with option 1, go with option 2, go with option C, go with option D. Let's say, for example, you take option number A, example. So it will be like minus J plus K cross minus J plus K. Oh, that to 100% won't happen. I mean, you can see that why. J into J 0, K into K 0. So the only terms which will come is minus J into K and K into minus J. So when I do minus J cross K plus K cross minus J, don't you see that they will actually cancel up each other, right? Because this is as good as saying this is minus J cross K, this is minus of J cross K, and they both will cancel up. So it will definitely not be equal to I cap. It will definitely not be equal to I cap. So try it out for all the other options also and see for which of the options does it come out to be correct. Just see if it is only for C option, it should come out to be correct. So when you do minus J plus K cross minus J minus K, you should get it only in terms of I cap. So this will get multiplied with this will get multiplied with this, that's all. This will get multiplied with this, that's all. Okay, because K into K is 0, J into J is also 0. So minus J cross minus K cap is the first term, and K cross minus J is the next term over here. Minus minus cancels, J cross K, I J K, and then you'll get I cap over here. And K cross J is minus I, so minus of minus I cap, so it will become 2 times of I cap. Yes, it is I cap. So option C is the only one which will match. Other options will not match to give you I cap. Okay, you will have to sit and try. This was a lengthy problem, again a sadistic problem, because no other way other than checking the options one by one, brute force method. Okay, cool. So be prepared for such questions. Ratio of contributions made by electric field and magnetic fields to the intensity of the electromagnetic wave. Ratio of the contributions made by electric field components to the intensity. Guys, this is very, very simple. The answer is 1:1. Both of them contribute equally. Okay, it's not like one contributes more, one contributes less. The energy densities are equal. Both the energies are present in equal amounts. 5 joules, 5 joules. Total will be 10 joules. They are always present in equal amounts. Okay. Moving on, next question. I think this question came again. Okay, by mistake. Yeah. So this is red only. Okay, let me just delete these two slides. Okay, we have come to optics now. Moving on, guys. We need to push ourselves a little bit fast. I know we are going. So many questions. Just imagine, guys. Just imagine one single video giving you all the 12th standard PYQs of all the 5 years. Actually, there are 6 papers. There are not 5, there are 6 papers. Okay. So some questions are getting from, the same year many times because of the re-exam which was conducted in Manipur. Right. Moving on. A lens is made of 3 different transparent media and all that. Okay, let's have a water break quickly. Okay, I hope you have read the question, guys. I don't know whether I'll be able to read all the questions now onwards. Okay, I need to conserve my throat a little bit. So, yeah, lens is made of 3 materials. Point object is placed beyond 2f. How many real images? Beyond 2f, if the object is placed, obviously real images will be formed. 3 materials means 3 different refractive indices, 3 different focal lengths, so 3 different images. So the answer should be 3, I believe. Yes, it is 3. So whenever refractive index is different, focal length will be different. So each one will create its own image. Some rays will go through this, will make an image here. Some rays will go through this, will make an image here. Some rays will go through this, will make an image here. So we'll get 3 different images because of 3 different focal lengths. Very good. Moving on, next one. I think this question should have been in electromagnetic waves. Looks like it. If the corresponding quantities of the medium are 2 epsilon naught and 1.5 mu naught, the refractive index of the medium will be. In fact, you can find the speed of light in the medium as 1 by root of 2 epsilon naught 1.5, which is 3 by 2 mu naught, which will be 2 cancels. So you will have 1 by root 3 into 1 by root epsilon naught mu naught. So this is nothing but speed of light. So speed of light by root 3 is speed of light in the medium. So just taking the ratio C by cm is nothing but root 3. This speed of light in air upon speed of light in that medium is the refractive index. So refractive index is root 3. Refractive index is root 3. Yes, that is the correct answer. Very nice. Speed of light in any medium in terms of permittivity and permeability is 1 by root permittivity of the medium, which is given as 2 epsilon naught, and permeability of the medium, which is 1.5 or 3 by 2 mu naught. It is given to us. So directly we could tell this. Brilliant question. Cool. Sometimes electromagnetic waves can be combined with refractive index, which is the ray optics. 2 chapters married each other. They married each other. Perfect. So these marriages can happen. What is this? Horizontal ray of light is on the right angle prism with an angle of 6 degree. The refractive index of the material is 1.5. Then the angle of emergence will be how much? So over here, basically you can think, since actually the ray is not shown horizontal, but actually you can think of it like this. It is like this, and the ray actually will come like this. Because it is 90 degree, it will continue its journey 90 degree. It will go here and it will refract like that. So it will deviate. It's a thin prism. So just find that deviation. Just find that deviation. How much is that deviation? It is A into mu minus 1. Angle of prism 6. Mu is 1.5. So 1.5 minus 1. 1.5 minus 1 is 0.5. So it will become 3 degree. So this is basically your deviation, my dear warriors. This is basically your deviation, my dear warriors. Perfect. But is that the angle of emergence? No. You need to be little bit careful over there. Why? Because think about it. If I drop a perpendicular over here, this is the total angle of emergence. So you need to be really careful over here. So as per the given information, this is 6 degree. So this will be 90 minus 6 degree. Naturally, this will be again 6 degree. Got it, guys? 6, 90, 90 minus 6. 90 minus 6, this will be 6 because the total angle has to be 90 degree. This is the normal which is drawn. So this angle is opposite to this particular angle over here. So I think this angle is again 6 degree. So what is the angle of emergence going to be? This is 6 and this angle is delta, which is 3. So it will come out as 9 degree. So I think 9 degree should be the answer. Yes, it is. Such a nice question, no? Many people will write the answer as 3, which is not even there in the option. But you have to use little bit of geometry over here. Question was angle of emergence, not any deviation. Little bit geometry was involved. Did you understand this question? Give me a thumbs up. Did you love this question? Give me a thumbs up. If you have not yet liked or subscribed, do that. If you have already done that, put it up in the comments. Shall we move ahead, my dear students? Perfect. Yes. Okay, so you should know how to use these geometrical principles, guys. So I'll just quickly repeat what I just did over here. This was the perpendicular which was drawn, and let's say this was like this and like that. If this is 6 degree, this is complementary of that. This is 90. So since this is 90, again this will be 6 degree. Understand that. So that is the reason why, you know, when we probably went over here like this, if this is basically 6, even this was 6 degree, and remember this was 3 degree, so total is 9 degree. That is what you should go with. Okay, opposite angle 6, 6. Opposite angle 6, 6. What is this? Object is mounted on a wall. Its image is of equal size is to be obtained on a parallel wall with the help of a convex lens placed between these walls. The lens is kept at a distance x in front of the second wall. The required focal length of the lens will be. Now in this particular question, okay, think about it. What is it? Object is mounted on a wall. Image of equal size is to be obtained on the parallel wall with the help of a convex lens. So this is an object, convex lens, wall, and equal size, if I'm not wrong. Equal size, that means here like this, within these walls. The lens is kept at a distance of x in front of the second wall. X in front of the second wall. The required focal length of the lens. Guys, this can only happen in one situation: if the object is at 2f and the image is also going to be formed at 2f, which is inverted and equal size. So basically this distance is 2f, so x is 2f, so f is x by 2. Standard procedure. Answer is C. Yes, it is C. Very good. No need to do any complicated mathematics. Complicated mathematics not needed at all. Yes. Pratina James, I can understand very little Tamil. I can speak also very little Tamil, right? But yeah, and I would love to learn more when I come to meet you and we conduct more classes for you, and hopefully you too will come to Bangalore very soon when you crack NEET. Definitely Pratina James. Right, moving on. Next question coming up on your screen. Light travels x in T1, 10x in T2. What is the critical angle of this medium? So basically we can find the speed of the light in both these mediums, and that's how you can find the critical angle. So in the first medium, speed is x by t1. In the second medium, the speed will be 10x by t2. Now if you basically take the ratio of the speeds, you will get the refractive index. If you basically take the ratio of the speeds, you will get the refractive index. So it is nothing but v1 by v2. v1 is x by t1, v2 is 10x by t2. xx gets cancelled and we will be left with t2 by 10 times of t1 is refractive index. But that's not the question. The question is critical angle. Sine of the critical angle is 1 by mu. So reciprocal of this will be 10 t1 by t2. So the critical angle will be sine inverse of 10 t1 by t2. 10 t1 by t2 sine inverse. Yes, that is option number C. Again, option number C. Yeah. Cool. Shall we go ahead to the next one? And here it comes. What does it say? What does it say? Okay. Vanakkam, my dear students. Vanakkam, and keep liking like this only. Tamil konjam therida. Okay. Cool. Let's move on. In the figure shown here, what is the equivalent focal length of the combination of the lenses? Okay, first of all, inner refractive index 1.5, outer refractive index 1.6, radius is given. What is the equivalent focal length? Assume that the layers are thin. So over here, basically, this and this can be taken as two plano concave lenses. Together, if you add them, it just becomes one single concave lens. So that is this part. If you talk about this part at the between, it is just one single convex lens. So you have a concave lens and a convex lens. Find the focal length separately and you will get the answer. So for the convex lens, 1 by f1 will be mu. Mu is 1.5. 1.5 minus 1. Radius is 20. So 1 by 20 minus 1 by minus 20. So that will give me 1 by f1 is equal to how much? 0.5 into 2 by 20. 2 and 0.5 cancels. So f1 will be basically 20 centimeters. Same thing do for the concave lens also. So 1 by f2 will be refractive index is 1.6. 1.6 minus 1. 1 by minus 20 minus 1 by plus 20 because of the sign convention. So this will become 0.6 into minus 2 divided by 20. So therefore your focal length in the second case will be 20 divided by minus 20 divided by 2 into 0.6. 2 into 0.6. So this will become 10 and this can become 100 by 6, which is 50 by 3 with a negative sign, of course. Now once you get that, you can find the effective focal length, which is what is the effective focal length? Effective focal length will be 1 by f1 plus 1 by f2. 1 by f1 plus 1 by f2. So just do the math. So 1 by 20 plus 1 by minus 50 by 3. So 50 and 3 will come over here. That's it. Just see if you get the answer as 100 centimeters. See if you get the effective focal length as 100 centimeters. Okay, so that is all that you need to do. Cool, everyone. Shall we move ahead to the next one coming up on your screen? Yep. Okay. Let's move. What is it? In the figure shown here, what is the equivalent? I think something is missing. Is it there in the options? No, nothing. I'm not sure what the question was actually, but I think there was a question where the focal length of the combination of the lenses becomes infinite, meaning maybe there was a, I'm not sure, maybe there was a convex lens and a concave lens. So whatever rays will converge, maybe they again diverge and they again become parallel, something like that. So most likely that was what the situation was. So focal length could have been infinite. Anyways, during a cloudy day, the primary and the secondary rainbow may be created. Then sometimes you get two rainbows, guys. Sometimes you get two rainbows like this. Right. Like this. I get a rainbow like this. And then you might get a rainbow like this over here. So these are called primary and the secondary rainbows. So the question is on that primary and the secondary rainbow. Why do you get those primary and the secondary rainbows? That is basically because of how the refraction happens inside a drop. So if you have a drop of water, the white light which goes in gets internally reflected once, you get primary rainbow. If you get internally reflected twice, you get the secondary rainbow. That's all. So secondary rainbow is due to double internal reflection, and primary is formed because of the single internal reflection. That's all. So it's just how the refraction occurs inside the drop. So if it happens 2 times, it will be double secondary rainbow. If it happens once, it is basically because of the it will cause the primary rainbow. That's all. Yeah, great. Moving on to the next one coming up on your screen. Here it is. A biconvex lens has a radius of curvature 20 centimeters each. The refractive index is given. The power is how much? So first find the focal length. Focal length is mu. Mu is 1.5 minus 1. This is lens maker formula. 1 by 20 minus 1 by minus 20 because of sign convention. So this is 0.5. Minus minus becomes plus. So 2 by 20. 2 into 0.5 is 1. So 1 by 20. So focal length will become 20 centimeters or 0.2 meters. That is not the question. The question is power, which is 1 by f. So 1 by 0.2, which is 5 diopters. Always keep it in meters so that you get the answer in SI units, which is diopters. Else you will get a completely different answer if you put 20 centimeters. Okay, so that's how it is. Next one coming up on your screen. A light ray falls on a glass surface of refractive index at 60 degrees. Angle between the refracted and the reflected light will be question mark. How much it is? That's the question. Let's see if you guys can figure this out quickly. So let me draw that surface. Let me show the light falling like this at basically 60 degree. The light which will get reflected will also be at 60 degree, no doubt about it. The light which will get refracted will have some angle. So for that, sine of I by sine of R will be refractive index. Sine 60 is root 3 by 2. So root 3 cancels. Sine R will become half. So R will become basically 30 degree. So this is 30 degree. This is 60, this is 30. So naturally, how much will this angle be? It will be 180 minus 60 minus 30, which is 180 minus 90, which is 90 degree. So the angle between the reflected and the refracted ray is simply put 90 degree. Yes, it is 90 degree. You had to use law of reflection and law of refraction, Snell's law and simple law of reflection also. Very good. Clearo, shall we move ahead to the next question? Come on guys, couple of few questions only more left, I feel. Yes, I think we are already on some 544th page or something already. Wow, this is crazy guys. This session has been so long. We are on 540, if I remember it correctly, some 600 pages, approximately 600 plus pages were there. So we are coming closer and closer to the end already. Two medium are separated by a plane boundary. The speed of light in those medium are this and this. The critical angle is, if speed of light is given, you can find the refractive index. Refractive index is relatively of denser with respect to rarer, is higher speed by lower speed. This 10 to the power 8 gets cancelled. 1.5 is 3 by 2, so it will become 4 by 3. Leave that. Now sine of the critical angle is 1 by refractive index of dense with respect to rare. So reciprocal of this will be 3 by 4. So it will be basically IC is sine inverse of 3 by 4. Sine inverse of 3 by 4 is 0.75, which is option B, of course. Yes. 3/4 is 0.75. Make sense, everyone? Awesomeness, awesomeness. Moving on, next question on your screen. We are on rapid fire mode. See how the momentum has built up, and just because you have been following the class, it's like, I'm pretty sure, I mean, if you would have done it on your own, it would be very difficult. You would have taken 5, 6, 7, 8 days, or maybe not even completed it. Because you are a part of this lecture, whether live or recorded, you're going with the flow, you're going with the momentum. So many questions, taka 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 taka, you're solving it. Find the value of the angle of emergence from the prism. Refractive index of the glass is √3. Okay. Find the angle of emergence from the prism. So you'll have to use little bit of ray optics over here. First of all, because this is falling perpendicular, it will continue perpendicular as it is. No change over there. If this is 60, this is 90, obviously the angle on the top should be 30 degrees. If that is 30, this is 90, again this angle over here should be 60, because 30, 90, 60 triangle. And then let me drop a perpendicular over here like this, and what I will see, interestingly, if this is 60, naturally this angle will be 30 degrees. So finally, when the ray comes out, because it's going from denser to rarer medium, this is the angle of refraction, this is the angle of incidence, this is the angle of refraction. So sine of I by sine of R, if I use it, sine of I by sine of R, it should be mu. Sine of I, sine 30, sine of R, which I don't know. Please do not put mu as √3, because you are going from dense to rare. So this mu is the refractive index of the glass with respect to air, which is 1 by refractive index of air with respect to glass. Here, this is okay if you are going from air to glass. The moment you go from glass to air, then you have to go like that. So in this particular scenario, because I am going from glass to air, going from glass to air, I will write it like this, which is the reciprocal of A mu G. Usually this is given. So this √3 is technically this one, is basically this one. So use this over here. This is 1 by √3. Common mistake is people do not take the reciprocal. Common mistake is people do not take the reciprocal. Understand, if light is going from glass to air, write glass first, then air. Light is going from glass to air, yes. But what is given is not glass to air, it is air to glass, which is reciprocal. Understood? Sine 30 is 1 by 2. This is sine of R. This is 1 by √3. So sine of R is a √3 by 2. So R is basically 60 degree, and that is the angle of emergence from the left hand side. Yes, 60 degree. That is correct. That is correct. So much of geometry is involved, right? We started off with this is 60, this is 30. Okay, this is going like that. So in this small chintu mintu triangles, this is 60. Over here, if this is 60, this is 30. Wow. So then I understood this is incidence, this is refraction. So a lot of geometry also is there. That's why some books also call it as geometrical optics. Convex lens, concave lens, focal length, same axis, distance d between them, a parallel beam of light leaves as parallel, then a distance in d centimeter is how much? Okay, so convex lens, and what happens is light is falling on it parallelly. Light is falling on it parallelly because the lens has a focal length of 20 centimeters. So obviously the light rays would love to meet over here at a distance of 20 centimeters. But what you did is, intelligently, smartly, you have placed a concave lens like this over here, whose focal length is 5 centimeter. Now just imagine if this is 5 centimeter, then the rays are trying to meet at the focal length. Reversibility principle of light, the rays will become parallel, right, like this. So the rays which were trying to meet, you have made them parallel. So that means what's the actual distance between the lenses? It is 20 minus 5, which is 15 centimeter, which is C option, I believe. Yes, C option, Captain Shreyas. What a brilliant question, guys. What a brilliant question, isn't it? Moving on, next one on your screen. You have to just think, how can I place it like that? That's all. Point object 60 centimeters from a convex lens, focal length 30 centimeters. Plane mirror were put perpendicular to the principal axis, distance 40 centimeter. Final image would be formed at what distance? Guys, this is unnecessarily lengthy, that's all. I'll just tell you what you need to do step by step. See, object is here. First find where the image will be formed. So use lens formula, 1 by V minus 1 by minus 60. Focal length is 30, so 1 by 30. So 1 by V is equal to 1 by 30 minus plus, goes on the other side as minus 1 by 60. 1 by 30 minus 1 by 60 is 2 minus 1, which is again 1 by 60 only. That is 1 by V in the first case. So V1 will be basically 60 centimeters. So what it means is that the image would have formed over here at a distance of 60 centimeters. But because of reflection, what happened is, which was supposed to form over here, it got reflected and it will form over here. I hope this is clear. So now this is where the first image is going to be formed. Now this image will now act like an object, for the second refraction. Okay, for the second refraction, and then it will again refract and form the image somewhere else. Now the sign convention will change. Light is going from here to here. Did you understand this, what I just did? Light refracted, it would have formed the image here, but it got reflected and made the image over here. So if it would have formed at a distance of basically 60 centimeters from here, out of that this is 40, naturally this is 20, so 20 centimeters in between. So basically it should form 20 centimeters in the front, because this is 20. So the object number 2, technically speaking, is 20 centimeters from the lens. So again use 1 by V minus 1 by U is minus 20, is equal to 1 by F. F is how much? 30. So just do the math. 1 by V is equal to 1 by 30 minus 1 by 20, which is 60 over here. 2 minus 3, which is minus 1 by 60. So V2, just check this out. If it is coming out as a minus, just check this, yeah, 1 by 30, 63, 2 and 3, yes, perfect, minus 60 centimeters. Just check this out. Now if it is coming out as minus 60, that means most likely the ray goes like that, and the final image is formed behind the mirror. This is your final image, and this is at minus 60. That means it is 20 centimeters from the mirror. So image is formed 60 centimeters behind the lens. So yes, it should be 20 centimeters from the plane mirror, option A. And it will be a virtual image because the rays are going like this and the answer came out to be negative. That means it has to be virtual. It will not be real. It will not be real. It can be virtual. It can be virtual here, but it is not 30. It will be 20. So that's all. It was just a multi-step problem which was asked in 2021. Okay, just one second. Let me drink some water. Okay, let's continue. A rays incident at an angle of incidence on the prism emerges normally from the opposite surface. The refractive index of the material, the prism is mu, then the angle of incidence is nearly equal to incidence on the one of the surface of a small angle prism. It's a small angle prism, so just show a small angle prism, and it is given that it emerges normally from the opposite surface. It emerges out like this. So this kind of diagrams have been very common, like you can see even before. So this is the angle of incidence, so it will probably go like that. Okay, this is how the ray diagram would approximately look like. This is 90 degree, this is also 90 degree. Okay, cool. So rays incident at an angle of incidence I on one of the things and emerges normally. Refractive index is mu, then the angle of incidence is roughly approximately equal to how much? That is the question. Now over here you need to use little bit of geometry is what I would say. Little bit of geometry. See, this is the angle of prism. This is 90 degree. So this is 90 minus A. This is basically 90 minus A. So this obviously would be A again. This would be again A because this is 90 degree. This is 90 degree. So if this is 90 minus A, this would be A angle. So if this is I, can I say sine of I by sine of A is basically mu? But since the angles are small, sine is angle, sine is also the angle. So I by A is mu. So I is basically mu times of A. I is basically mu times of A, which is option B. Yes, that is correct. So we had to use the small angle approximation. We had to use the small angle approximation. That's all. Cool, everybody. Shall we go ahead? Next question on your screen now. The Brewster angles for an interface should be, well, Brewster's angle, right? What is Brewster's angle? Tan of the angle of Brewster is basically mu, and mu is basically more than 1 less than infinity. So instead of mu, put tan of IB. Tan of IB, this is what it is. Now think, what is 1? I can write in terms of tan as tan 45. And what can be written down instead of infinity? I can write tan of 90. So tan 45 less than tan IB less than tan 90. So the angles also are related exactly like that in this particular manner. So 45 less than IB less than 90, which is option B, I believe. Yes, that is the correct answer. So a lot of people use unnecessary mathematics in this particular question, but actually you didn't have to use anything like that. Moving on to the next one on your screen. Total internal reflection when the angle of incidence is equal to the critical angle for a pair of medium of contact will be the, what will be the angle of refraction? Okay, So in total internal reflection, when the angle of incidence is equal to the critical angle, if the angle of incidence is equal to the critical angle, then what will happen? This is called as grazing. The ray of light is grazing the surface. So this R will be 90 degree. This angle of refraction will be 90 degree. Yes, that is the correct one. That is the correct one. Okay, it will graze through the surface. If you go more than that, any angle more than that, it will get internally reflected. Any angle less than that, let's say it is like this, then it will come out over here like that. It will get refracted. Okay, so this is how it works. This is how it works. Anything more, it gets reflected. Anything less, it comes out. Exactly at that, it is grazing incidence, which is basically 90 degree. Very good. Excellent. B for biology. Moving on, next question on your screen now. What do we have? Two similar equiconvex lenses of focal length f are kept coaxially with each other such that the focal length of the combination is f1. When the space between the two lenses is filled with glycerine, then the equivalent focal length is f2, the ratio of f1 by f2. Okay, so first thing, two equiconvex lenses kept together in contact with each other such that their focal length of the combination is f1. This and this together is basically f1. Now in the second scenario, space between the two is filled with glycerine of same refractive index. Okay, interesting. This is the combination, but you are filling it up with glycerine of the same refractive index. Guys, one of the lenses will get cancelled out because you have a concave lens. This is as good as saying you have a convex lens, you have a concave lens, and then again you have a convex lens. These two will get cancelled out, and what will be left is just one single convex lens, and their effective combination was f2. Now just imagine if I tell you each of these lenses have f and f as focal length. So over here this will be f, this will be minus f, this will be f. Here what is left is just f. So strictly speaking, over here f2 is just f, and in the first case 1 by f plus 1 by f was f1, so 2 by f was 1 by f1, so f1 was f by 2. Oh, f1 was f by 2, f2 was f, so that's it, the ratio of f1 by f2. f1 is f by 2, f2 is just f, so it will be just 1 by 2. So which is option number A, I believe, A for Ames. Yes, f1 by f2 is 1 by 2. Okay, glad, Krishna. Yes, I know I can solve the questions easily, but it's not about me solving. You have to also understand. Yes, you noticed it correctly, Krishna. So here the main crux of the problem is to realize this concave lens, which is formed by the glycerin pore, cancels out the convex lens. Why? Because they have the same refractive index. They will cancel out. So it's at the end of the day, only one lens is remaining, which is having f. But here there were two lenses. So use the combination of lens formula, you will get the focal length. Last step is taking the ratio. Moving on, next question coming up on the screen. What is it? Oh, done with ray optics. My goodness, this is cool. Shall we go now to wave optics, guys? Okay, ready for it? Because after wave optics, only modern physics is remaining. Just imagine complete syllabus. 4 days, complete syllabus. Not just physics, guys, but also chemistry and zoology and botany. All PYQs, literally chapter-wise solutions, video solutions in English. Just imagine. This is next level stuff which has happened on the Vedantu NEET English channel. One of its kind. And all thanks to the dedication of all the teachers and the team working behind. Which set of colors will come out in the air for the situation shown? Think about it. The one which has higher refractive index will have smaller critical angle. How? Look at this. Sine of the critical angle is 1 by mu. Higher refractive index, smaller critical angle. That means it will get reflected easily. So it will get internally reflected. So out of violet, blue, green, yellow, orange, red, what happens? Violet deviates the most. Violet deviates the most. So refractive index of violet is more. That means the critical angle will be less. So as compared to red, refractive index of red, and this is critical angle of red. So refractive index of violet is more. So critical angle of violet is going to be less. So it will get easily internally reflected. So there will be total internal reflection which will occur easily for this, easily for smaller angles also. So if green is coming, what will happen is that the violet light will be coming over here and the red light might be getting out of this because it is more difficult to refract it, internally reflect it. So if red is coming out, what are the colors between red and green? I think it is orange. I think it is orange and yellow, right? Orange and yellow. Vibgyor. So green is just coming over here. Green is just coming over here. So your blues and indigos will be over here. This is how it will be. In fact, this will be going like this because they have to follow laws of reflection, and reflection angle of incidence is equal to angle of incidence. That's it. This is how the diagram would look like in this case. What a brilliant question, right? So just check it out. Orange, yellow and red. Yes, it is A for aims. It is A for aims. This is the diagram. It is easily going to get reflected. So that is why you can see total internal reflection happening for the blues, whereas for the yellows, oranges and reds, they are getting refracted out in the medium. Got it? Did you visualize it now? Why this is happening? Only because of the refractive index. Moving on, next one. YDSE, screen is moved away from the plane slits. Angular separation of the fringes remains constant. The monochromatic source is replaced by another source of larger wavelength. Angular separation decreases. What do you think? If you know the formula, you will know it. If you know the formula, you get the answer immediately, guys. What is the angular width? Angular width is lambda by small d. So it is independent of d. If the screen is moved away, that means d has been increased. There is no d in this, so delta theta is constant. Yes, it is constant. Statement 1 is definitely correct. What about the next statement? It is replaced by a larger wavelength. If it is replaced by larger wavelength, delta theta will also increase. Here it says decreases. This is wrong. So statement 2 is wrong. So 1 is correct, 2 is wrong. 1 is correct, 2 is wrong. Yes, option B is the answer. No, it is not A, it is not C. Yep, option B is correct. Okay, this is the angular width formula, fringes. Just like beta was lambda capital D by small d. So this delta theta actually is your beta by capital D. Beta is lambda capital D by small d, and this d, they cancel out, and that's how you get this formula. That's how you get this formula. You should know what capital D and small d stands for. The screen is moved away from the plane of the slits in a YDSE setup. This is very straightforward. Obviously, the linear separation of the fringe width increases because beta is lambda d by small d. So what happens if d increases? Fringe width increases. So the separation of the fringes increases as you move the screen away from the slits of the Young's double slit experiment. Is that right? Moving on, next one. If you pass through a polarizer, intensity of the light on the analyzer making angle of 30 degree with that of the polarizer, the intensity of the emitted light. This is Malu's law. the intensity of the light coming out is the intensity of the light coming in into cos square of the angle. So I into cos square 30. Cos 30 is root 3 by 2. Square it will become 3 by 4. So 3I by 4 should be the answer, which is option number D. Which is option number D. Is that okay? Everybody with me? Yes, D for doctor. Perfecto, perfecto. Very good, very good. Next question. All right. I wish I had studied so much during my days. I think I'm studying more as a teacher and solving more as a teacher. I hope at least you solve more than me. Okay. Yeah, I hope, guys. Pakka? Or is it the first time, sir, somebody literally made us, I think you are the only one who has made us solve all these problems first time like this. Otherwise, we solved like some 20 problems. Today, chapter number 5 will solve all PYQs. So happy, very happy. Sir, I solved 20 questions today. Nothing doing. We are aiming for AIMS. We are aiming for AFMC. We are targeting 700 score. We want to improve the rank of students who are getting 200, 300 marks to 600 marks at least. So when we target like that, we have to put in that extra effort. We cannot solve 20, 30 lallu pallu questions. Yeah, we are now legends now. We are legends who are solving like 1000+ questions in 4 days in this 4-day challenge. And when we give it to you as a challenge, it is a challenge for us, man. Because we have to come over here. Okay, giving a challenge is easy. Hey, come on, do. So many people make strategies. Yeah, do 1000 questions. Yes, very good, motivation. But you come and do it. That is where the interesting part lies. And I'm so proud of this channel that we are doing it for you. Right? Correct. So, YDSE setup, a student observes 8 fringes in a certain segment of the screen when monochromatic light is used. The wavelength when 400 nanometers, then how many fringes? Okay. See, if each fringe width is beta, right? And there is a particular segment of whatever, let's say I call it X, in that you are seeing some N fringes. Let's say these are N number of fringes. Then can I say X is basically N times of beta? If you change the wavelength, obviously beta will change because beta is nothing but lambda capital D by small d. So now think about it. If X has not changed, D has not changed, small d has not changed, N lambda is basically going to be a constant. So N1 lambda 1 will be N2 lambda 2. So first time, how many fringes? 8 for wavelength of 600. Second time, how many fringes? I don't know, for a wavelength of 400. So basically N2 will be nothing but this 0 goes, this 4 goes with this 8 2 times, 2 into 6 divided by 10, I believe. Yes, so this will be 12 by 10. Something is wrong. Oh, this was 600. I'm so sorry. This was one more 0 which was getting cancelled. Yeah, so no need of that 0. So 2 6 are basically 12. Yes. So you will see 12 fringes. You will see 12 fringes. So what exactly happened is when you change the wavelength, the fringe width reduced or fringe width increased. So because of which you are seeing different number of fringes. So first time the wavelength was more. So the fringe width was also big. So maybe you are seeing few fringes in a particular region. Next time the wavelength reduced, so fringe width also will reduce. So now you will see more number of fringes in that same region. That is what has happened. Okay, wavelength change, fringe width change. So more number of or less number of fringes will be seen in the same region. Did you understand the question? Did you see how we solved it? Yes, 600. Susi, yes, very good. Yes, I made it 600. Next one, what is it? Light wavelength coming from a star, the limit of resolution has been deleted. So don't bother solving these questions. Let's go ahead. In Young's double slit experiment, the separation between coherent sources is halved distance of the screen from the coherent sources is doubled, fringe width will become beta is equal to lambda capital D by small d. What and all have you changed? Separation between the sources is halved. That means this has been made half times. Okay. And the distance of the screen from the coherent sources is doubled. That means this has been made 2 times. When I say 1 by 2, it actually means that 2 will go on the top only. The 2 will go on the top. 2 2s are 4. So basically the fringe width will become 4 times. Just check this out. Fringe width will become 4 times, yes. Because you are reducing the denominator, that will increase the ratio. You are also increasing the denominator. So both are contributing in the increase. So 2 times because of capital D, 2 times because of small d. 2 2s are 4. So fringe width will increase 4 times. Moving on to the next one. YDSE light wavelength was used. Angular width of the screen 1 meter away was this much. What will be the angular width of the first minima if the entire experimental setup is immersed in water? Okay, angular width. Okay. So remember, angular width was, remember, lambda by small d. So delta theta is proportional to lambda. But also do not forget that lambda is inversely proportional to the refractive index. More the refractive index, smaller is the wavelength because lesser speed. Speed becomes less, wavelength becomes less, right? So it is indirectly proportional to mu. So basically, when you have poured water, what will happen? Let's have a look. Delta theta 2 by delta theta 1 is the refractive index in the first case upon second case. So delta theta 2 upon delta theta 1, how much is it? 0.2 degrees. 0.2 degrees is delta theta 1. First time it was air, second time it was water. So 4 by 3 over here. So delta theta 2 is 0.2 into 3 divided by 4. This goes with this 2 times. So 0.1 is remaining. So 0.3 by 2. 0.3 by 2, which is 1.5. So 0.15. Yes, 0.15 should be the answer. Yes, it is. So option number A. Option number A. Is that right, everyone? Cool. Correcto? Everybody with me on this? A lot of people lost enthu now. Sir, so many questions. I know. Coming up with the next one, and we have reached modern physics. Okay guys, come on. I want the energy, full josh. All the people present here, light up the chat box quickly. Taka, let everybody know sir has come to the last final part, and that is modern physics. Final part guys, modern physics. Modern physics and semiconductors. Come on, let's do this quickly. I know Diksha ma'am's lecture is also there. I think I'll have to message Diksha ma'am. Ma'am, I'm so sorry. I think I'm just like probably going to take up the lecture a little bit ahead. We'll try to see as many questions as possible. Okay. Other things we will see maybe in the PDF or something like that. Yes. Yes, Gopika ma'am is also in the chat box. See, let's go guys. Few more, I think few more 100 slides are there, or maybe less than 100 slides. Last part. Okay, I think I have shown the answer, but even if I don't show, what is it? The ground state energy of hydrogen atom is this much. The energy needed for ionizing hydrogen atom from its second excited state will be, see, this is n is equal to infinity. This is ground state. This is your ground state. This is n is equal to 2. This is, let's say, n is equal to 3. In the ground state, the energy will be minus 13.6 electron volt. Minus 13.6 electron volt, right? Here you get minus 3.4 electron volt. Here you get minus 1.51 electron volt, and so on and so forth. This is your first excited state. This is your second excited state. So when you ionize from here, you would need to go from minus 13.6 to 0 energy level. So 13.6 electron volt is needed. When you go from second excited state to here, you will just need 1.51 electron volt of energy, which is option C, which is option C. Is that okay? If you know the energy level diagram of standard hydrogen atom, Bohr's model of atom, you will get the answer very, very easily, peasily. Moving on, next question on your screen now. The wavelength of Lyman series of hydrogen atom appears standard fact-based question. If you know it, you know it. You don't know it, you don't know it. It is always going to be in the ultraviolet region. Lyman is in ultraviolet. Then slowly you go from visible to infrared region as you go to the higher order series. Lyman to Balmer, Balmer to a bracket, P-fund and all these things. Slowly you go to infrared region. Keep that in mind. Angular momentum of the electron moving in an orbit in the hydrogen atom is 1.5 h pi. Energy in the same orbit is nearly. Okay, Bohr's postulates, if you remember guys, Bohr's postulates, you will know this. Angular momentum is nh by 2 pi. It's given, it is 1.5 h by pi is nh by 2 pi. This was already given to me. I just substituted. 1.5 is 3 by 2. So 3h by 2 pi is nh by 2 pi. Comparing n is equal to 3. H by 2 pi, h by, oops, I think I put that 2 pi 2 times. Yeah. Comparing n is equal to 3. So in the third orbit, what is the energy, guys? In the third orbit, the energy is energy in the first orbit divided by 3 square. So minus 13.6 divided by 9. How much does it come out to be? 1.5 negative electron volt. Yes, that is the correct answer. Energy in the first orbit divided by 3 square is the energy in the third orbit. First orbit energy minus 13.6. Very good. Very good. Let's move on. Let's move on. Let's move on. Next question on your screen now. Next question on your screen now. What is it? Hydrogen spectrum, the shortest wavelength in the Balmer series is lambda, the shortest wavelength in the bracket series. Lyman, Balmer. Come on, guys. So this is 1, this is 2, this is 3, this is 4, this is 5, and so on and so forth, and then finally infinity. So when we talk about the shortest wavelength, you should look at the longest transition. The reason for that is delta E is hc by lambda for shortest wavelength. Maximum energy difference you should look at. So the shortest wavelength in the Balmer series, Lyman Balmer, so you are going to 2. So you are coming from infinity to 2. This is basically lambda. This is basically lambda. Okay. This is for the shortest wavelength. You will look at the maximum energy. So minimum energy will give you maximum wavelength. The shortest wavelength in the bracket. So for bracket, what will be the transition from? Answer in the chat box, my dear warriors. Come on, what will be the transition from? Quickly tell me, what do you think it will be? Yes, from infinity to over here, from infinity to 4, Pakka. That's it. Your job is done. That's all. Your job is done. Yep. So from here you can see E infinity minus E2 is hc by lambda. E infinity minus E4 is equal to hc by lambda 1. How much it is going to be? So you can just subtract the 2. You can just subtract the 2. You can see you will get this as E4 minus E2. Okay, I'm just subtracting the 2. E4 minus E2 is basically hc by lambda minus hc by lambda 1. I don't even have to do that actually, but anyways, why did I even do this? This was not needed. Sorry guys. Sorry. It was not even needed. I can just do this. 1 by lambda is equal to r into 1 by 2 square minus 1 by infinity square, and 1 by lambda 1 is equal to Rydberg's constant 1 by 4 square minus 1 by infinity square. 1 by infinity is 0. 1 by infinity is 0, right? Yes. So that's all. From this, just divide them. 1 by lambda by 1 by lambda 1. 1 by lambda by 1 by lambda 1. R will cancel. 1 by infinity is 0. So it will be 1 by 2 square by 1 by 4 square, which is 1 by 4 by 1 by 16, which is 4 by 1. This will become lambda 1 by lambda. Lambda 1 by lambda. So basically lambda 1 will become 4 times of lambda. So that is the answer. Okay, great. Is that clear? So you should know all these series and what are the transitions and the Rydberg's formula. Next question. The radius of the innermost orbit of the hydrogen atom is this much. What is the radius of the third allowed orbit of the hydrogen atom? So guys, over here, radius is directly proportional to the n square, right? Radius is proportional to the n square. So R3 by R1 will be 3 square by 1 square. So R3 will be R1, bring it on the top. R1, bring it on the top. R1 is 5.3 into 10 to the power minus 11. 3 square is 9. 3 square is 9. 9 into 5, almost like 4.77. Yes. 9 5s are 45. So slightly more than 45. So it will be approximately 4.77. Yes. Perfecto. Perfecto. Shall we move ahead to the next question coming up on your screen? Here it is. Here it is. Here it is. What is it? The de Broglie wavelength associated with an electron accelerated by the potential difference of 81 volts is how much? So de Broglie wavelength is asked. So lambda is basically h by p. Momentum is nothing but root of 2m kinetic energy. Now next part, kinetic energy is nothing but charge into voltage difference. Correct? And here you can substitute 6.6 into 10 to the power minus 34, and then you can put 2 into 9 into 10 to the power minus 31, charge 1.6 into 10 to the power minus 19, and then voltage difference, how much is it? 81 over here. All these things you can put. All these things you can put. How much is the answer that you are getting? How much is the answer that you are getting? Come on. Yo. Is it coming out to be something, my dear warriors? Is it coming out to be something, my dear warriors? Tell me. Is the answer coming out to be like 0.136 nanometers? If you get 0.136 nanometers, very good. If you don't get, redo it and see if it matches again. Okay, so that is the answer out there. Cool. Let's move ahead. Okay, let's move ahead to the next one. The maximum kinetic energy of the emitted photoelectron in the photoelectric effect is independent of the maximum energy of a photoelectron is independent of what? See, energy of the photon is work function plus the kinetic energy. So definitely this kinetic energy depends on the frequency, depends on the material. This is material. This is the frequency of the light. It depends on the work function, yes. It depends on the frequency, yes. Wavelength and frequency, yes. But intensity, definitely not. So it does not depend on the intensity of the incident radiation, which is option number B. Exactly. Very good. Long calculation, I know, Pratyusha. But you know what? You can always do one simple thing for the previous one. I don't know how many of you know that simple calculation trick for this problem. There is a simple formula and it is nothing but 1.227, 1.23 approximately, right? Or you can just put it as 1.2 or 1.3, around that region, upon root of voltage difference, upon root of that voltage difference. This is also a much better formula rather than substituting everything. And just substitute your delta V as 81. Just substitute it as 81. Root 81 is 9. So it will just become 1.2 divided by 9 approximately. Actually, it is 1.227 over here, 1.227. This answer is in nanometers automatically. So you can avoid this long calculation. This method will be slightly longer, whereas if you do this, this will be a short method. Remember this formula, 1.227 by root V. How many of you remember this? If you don't remember this, now I am telling it to you. Okay, so remember that. I was hoping that somebody will tell this, but nobody told. So I was like, okay, fine, I'll show you the long method. Then if nobody tells, then I will show you the short method. Okay, so guys, this is the short method for that. All right, shall we move ahead to the next one? Work function is given for 3 different materials, and incident light has energy of 2.2 electron volt, which may emit photoelectron. Guys, 2.2 is incident. I think only this guy can, because this is less than this. You want the work function to be less than the incident energy, whereas this and this won't be able to do it because their energies, work functions, are more. So only when the work function is less than the incident energy of the photon, you will see the photoelectric effect will occur. So that means only for cesium, I believe, CS, only for CS, only for cesium it will occur, otherwise it won't. Is that clear, everybody? No, it is not option A, it is option number D for doctor, D for doctor. Moving to the next question on your screen now. What is it? The minimum wavelength of X-ray produced when accelerated through the potential difference. By the way, X-rays have been deleted, so no point discussing it, but still, if you have to solve it, how will you solve it? Basically, hc by lambda is going to be the energy of the photon. That comes by accelerating the electron by a voltage difference, so it will be Q into basically delta V. So this is how you get that equation. Hence, what is it? The wavelength. So you can see this lambda, 1 by lambda is directly proportional to delta V, or lambda is inversely proportional to delta V. So the answer comes out as option A. Yes, that is the correct answer. So lambda is inversely proportional to the voltage difference. That's how you get it, but anyways, X-rays is not there right now, so don't bother. If R1 is the radius of the second stationary orbit and R2 be the radius of the fourth stationary orbit, then the ratio is how much? Radius is directly proportional to n square, so R1 by R2 will be something by something square. R1 is the radius of the second orbit, so n is 2. R2 is the radius of the fourth orbit, so n is basically 4. So 2 by 4 is half, half square is 1/4. So answer is 0.25, I believe. So 0.25, yes, that is the correct answer. Is that okay, my dear warriors? So direct question on how is the radius going to be proportional to what and all of that. Moving on to the next question, guys, coming up on your screen. Okay, the ratio of the Coulomb's force to the gravitational force for proton and electron by some distance is basically this much. The ratio proportionality constant K is 1 by 4 pi epsilon naught to the gravitational constant is nearly given the charge of the proton and electron is this much, the mass of the electron is this much, and the mass of the proton is this much. Okay, so basically I'll tell you what has to be done. Gravitational force is nothing but, or rather let's start with Coulomb force. Coulomb force is nothing but 1 by 4 pi epsilon naught Q1 Q2 by R square. Here the charges are same, so E into E divided by R square. Similarly, the gravitational force is G m1, mass of the electron, mass of proton, divided by R square. Now you basically divide both of them. So the ratio of the Coulomb force to the gravitational force, R square cancels. You will have 1 by 4 pi epsilon naught by g. Here you will have E square, and here you will have mass of electron, mass of proton. Now this ratio is what is given. This ratio is what is given to you, and this has been asked. This particular quantity has been asked. So 1 by 4 pi epsilon naught by g. That is what is asked. This value to the gravitational constant ratio is how much? That is what is asked. Bring these people onto the other side. So it will become mass of electron, mass of proton divided by E square. E square goes below. Fc by Fg remains as it is. Fc by Fg remains as it is. Now substitute everything. Everything is known to you over here. Nothing is hidden from you. Mass of electron, mass of proton is given. So it will be 9.11 10 to the power minus 31. Mass of proton 1.67 10 to the power minus 27. Electron charge 1.6 10 to the power minus 19, and then whole square. And this ratio was given to be 2.4 into 10 to the power 39. This was in NEET 2022, very sadistic problem. What is this kind of problem called as? Sadistic. Very sad. Very sad problem. Very sad problem. Unnecessarily calculations are there, but otherwise there is nothing great about this problem, miraculous about this problem. It's very straightforward theoretically, but it's just about calculations. So somebody had a very bad day when making the paper. So expect such 1 or 2 questions. Expect such 1 or 2 questions. Yes, this is really studying 10 power 38. Very good. Yep. So no, the answer comes out as 10 to the power 20 after solving. Okay. Right. Moving on to the next one. Coming up on your screen, T1 and T2 be the energy of the electron in the first and the second excited states of hydrogen atom respectively. According to the Bohr's model of the atom, the ratio of T1 by T2 is how much? Okay, let's see. What is this? T1 and T2 be the electron energy in the first and second excited states. According to the Bohr's model, what is the ratio of T1 by T2? So T1 by T2. See, first excited state means it is actually in the second orbit. Second excited state means it is in the third orbit. So E2 will be minus E1 by 2 square, and E3 will be minus E1, or I don't even need that minus. It's okay. E1 by 3 square. So it will be 3 square by 2 square, which is 9 by 4. 9 by 4 is option D. Yes, it is option D. So remember, first excited means it is already excited. So from 1 it has gone to 2. Second excited state means 2 states above 1, which is going to be n is equal to 3. I hope this is clear. And energy of any nth shell is first shell energy by n square. That is the formula which I have used, which will give me 9 by 4. 9 by 4. Moving on to the next one coming up on your screen, and here it is. Rapid fire mode, guys. Rapid fire mode. Nucleus of mass number something is splitting up. And the question is, the 2 nuclei have this much and this much mass number. The ratio of the radii of the 2 daughter nuclei is respectively. We know radius is directly proportional to a raised to 1 by 3. So R1 by R2 will be A1 by A2 whole raised to 1 by 3. A1 is 125, A2 is 64 whole raised to 1 by 3. So 125's cube root is 5, 64's cube root is 4. So 5:4 should be the answer. Yes, it is 5:4. Great, everybody. No problem, Apurva, but you have missed a lot of problems, let me tell you. Yeah, you will have to cover up this session sometime. Yeah, I know it is a big session. You will have to take up your time, right? Okay. Moving on. The light rays having photons of energy this much are falling on a metallic surface having work function this much. The stopping potential of the surface. Energy of the photon is a work function plus kinetic energy, which is E times of Vs. Energy of the photon is 4.2 electron volt. Work function is 2.2 electron. volt, and this is E into Vs. E will cancel. So 4.2 minus 2.2 is equal to Vs. So Vs is basically 2. Not 2 electron volt, 2 volts. How can volts be 2 electron volts? It will be 2 volts. Energy will be 2 electron volt. There is a difference. Many people got confused between these two options in the actual exam because they did not put this E. They got 4.2 E minus 2.2 E. They got it as 2E. So that's a common mistake. Getting my point? Okay. Yes. Let's move on to the next one on your screen now. The threshold frequency of a photoelectric metal is V0. The light of frequency 4 V0 is incident on the metal. Then the maximum kinetic energy of the electrons will be how much? Okay. So threshold frequency is this much, light frequency is this much. What is the maximum kinetic energy? Energy of the photon is work function plus kinetic energy. Energy of the photon is h into 4 nu naught. Work function is h nu naught. Why? Because work function is h into critical frequency, threshold frequency. So kinetic energy will become 4 minus 1 h nu naught, which is nothing but 3h nu naught. So 3h nu naught should be the answer, which is option number D. Yes, that is the correct answer. Is that okay, guys? Everybody with me? Moving on to the next one coming up on your screen. When two monochromatic light of frequency V and V by 2 are incident on a photoelectric metal, that stopping potential becomes Vs by 2 and Vs respectively. The threshold frequency for this metal will be how much? Okay, so two situations, two separate equations will be needed. So first time this and this. So h nu is equal to hf naught plus E times Vs by 2. Yes, perfect. And second time, when I use this respectively, h frequency is nu by 2, it will be h f naught plus E Vs. I feel there is something wrong in this, because if you reduce this, how is it increasing? There is something wrong over here. I remember there was some kind of a play, maybe some information is wrong. Either this is nu and Vs by 2, this is not Vs by 2, this will be Vs, and if this is becoming half, this should also become half, but that also is not possible. I think, this information given here is not matching, because how is this possible? Look at this. Frequency has reduced, stopping potential has not reduced, it has increased. From half it became 1. So there is a wrong data in this problem. There is a wrong data in this particular problem. Keep this in mind. Okay. So, but these would be the equations as per the data. Otherwise, nothing great is there. In waves chapter, Arjun, Young's double slit experiment. That is the main thing about the chapter, and polarization. Young's double slit experiment and polarization, right? So ignore this solution also. This solution given also will be wrong then. Okay. A nucleus with mass number 240 breaks into fragments. Binding energy per nucleon is given. The total gain in the binding energy is how much? Right, perfect. Let's have a look at this. Whenever binding energy problems are given, what to do? Okay, write down what is happening first. Mass number 240. Okay, it breaks down into two fragments, 120, 120 each. So 2 multiplied by 120. Okay, the binding energy per nucleon of the unfragmented means this one, is 7.6. 7.6, but 240 nucleons in it. So 240 into 7.6 mega electron volt is the total binding energy of the reactant. Here, if you look at the product, the binding energy of the total product which is formed, there are two such atoms. So first of all, multiply by 2. There are 120 nucleons in this. 120 nucleons in this. So 120, and each nucleon has an energy of 8.5 mega electron volt. Now if you subtract these two, what you get is the gain in the binding energy of the process. You can see it was 7.6, it became 8.5. So energy has increased between these two. So the gain in the binding energy will be this number, is 2 into 120, which will make it 240 into 8.5. So it will be 240 into 8.5 minus 240 into 7.6. So it will be 240 multiplied by 8.5 minus 7.6, which is 0.9, I believe. Yes. So 24 into 9. Come on, guys. It is 216, I believe. Close to that. Yes, it should be 24 nines. Yeah, very good. So that is the answer. Yes, A for M's. Perfect. Moving ahead. A lot of questions are there. A lot of questions will be there, guys. Let's do this quickly. Let me just call up Diksha ma'am 1 second and let her know that it is taking little bit more than usual. Okay, so I just spoke to Diksha ma'am. Diksha ma'am will be taking the class at 6 o'clock. I will be just taking the class to around 5:15, so that you also get a break of 40-45 minutes at least. Okay, so let's go, guys, full-fledged. Number of photons per second on an average emitted by the source of light of wavelength when it delivers this much watts of power is how much? So if energy of each photon is EP, if there are n number of photons, total energy will be NEP, and the time taken for it to come out is T. So this will be the total energy. This will be total energy per unit time. This will be nothing but the power. This will be nothing but the power, and energy of each photon is hc by lambda. So power is given. I think number of photons per unit second is asked. So n by t will be power by hc, and lambda will go on the top. So just you have to substitute the values now over here. Power is 3.3 10 to the power minus 3. Lambda is 600 nano. So 10 to the power minus 9. Whole thing divided by h and c. What is h? H is basically 6.6 10 to the power minus 34. And what is speed of light? Obviously it's 3 into 10 to the power 8. 3 into 10 to the power 8. Just do the math and see if you get the answer as 10 to the power 16. Solving this, you should get the answer as 10 to the power 16. Did you understand the method? I found out total energy. Total energy will be each photon's energy n times, but per unit time will give me power. That is why I divided by time. And the question has asked me number of photons per second, n by t. That is why I brought all these people here, p lambda by hc. Last step is just substitution. Can we write hc by lambda? I'm not able to see your comment as 20 times 10 power 26. So no, don't write it like that. Acha, oh, HC. Okay. Like that. You can multiply 6.6 into 3 into 10 to the power 8. So minus 34 and this will become 26. Yes, you can use that. You can use that. Rivoli study, definitely. Electromagnetic wave is incident on a surface, negligible work function. Mass of the if m is the mass of the electron emitted from the surface, the de Broglie wavelength will be how much? Very interesting question. A photon is falling on a surface and the electron is being ejected. That has some wavelength. The question is, the de Broglie wavelength of that electron is how much? The photon has a wavelength of lambda. This is the entire scenario. So negligible work function is given. So the energy of the photon is roughly almost equal to the energy of the electron. So energy of the photon is hc by lambda. This is the energy of the electron as well. I will need this later on. Why? Because when I calculate the de Broglie wavelength, which is h by p, that p is nothing but root of 2m energy of the electron. That's all. So that is where I will need it. So lambda d will be h by this whole thing, h by root of 2m. Energy of the electron is hc by lambda. So here you are just going to substitute this hc by lambda over here. So root lambda will go on the top. H is there over here also, and below also you will have root 2mch. Root h will cancel. You will get root of lambda h by 2mc is lambda of d. Root of lambda h upon 2mc, which is option number D. Just check this out. So that was lambda d. So if you want to find lambda, square both sides. I think you'll have to square both sides and shift the terms. So lambda d square and 2 times of mc upon h is equal to lambda. Yeah. 2 times mc by h and lambda d square is equal to lambda, which is option number D. Perfect. We got the answer. Okay. So whatever we found till here was lambda d, but the question asked lambda. So I squared it. I shifted 2mc here, brought h below. What was left was just lambda, which is obviously option number D. Cool? Yes. Okay. So Diksha ma'am is in the chat box. She is telling, please take rest after the physics class, right? I know you guys will be tired a little bit. Organic session is going to start and organic class will not be for a very long time. Okay, so that way you can be pretty much rest assured, you will not be extra tired. But I feel even if you are tired, it's worth it. How many of you feel it is worth it, right? Even if the class went on for 9 hours, it's not like we are doing time pass, right? We are doing problem. Thank God I studied. Thank God I was here. Thank God, even if it pained me, even if I was stressed out, but it was all worth it when I went into the college. Right. So moving on. Which of the following Bohr model is not valid? Bohr's model is not valid in certain situations. What is that certain situation, my dear students? When it is not a single electron atom. When it is not a single electron atom, then it is not going to be valid. Ionized helium, 1 electron. Deuteron, again 1 electron. Hydrogen, obviously. Ionized neon, obviously it has more than 1 electron, so it is not going to be valid. Next one, the energy equivalent of 0.5 gram of a substance is simple, mc square. E is equal to mc square. Use this formula. Mass is given 0.5 gram into 10 to the power minus 3. C is 3 into 10 to the power 8. Square it. That's it. You will get the answer. 4.5 10 to the power 13 joules, right? So just multiply it, guys, and you will get the answer over here. Cool. E is equal to mc square. So when you destroy this much mass, you get that much amount of energy. That's what it is all about. Light of frequency 1.5 times threshold. What will be the photo current if the frequency is halved and the intensity is doubled? Okay, what will happen to the current? First of all, if the incident frequency is 1.5 times f naught, if you make the frequency half, f by 2, basically it will become 1.5 f naught by 2, which is 3 by 2 by 2 f naught, which is 0.75 f naught. Yeah, oh, it is less than f naught. So basically no photoelectric effect. Forget 4 1/4 the double, it will be 0. There will be no photoelectric effect only because the frequency has become less than the threshold frequency. Doesn't matter how intense the light beam is. Correct? Moving on to the next one. Light flux falls non-reflecting surface area. Energy received by the surface during the span of 1 minute. Look at the units, you will get the answer. This is watt per centimeter square. 20 centimeter square is there. So the total energy will be intensity into area. Intensity into area. Intensity is 20 watts per centimeter square into 20 centimeter square will make it how much? Oh, this will make it 40 watts. 40 watts is, sorry, why did I do 40? 400 watts. 400 watts is 400 joules per second. This is joules per second. Correct? This is what it is. This is the total energy which is coming per unit time. Total energy which is coming per unit time. So the total energy will be there. It will be 400 joules per second into the time. Into the time. So what is the time going to be? That time is going to be how much? 1 minute. 1 minute means 60 seconds. Correct. So I think 4 6 are 24. The option B should be the correct answer. Yes, it is. I didn't even solve it. How do I know it is like that? 2 zeros and this 0, ignore it. 4 6 are 24. No other option has 24 in it. I will directly mark it as that one. Is that right, everyone? Let's go to the next one on your screen. Get ready, guys. So what do we have? Electron accelerated from rest, potential difference this. I just now told you a formula for the de Broglie wavelength. Remember, it was 1.227 nanometer by root of delta V. By root of delta V. Now this lambda itself is given as 1.227 10 to the power minus 2 nanometer. So 1.227 nanometer got cancelled. Only 10 to the power minus 2 is 1 by root delta V. Square it. 10 to the power minus 4 is 1 by delta V. So delta V is 10 to the power 4. 10 to the power 4, which is option C. So if you know this formula, it becomes very easy. Else you will waste a lot of time. So lambda in nanometers de Broglie is this number divided by delta V. Correct. Very good. Moving on to the next question coming up on your screen. Here it is. It says alpha particle. Oh, come on. This is very straightforward. I want everybody spamming the answer. Everybody spamming the answer. Come on. Quickly. It's such a lallu question. Two protons, two neutrons, no electrons. Alpha means double positive charge. So two protons are there giving that positive charge. Neutron will not give the charge but will add to the mass. So 4 AMU will be roughly the mass of the alpha particle, right? Moving on to the next one on your screen. Here it is. What does it say? Oops, I showed the answer accidentally. It's okay. The total energy of an electron is this. The kinetic and the potential energies. Okay. Direct problem. Kinetic energy is negative of the total energy. So whatever is the total energy, just the negative of that which will make it 3.4. And if you talk about the potential energy, it is twice of the total energy. So 2 times of minus 3.4, which is minus 6.8. So that is the answer. That is the answer, which is option A. This formula is very important. You will see that in gravitation also and in atomic structure of chemistry as well as in physics. So kinetic is negative of total and potential is double of the total energy. Yes, option A. It was a direct question asked in 2019. An electron accelerated through this much volts de Broglie. Again, same formula being asked. That means it is very important, right? So lambda is nothing but 1.227 nanometers divided by delta V. Here it is 1, 2, 3, 4, 10 to the power 4, 10 to the power 4. So it will become 1.227 nano is 10 to the power minus 9. This will become 10 to the power 2. This will become 10 to the power 2. Make it on the top. So it will become 1.227 into 10 to the power minus 11. Minus 11, which is 12.27 into 10 to the power minus 12, right? Just shift the decimal. Shift the decimal here. You will make it 10 to the power minus 12 then. Make sense? Option A for Ames. Wow, very good, very good. Moving on to the next question. Wow, we have come to semiconductors. This is so cool. Let's go. On the basis, I think we will be done close enough to 510, not more than that, okay. On the basis of electrical conductivity, which one of the following material has the smallest resistivity? That means it's a very good conductor. Germanium is a semiconductor, glass is a bad conductor, silicon, semiconductor, silver is the only conductor. In fact, it's one of the very good conductors. If you give copper and silver, silver is a better conductor than even copper. So silver is the answer. Moving on to the next one. What is it? The given circuit is equivalent to this one. Is this equivalent to this or this? Okay, I'll tell you what. This is actually De Morgan's principle, if I'm not wrong. A, this is A bar. B, this is B bar. This is a NAND operation, so it is AND and a NOT gate together. So ANDing means dot. A bar dot B bar, that is your AND operation, dot. Knotting is putting a bar over this. Now there is De Morgan's principle which says A bar dot B bar, if it is there or some dot something is there, okay, this is one quantity, this is one quantity. What you do is that complete roof you divide it into two parts. That complete bar divided into two parts. This dot you make it into plus. And whatever was there inside, you put over there separately. So what was there inside? A bar was there and B bar was there. A bar was there and B bar was there. So whatever is there in the brackets, put it separately. And that roof, you split it. But when you split it, if it is dot, make it plus. If it is plus, make it dot. That is your De Morgan's principle. A bar bar is A, B bar bar is B, A plus B, that means it is an OR gate. This is an OR gate, if you see. Oh, sorry, what just happened? Guys, I'm so sorry. This was OR gate, but here I made a mistake. I made a big boo-boo. Oops, this was not dot, this was plus. Happens. Too much time problem solving, right? And instead of and I wrote, instead of or I wrote and. Where is this? This is or and this is not. Even then, the method remains the same. Let me tell you that. So this is A bar, or means plus, B bar, and not of it, that means like this. And I'm doing or operation on these two variables. So the first step, like I said, if it is a bar, split it up into two parts. And if it is a plus, make it a dot. If it was a dot, make it a plus. And then whatever was written, put it separately over here. So this will be A bar and this will be B bar. A bar bar is A, B bar bar is B. So A dot B, which is nothing but AND gate. AND gate means this is the option. Okay. If this was a NAND gate, then this would be the option. This is OR, so it became AND. If this was AND, this would have become OR. Cool. That is the correct answer. This was asked in NEET 2023. Yes, yes, yes. Hello Kitty. I changed it. Yep. Cool. Let's move to the next question. Please remember that principle which I told you. It is called De Morgan's principle. I have taught it in the logic gates class. Please watch my logic gates lecture. Okay. Please watch my logic gates lecture. P-type extrinsic semiconductor is obtained when germanium is doped with P-type. That means one less electron should be there. Which one? Phosphorus is pentavalent. Which one is it? Arsenic, boron, antimony. NEET 2023 question, guys. If you know it, you know it. Boron. Boron is the correct answer. For germanium, you use boron. For silicon, you use aluminium. For silicon, you use aluminium. It should be in the same, line of the periodic table. Okay. So boron is for germanium. If you go for silicon, it is going to be aluminium, the next level of element. Okay. That's how it works. Moving on to the next question coming up on your screen. Two statements, which is correct, which is false. Read it for yourself. Read it for yourself and let me know. Photovoltaic cells can convert radiation into electricity. Yes, solar cell. That is what they do. Perfect. Zener diode is designed in reverse bias in the breakdown. Perfect. Nothing wrong. Both are correct. D option. D for doctor. Both are correct. Use Zener diode in reverse bias to regulate the voltage in the breakdown region. Correct. Solar cell takes electrical energy, takes solar energy, light energy, converts it into electrical energy. Perfect. There is nothing wrong in both of them. Full wave rectifier consists of two PN junction, a center tap, capacitor and a load resistance. Which of the components remove the AC ripple from the rectified output? This is very interesting. Come on, let's see how many of you can do this. Come on, my dear warriors. So, when you have a AC input, the output that you get after rectification is a DC output, which is like this for a full wave rectifier. But these are ripples. These are ripples. You remove that ripples, you make it a little bit smoother. You make it a little bit smoother so that it is almost constant. And this happens because of which instrument? From this to this, it's because of the diodes and the center tap transformer. From here to here, it happens because of the capacitor. So the ripples are removed. The wavy nature is removed because it's made constant because of the capacitor. So I think capacitor should be the answer. Yes, perfect. Capacitor. What is the job of a capacitor? The capacitor stores the charge when excess charge is there, and when low current or low charge is there, it gives it. So it gives when in need and stores when not in need, thereby making the current and the voltages constant. That is the job of this. Is that okay, guys? Everybody? Let's move to the next one. For the following circuit, the truth table is, first of all, this is A, this is A bar, this is B, this is B bar, this is a AND with a NOT gate. So if you strictly think about it, it is A bar, AND means dot, B bar and a big bar over it. I told you about De Morgan. When there is a big bar, separate it out. If there is a dot, put a plus. And whatever is there on both sides, write it as it is. A bar and B bar. A bar bar is A, B bar bar is B. So this is nothing but a OR gate. This is nothing but a OR gate, guys. So it's just going to be a OR gate truth table. 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. Any one is high, it will become high. Both are low, it will be low. So it's a OR gate truth table. Is that okay with me and every one of you? Yes? Shall we go ahead? Identify the equivalent logic gate represented by this particular circuit. Very interesting question. If you can crack this question, I would be really happy with you. See, there is high voltage, there is a resistor, there is LED. If it glows, it is 1. Okay, that is the output that you are expecting. If it glows, it is 1. If it does not glow, it is low. The current has 2 paths to go. Just imagine both are off. Both are basically off. What will happen? The current can't go anywhere. The current can't go anywhere. So the output will also be not there. Now just imagine one of the switch is closed. So the current will immediately go like this and go to the ground. So if this is on, this is off, this is on, this is off, the current has a path, the light will glow, correct? So I will put 1 over here. Now, if you close this and if you close this and you keep this open, what will happen? The current will go like this. So this is 0, this is 1, the light will still glow. And what will happen if both the switches are closed? It has two-way options. So the answer will be again 1. The answer will be again 1. Yes, correct. So you will see, my dear warriors, it will glow. So this is the truth table of OR gate. This is the truth table of the OR gate. Is that right? What a question is it? What an amazing question, right? Perfect. Let's go to the next one on your screen now. The incorrect state. Incorrect. Underline this. Underline this. Okay. About the property of a Zener diode. What is wrong about a Zener diode? P and N regions are heavily doped. That is correct because it has to have a good breakdown voltage. Zener voltage remains constant at breakdown. That is also correct. It is designed to operate under reverse bias. That is also correct. Depletion region is very wide. That is wrong. Depletion region is very small. Okay, so D option is wrong. Moving on to the next one. In the given circuit, the potential drop across the two PN junctions are equal in which of the following circuits? That is the question. Come on, think about it. Very interesting question. Very interesting question. I have a feeling if their voltages are same, both should be identically biased. Either both are forward or both are reversed. Then whatever happens in the first will happen in the next. If one is forward, one is reversed, obviously their voltages won't be the same. Here, both of them are forward biased. So yes. Here, one is forward, one is reverse. No. Here, both are reversed. Yes, this will also work, this will not work. So both A and C means option D should be correct. Yes. Either both are same direction or both are reverse bias, that will work. One is forward, one is reverse, will not work because one will have, because it's in the forward bias, current will tend to go easily. The voltage barrier would have reduced, but in the reverse bias, the voltage barrier would have increased. The potential between P and N junction would have been increased. So the voltages would be the same. Got it? Everyone with me? Let's move to the next question coming up on your screen. As the temperature increases the electrical resistance, what will happen? As the temperature increases the electrical resistance, yes, come on. Increases for both conductors and semiconductors? No. If temperature increases, if it is a conductor, resistance will increase. If it is a semiconductor, then the resistance will decrease. Why? Because for a conductor, collisions will increase, so resistance will increase. For semiconductor, electrons will jump into the conduction band, thereby increasing the conductivity, lowering the resistance. Hence, the correct answer for this is increases for conductors but decreases for semiconductors. I hope this is clear. In half wave rectification, if the input frequency is 60, then the output frequency would be half wave. Half wave, input is 60, output is also going to be 60 only, there will be no change. Only in the full wave, the answer will be 120. Because in one cycle, you will get 2 cycles, full wave. Both the cycles get rectified. In half wave, in that entire positive negative cycle, only the positive cycle gets rectified. Every cycle, positive cycle is there. So the frequency is still going to be the same. Many people think half wave means half of 60, so answer will be 30. No. Remember the diagram. Yes. Do you see, guys, a lot of questions are there from semiconductors, a lot of questions are there from current electricity, electrostatics, even electromagnetic waves, decent questions were asked. You can see AC, again high weightage chapter in 12th standard. Modern physics, again high weightage, but semiconductors and logic gates like really high. One chapter they are asking so many questions. That gives you a good idea of what you should prepare, what you should avoid. For the following circuit, the truth table is going to be, there is no other option but to do it properly, nothing else you can do. So you do A, I think A bar is also there somewhere. Then here this is, what is this? A and B. A dot B bar is there. This is A dot B and bar because of the knot. This is A bar dot B whole bar. So you have A bar dot B whole bar. And lastly is AND of it. That means you do this and you get the final output over here, which is C. So this is your truth table. So you just have to write as much as possible. So starting with 0, 0, 0, 1, 1, 0, 1, 1. This is A bar. So 1, 1, 0, 0. Exactly negating that. So A dot B bar. This and this. 0 and 0, 0. Bar of it 1. 0 and 1, 0. Bar of it 1. Yeah. 1 and 0, 0. Bar of it 1. 1 and 1, 1. Bar of it 0. Here A bar dot B. A bar dot B. So 1 and 0, 1 and 0, 0. Bar of it 1. 1 and 1, 1. Bar of it 0. 0 and 0, 0. Bar of it 1. 0 and 1, 0. Bar of it 1. Now you have to take the dot of it. The dot again means AND. 1 and 1, 1. 1 and 0, 0. 1 and 1, 1. 0 and 1, basically 0. So 1, 0, 1, 0 should be the answer. Just check this. 1, 0, 1, 0. Yes, that is the correct answer. Is that clear? 1, 0, 1, 0. So that is the way, only way to do it. Don't use any random shortcuts out there. Okay, cool. So let's move on to the next question. I'm showing you all the solutions. I'm not skipping one question also, guys. It's not like, oh, this is simple. Okay, do it. I'm showing you all the solutions. And why did I show the answer again? Anyways, consider the following statements A and B. Identify the correct answer. Zener diode is connected in reverse bias when used as a voltage regulator. Yes, definitely. It is used. See, Zener diode questions, so common. They love Zener diodes. I think NTA people dream about Zener diodes in their sleep, even in day, every time. Potential barrier of PN junction lies between this and this. So guys, this potential barrier of PN junction 0.3 and 0.7, around that range, right? I think this is slightly wrong value. This is slightly wrong value. Yeah. So this value is not 0.3 and 0.7. This is slightly on the higher, lower side. Actual values are slightly higher. So that's why statement true is false. Okay. So that is the wrong part. So A is correct, B is incorrect. Moving on to the next one. Electron concentration in N-type is same as the hole concentration in P-type. External field is applied, crossing them. Compare the currents. What a brilliant question. See, concentration of electrons in N is same as concentration of holes in P. So, compare their conductivities. You might think, sir, concentration of holes and electrons is same, so the currents will be same. But do not forget the mobility. Mobility of electrons is much higher than the mobility of holes. So even if number of electrons is equal to number of holes, the current because of the mobility in the electrons or N-type will be more than the current because of the holes. Hence, you will see the current in N type is more than the current in P type. Extrinsic semiconductors. It's only because of mobility, meaning how easily the electrons can travel. Very good. Moving on to the next question. Guys, coming up on your screen. Graphs are given. Question is, what would be the output in this particular scenario? You just have to take few cases and you will get the answer. It is not that difficult. Check this out. First case only, let's take. This is 0, this is 0, this is 1. This is 0, this is 0, this is 1. This 0 goes over here, 0 and 0 gives you 0. This 0 goes over here, 0 and 1 gives you 0. NAND of it gives you 1. This is OR gate, 0 or 1 will give you 1. So 100% the output should be high. 100% the output should be high. Everybody with me? Very good. So either, what is this? Option 1 has gone out. Option 2 also has gone out. Either 3 or other 4. Either 3 or 4. Okay. Now go to the next part. This is 1. This is 0. This is 1. This is 1. This is 0. And this is 1. 1 and 0. What is 1 and 0? 0. 0 and 1 is 0, but negation is 1. So 0 or 1 is going to be 1. Oh, so the output has to be high. It is 1 here. Oops, sorry. It is 1 here, but it is 0 here. That is the problem. Oops. That is the problem. This can't be true then. This can't be the correct graph. So the correct graph has to be 3. Don't even have to check the other lines. Answer will be 3. Option 3. So constant voltage of 5 volt is coming. Such a surprising question came. Imagine to mark this, you would take so much of pain or effort, or you would not get the confidence, because you will be like, how can it be a straight line? Something I must be doing wrong. Okay. But this was asked in 2021. The answer is a straight line. Crazy question being asked. Crazy question being asked. Okay. Did you understand how we did it? We just checked the first 2 times. This, what is this? Suddenly there is a spike, spike, spike. That spike doesn't make sense. 2 we ruled out in the first, values only. Second part we ruled out in the second time frame. We got option 4 is eliminated. So automatically option 3 is correct. You have to do these questions via elimination. The increase in the width of the depletion region in a PN junction diode is due to, come on, theory based question. The increase in the depletion layer's width, where does it happen? When you are reversing the voltage, reverse bias, right? Forward bias, the depletion layer gets destroyed and there is a surge of current after the new voltage. So it is reverse bias. In forward bias, the depletion layer decreases and suddenly there is a surge, correct? So reverse bias, the depletion layer increases, the current cannot flow so easily. The logical circuit truth table is, I think this is again De Morgan. The moment I see such things, I immediately think about De Morgan. This is A bar, this is B bar. This is A bar, this is B bar. This is OR gate, and this is a NOT gate. So OR the operation, OR means plus, and then put complete bar because of the NOT. What did I tell you? If there is a common roof, separate the roof. If there is plus, make it a dot. Whatever is there inside, put a bar of it. Oops. Yeah, whatever is there inside, put it as it is and there is a bar of it. And whatever is there inside, put as it is and there is a bar over it. Correct. So A bar bar is A, B bar bar is B. So this is nothing but, an AND gate. Why did I put it plus? Sorry, A dot B. This is a AND gate. This is a AND gate. Finally, let's see, where is it? Answer. Yeah, this is a AND gate. Yes. This is the AND gate. Everybody knows the truth table of AND gate. 0, 0, 0, 1, 1, 0, 1, 1. What is the final answer? 0, 0, 0, 1. That is the truth table of a AND gate. That is what exactly is written over here. NEET 2020 question. This is NEET 2019 question. Come on, my dear warriors. What do you think is going to happen here? The correct Boolean operation is Is it or, is it NAND, is it NOR, or is it AND? Okay, let's take few options here. This is A, this is B, and this is off, this is also off, then this is on, this is off. Whatever happens for this will happen exactly reverse also, off and on, and then both the switches are on. So what will be the LED output is what we have to see. What will be the LED output? Okay, let's see. If both are open, if both of them are open, the current will go through this, through the LED, through the resistor in this. Correct? Everybody with me in this? Right? Very good. So I think the LED will glow. It will glow 100%. It will glow. Okay. If one is on, one is off. If this is on and this is off, the circuit is still broken. The current can't go here, no? Because it will be stopped at this point. So still the current will go like this. Correct? Understood? So it will still glow. If this is off, this is on. Let's say this is on, this is still off. How can the current proceed? It can't. The circuit is broken over here. So nothing will happen. The LED will still glow because the current is still going through this LED only. So it will still glow over here. What about both are on? If both are on, then this is like shorting it. It will bypass and it will go like that. No current in the LED. No current in the LED. It will be off. Which kind of gate is this? 0, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1, 0. I think this is a NAND gate if I'm not wrong. This is a NAND gate. Yes, it should be NAND. Option B. Yes, it is correct. It is a NAND gate. Very good. B for biology. Proud of all of you. Proud of all of you. Next question. The P-type semiconductor, which of the following statement is true? Holes are majority carriers, trivalent atoms are the dopants. Okay, direct theory question. Holes are majority, pentavalent atoms are the dopants, electrons are the majority, pentavalent atoms are the dopants, electrons are the majority, and trivalent atoms are the dopant. When I say P-type, that means it has to have holes, and hole means deficiency of an electron. So definitely it will be a trivalent atom. Trivalent atom like aluminum example, it can't make bonds on all the four sides, so it makes a hole over here. So it is trivalent atom with holes as the majority carriers. Yes, perfect. That is option A, 2019 question. Theory based questions are so common in this. Oh, we are done. Guys, 667 pages, yeah. Come on. This is insane. I'm writing it here. I don't have the next slide. Like, subscribe, and share. You'll be thinking this is like Chumma Sir shares. But guys, really I need it. If you have to bring more sessions for you. When I say subscribe, why do I ask you to subscribe? Because the next session, at least you know when it is. It shows up in your feed, or else you'll lose track of it. You will lose, which was the channel? I forgot. What is the name? Not able to find. Not able to find the video. Subscribe. We have to make this community stronger. It's for you. It's a pure NEET channel in English. Why do I ask you to like? Because YouTube understands you love watching NEET videos. It will show you only NEET videos, or you will get distracted. It also supports us. It shows that you are loving us. So make sure that the algorithm is set right, or else random videos will pop up on your YouTube feed. You will only be distracted. I am asking you to share this, not just by hitting the share button there, but also when you go to your school, college, classmates, whatever, talk about this channel. This is the #1 NEET English channel for all of you. So it's for you, and whatever you say, we do it over here, whatever is your demand, and we take care of you just like you are, with us over here, even though we might be very far away, right? So guys, this bond is very important and we want this family to grow, so share it as well. So we are completed almost the 6 years papers. No, I won't even say almost. We have completed the 6 years or rather 5 years 6 papers of all the NEET question papers of physics 11th and 12th. Watch all the videos properly. Next lecture is by Diksha ma'am, organic chemistry. The questions which are left out will be done there. It's going to be 2 to 3 hours class, so be prepared for it. Take a nice break. You will be seeing Diksha ma'am very soon. Okay, take care guys. This was Captain Shreyas and I'm signing off. Bye bye. Captain Shreyas signing off. Hasta la vista.